Hello, people. Welcome to the session. I'm Rachita Sachdeva, your chemistry teacher, and I hope you all are doing awesome, blossom. Do let me know in the chat box if I'm visible and audible clearly to you guys. Come on. Quickly, do let me know in the chat box. Am I audible and visible? Give me a thumbs up. Hi, Aryan. Hi, guys. Hi, Lakshmi. Hello. So, how are you all? How's the Josh? Hi, hello, hello. Hi, Pudam. Hi, Priya. Rehana, hello. Super good to see you all finally live. Hi, Yuvika. Tejasvi, hello, good morning, Naman. Good afternoon. Yes. Oh, that's so sweet of you, Netik. All right, guys, without any delay, let's get ourselves started. Before we start, let me tell you that please settle down and do not stress yourself. We'll be together for a long time today. I hope you all are ready. I would just like to tell you to keep a pen and paper handy, keep a water bottle with you, and sit into a space where you can focus completely. Because we will be finishing up entire chemical lota, entire chemistry today, and you will be all set for your board exams. So I hope you are all set to go. Yeah? How's the Josh? Do let me know in the chat box. How is the Josh? How are you feeling? Exams are nearby. 2nd of March, you'll be having your board exams, which are quite near. Yeah? Oh, that's so sweet, Naman. Hi. Those who are saying me Hindi, guys, it's a pure English one. So, yeah. Sorry, that won't be in Hindi today. Feeling tense, no, you should not feel tense. Yeah, I understand, it's a human nature. We all get tense, we all get stressed, but yeah, we have to surpass that. We are so close to the victory line. We cannot give it, we cannot give it at all. So do not give up. Give your best and make your parents proud as well as yourself proud. Yeah. All right, chaliye, let's begin chemistry session, complete marathon. So I hope you all are ready to be with me for the entire day today. What happened? Why it's got stuck? Oh, just a second, guys. Uh-oh, it's a good start. Just give me a minute. Stuck. Stuck. Slides are stuck. Yeah, don't worry. It's a good start. Yeah, guys, there is a bit Alright guys, so we are back with a bang. So there was little glitch, technical glitch that we have already sorted. So I think we all are ready to begin with our session. So as I was saying, we are starting up with chemistry and we are completing all 4 chapters today all at once, starting up from chemical reactions and equations, second acid bases and salts, third metals and non-metals, and fourth carbon and its compound. Again, sit tight with your pen and paper, take sips of water in between, keep yourself hydrated, and yeah, good to go. Yeah. Hmm. Yeah. Hmm. All right. Alright guys, so you are so close to your victory as I told you, and we cannot give up right now. So let's begin with chemical reactions and equations. Try there for day. Alright guys, so before we start with chemical reactions and equations, I will be giving you the entire concept revision. Along with that, we'll also be doing questions in between. So be ready for the questions. We will be solving important question in the entire marathon in between the concepts, so that you will revise your concepts as well as you will get to know that how questions do come in your paper and how you have to handle those questions. In between, I'll be providing you some strategies for your board exams, so that you will not going to lose even a single mark and will be able to gain full marks in your paper. Alright guys, so what are chemical equations? What are chemical reactions? Is there a difference between chemical reactions and equations? Let's check it out. See, chemical reaction is just a process. What process? Of breaking of old bonds and formation of new bonds, where the entire new substance is created, is what we call it as chemical reactions. Now, to showcase those chemical reactions, we require symbolic representation. We require to showcase on paper, and this is where chemical equations comes into picture. So, chemical reaction is just a process of breaking of old bonds, formation of new bonds, whereas chemical equations is a symbolic representation to show the chemical reaction, to show the entire process. For example, what happens if we burn magnesium ribbon in air and that results into formation of what? A new substance. What is that? It's a white color powder of magnesium oxide. But how do we show that on paper? For that, we have chemical equations. Magnesium reacts with O2. Symbol of magnesium is Mg. Now, the basic mistake that you guys do is writing oxygen as an atom. So, you should not write O as an atom here, because oxygen as an atom does not participate into a reaction. It participates in form of air, and air is oxygen molecule. So magnesium reacts with oxygen molecule, that results into formation of magnesium oxide, which is white color powder. There are so many chemical lochas, so many chemical reactions going on around you. Starting up with your tummy, starting up with your respiration process, plants ke andar, there is photosynthesis reaction going on. In fact, fermentation of grapes. What happens when grapes are fermented? They turns into wine, which is alcohol. So grapes are fruits. Wine that has been produced after a lot of chemical changes has turned into an alcohol. So go and ask your parents, Mama, can I consume wine? You'll get a flying chappal from there. But if you ask your parents, can I consume grapes? They'll be more than happy to see their children eating fruits. So there is a huge difference between grapes and wine because of a whole lot of chemical changes, whole lot of chemical composition changes that has happened. So there are a lot of chemical processes going on around us. Along with that, there are physical changes also happening around our environment. Cooking of food, chemical change. Photosynthesis, chemical change. Car rusting, chemical change. Manufacturing of medicines, coal burning, frying of egg. So all of these examples are of chemical change. Now, as we are talking about change, what is a basic difference between physical change and chemical change? See, chemical change, we are very much clear when there is a complete change in the chemical reaction, complete change in the chemical composition, and a new substance is created, is called as a chemical change. Whereas physical change means when there is no new substance formed, when there is no chemical composition that has changed, is called as physical change. So let's take a look. Physical change is a temporary change, whereas chemical change is a permanent change. They could ask this question for 2 marks. Probability is less, but you should have an idea about how to represent this answer. Alright, so they can ask you this question to state a difference between physical and chemical change. Or they could put up this part in your MCQ, section A, where they will give you some examples and they can ask you which is chemical change, which is considered to be as a physical change. Now, in physical change, no new substance is formed, whereas in chemical change, a new substance will be always created with the change in chemical composition. Like burning of fuel, explosives are chemical change. I've given you a simple example of fermentation of grapes, digestion, respiration, photosynthesis. All of these are the examples of chemical. Melting of ice or melting of ice cream, boiling of water, evaporation of water, all of those are the example of physical change. In fact, if we cut a wooden log is being cut, it will cut into smaller pieces. It will be broken into smaller pieces. So that small piece is also a wooden characteristic, as well as a wooden log will have the wooden characteristics. So that doesn't matter. Wood will remain wood if it's into a wooden piece of a big log or into a smaller chunks or dust. So that is an example of none other than physical change. All right. So now, as we are talking about chemical reactions, chemical changes, how will you be able to determine and identify that how chemical changes are actually happening? So guys, there we have characteristics of chemical reaction. It comes to your paper for 2 marks again, where they could ask you to state 2 points or 2 characteristics of chemical reaction, or how will you determine that chemical reaction has taken place? What is a proof? How will you get to know? So there are few things that you need to observe. Number 1, if there is a change in state, it is considered to be as a chemical reaction. If there is a change in color happening, that means there is some chemical locha happening there. There is definitely a chemical change happening somewhere or the other. Third, if there is the evolution of gas, if there is a change in temperature or formation of precipitate, if you find any one of these characteristics, that determines, that actually prove that chemical reaction is taking place. In fact, there are some examples where you can find all the characteristics in one. Can you give me that example? Give me one example, one chemical reaction where you will going to find almost all the characteristics in one. Come on, let's see. Okay. All right. Come on, guys. Just one example. You can do it. All right, Ethik. Lead nitrate. Don't you think so? Lead nitrate is one of the best example we can quote. PbNO3 whole twice on heating, that gives you lead oxide plus nitrogen dioxide plus oxygen. See, what happened before reaction? This salt was white in color. But after heating, it changes its color and turns into buff yellow. Or you can also mention simply yellow color. That's perfectly okay. Along with that, it produced reddish brown color gas, which is, or reddish brown color fumes of nitrogen dioxide. In some of the books, you will also find brown fumes. So you can mention anything in your paper. Both of them are acceptable. Either you mention reddish brown fumes or brown fumes, that's absolutely fine. Along with that, oxygen gas, which is a colorless gas, is also evolved. Now look at the characteristic. Is there a change in state happening? Yes. It was solid earlier. Later on it turned into a gaseous state also. So yes, there is a change in state. There is a change in color. Evolution of gases happening. Change in temperature has taken place because it's the endothermic reaction. So definitely most of these characteristics have been compiled in one example. So this particular reaction comes for 2 to 3 marks, and please mark this as a very, very important reaction. Guys, trust me, this particular reaction has been repeated in your past year papers, in many papers. They'll come up with this reaction. They make questions in some in one form or the other, but they completely dependent upon this particular reaction. Cool? Give me a thumbs up in chat box. Come on. Cool, cool, cool. Understood? Sorted? Okay. All right. Rather, you will be with me for almost half of your day today. Great. Amazing. So this particular reaction has shown almost all the characteristics. That is super duper important reaction. Now talking about change in state, there is not just one reaction, there are many reactions which actually show the change in state. One of that, what we have seen, was lead nitrate on heating. Precipitation reactions are also a part of change in state. So you can quote any precipitation reaction under this, as well as ammonia, if it's reacted with HCl, both in gaseous form, that results into formation of ammonium chloride, which is solid state. So there are ample number of reactions and examples which you can quote under a characteristic of change of state. State could be solid, liquid, gas, aqueous, and so on. Change in color. The best and the most common favorite example of all, when iron nail is dipped into blue color solution of copper sulfate. You get 2-mark question from this particular reaction asking, what do you observe? What happened when iron nail is dipped into solution of copper sulfate? What do you observe? Change in color. How change in color will happen? So iron, being more reactive than copper, will displace copper from its position and turns into ferrous sulfate, which is FeSO4, and copper will be displaced and sitting out alone. So iron will kick out copper from its position. Blue color of copper sulfate will eventually turn into pale green color of ferrous sulfate. Brown color of copper will be deposited onto the surface of iron nail, slowly and gradually. And there are other examples also. Again, lead nitrate example can be given. White color salt on heating will going to turn into a yellow color lead oxide with the evolution of brown color gas of nitrogen dioxide and so on. So there could be again n number of examples under this category, under this characteristic as well. Evolution of gas. So if you see evolution of gas, that means definitely there is some chemical locha happening. There is a chemical change happening in that particular reactant. That means some old bonds will be broken and new bonds will be prepared with the formation of new products. Now, for example, if metal is reacting with Dilute acid. That definitely results into a formation of salt and hydrogen gas. Not only that, if metal carbonate or bicarbonate is reacting with the acid, dilute acid, that also results into formation of gas, and that is carbon dioxide along with water. So you can write any of these examples. Metal reacting with HCl, acid like zinc reacting with HCl, sodium carbonate reacting with H2SO4, that always results into a formation of carbon dioxide gas. And this is the most important one, which I've already quoted before. When lead nitrate is heating, undergoing thermal decomposition reaction results into a reddish brown color gas. I hope you have done this in your labs also. Yeah. I hope you guys did this in your lab. So this brown color is so hard to remove. Once we do this in lab, no, our teachers ask us to clean it before we leave the lab. I don't know if you have gone through such child labor or not, but yeah, we did. So in lab, we used to clean our own equipments. It is so hard to remove. This stain remains like for 2 to 3 days. You have to like wash it again and again to remove nitrogen dioxide gas. So I think if you want to punish someone, ask them to remove nitrogen dioxide stains. Alright, jokes apart, moving on to next characteristic, which is change in temperature. Now, reactions like endothermic or exothermic reactions, you can put under a category of change in temperature. Like this one, which is again very important for your exam point of view, calcium oxide, which is called as quick lime. In Hindi, we call it as chuna. Chuna, chuna. Tuna. So yeah, quick lime, once you add it into water, that results into formation of slaked lime, which is called as lime water, and that is calcium hydroxide. Along with that, heat is evolved. There are a large amount of heat is evolved during this reaction, so it is exothermic. In fact, thermal decomposition reactions can also be the part of change in temperature. You can put those examples under this category as well. Clear, boss? Sorted? Alright, formation of precipitate. So obviously, double displacement precipitation reactions will show such kind of characteristic. Like for example, NaCl in its aqueous state reacting with silver nitrate in aqueous state, there would be a double displacement reaction here where silver will take a place of sodium, sodium will take a position of silver, results into a formation of NaNO3, which is a byproduct, completely dissolved aqueous state, whereas AgCl will be precipitated out. Can you tell me what is the color of this AgCl precipitate? Come on guys, you can do it. What is the color of AgCl as a precipitate? Awesome, Lakshmi. High five. Good job. Yes, absolutely. Superb, superb. It will be definitely white in color. Yes, Suryansh. Cool, 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 cool. So this is white color precipitate. Those who are saying yellow, it's for lead iodide. Please mind it. You have to remember the colors of the precipitate. That's mandatory for you to mention in your paper. If you do not mention the color of precipitate, you will definitely going to lose marks, approximately half marks there. Yes, white is the right answer. Good. Well done. All right, guys. Now, as we discussed about chemical reactions and chemical equations are a simple representation of a chemical reaction, right? But how do we represent it on paper? There are various ways by which you can represent chemical equations. Like, for example, you can represent chemical equation in word form. You can either do that in a skeletal equation form or a balanced chemical equation. But question arises, what do we do in exam? Which particular representation is to be mentioned in board paper? That's a big question. Now listen to me very carefully. Word equations to be written only if it is asked in the question. I'll repeat this part. You will use word equations only if it is asked in your question. Otherwise, you will not going to mention word equation. Okay, it's a waste of time. Secondly, what is skeletal equation? Skeletal equation means you will give a proper representation, symbolic representation, but in unbalanced form. Without balancing, if you write the equation properly with proper symbols and molecules, that is called as a skeletal equation. In short, unbalanced equation. Third way to represent is balanced equation. This is something which is considered to be complete answer. Please mind this thing. In exam, you will never leave your answer unbalanced. You always have to balance the chemical equations in your paper by default. Whether it is asked or not asked, you will going to balance the chemical equation. Otherwise, you will going to lose marks. Clear, boss? I hope it is clear. So your answer will be considered complete only if you balance the chemical equation. Now, what is balancing? Why we always have to balance the chemical equation? Do let me know in the chat box. Why it is necessary to balance the chemical equation? Come on. Why always we need to balance chemical equation? To follow, to obey who? Which law do we have to follow? Absolutely, Vishesh. High five. Good job, Vanshika Lakshmi. Yes. To obey the law of conservation of mass. Perfect. See, law of conservation of mass is given by whom? Your father. You know whom? Father of chemistry. And we all know that if we do not obey our father, we'll get flying tupples. So, it's better to obey your father of chemistry, Anthony Lavoisier, and always balance the chemical equation. Now, while we are balancing the chemical equation, we have to equate the total number of atoms on LHS of the arrow and RHS of the arrow. So, on left hand side, number of atoms should always be equal to the total number of atoms on right hand side. Then only it will be considered as complete. So on that positive note, we have a question to solve here. Come on, guys. If iron reacts with steam, that gives ferric oxide plus hydrogen gas is evolved. Again, if iron, red hot iron, is reacting with steam, that results into a formation of what? Ferric oxide. I will come to this later also. Plus hydrogen gas will be evolved. How will you balance it? So there is a simple trick that you should follow for your paper. Always balance metals first. This is a simple trick. Follow the sequence and you will be free from all the mess. You will be able to complete your answer quickly. Always balance metal first, then balance non-metals except oxygen and hydrogen. Third, balance oxygen, and fourth, hydrogen. Right? Always balance metal first, then non-metal except oxygen and hydrogen. Now it could be sulfur, it could be phosphorus, chlorine, bromine, iodine, fluorine, and so on. So which metal is here? Iron. Okay. Alright. Is there a non-metal except oxygen and hydrogen? No. We'll skip this part. Is there oxygen here? Yes. Is there hydrogen here? Absolutely yes. Now, how many irons are there? Here it's 1. On the other side it is 3. How many oxygens are here? It is just 1 oxygen atom. On the other side they have 4 oxygen atom. How many hydrogens are here? 2. On the other side, how many hydrogens atom? 2. That means there is some differences in number of atoms here. So we need to equate it. Starting up with iron. So if we multiply this 1 with 3, we'll get 3 iron. That will be equated. So let's multiply iron with 3. Irons are sorted. Clear? Now, moving on to oxygen. How many oxygens are here? 1. On the other side it is 4. How we can make it 4? By multiplying 1 with 4, we can make it 4. So oxygen will be multiplied on the front side, not on the back side. All right. So now, unfortunately, as we have equated oxygen atoms, unfortunately, we have disturbed total number of hydrogen atoms. So now hydrogens are 4 into 2, 8. Now, by which number should I multiply 2 with to make it 8? By which number should I multiply 2 with to make it 8? 4? Yeah, I should multiply it with 4. And that's it. Done and dusted. So this is our final equation. 3Fe plus 4H2 gives you Fe3O plus 4H2. Cool? Cool, cool, cool. What to learn the colors of PP formed in a reaction? Ansh, you have to learn the colors. They're very specific colors. So you have to like learn them. Okay? Hi, Tane. Cool. Cool, cool, cool. So I think this is sorted. First, you have to balance metals, then non-metal if it is there. Otherwise, you can skip. Then oxygen and then hydrogen. We did this. So your final answer will be 3Fe plus 4H2 gives you Fe3O4 plus 4H2. This is your completely balanced chemical equation and you will get full marks for this one. Alright guys, are you ready to solve some questions? Ready, steady, and go. Keep your pen and paper handy. Yeah. No, you cannot use black pen in your boards, Jayashri. No, only blue pen. Yeah? Ready? All right. Okay, then. Let's move on. Let's practice few questions. You have to balance this first reaction. Aluminium plus HCl gives you aluminium chloride plus H2. Come on. I'll give you 30 seconds. More than enough, or 45 seconds. Chalo, let's have 45 seconds. I'm just giving you a timer. That's it. Tejasvi, happy birthday. Okay, I'm already getting some answers here. Let's see if it's right or not. All right, 2623. 2623. That's your answer. Let's see. Okay. All right. All right, guys. So as you have given me the answer is 2623. 2623. Let's see if it is right or not. Aluminium reacts with HCl. That gives you aluminium chloride plus H2. Alright. So first we have to balance metals. Then if there is a non-metal like chlorine and then hydrogen. How many aluminium? 1. On the other side it is 1. Chlorine, it's 1. On the other side it is 3. Hydrogen, it's 1. On the other side it is 2. So better we start with chlorine because aluminium is already balanced. So we will not touch it. Now, chlorine. How to make chlorine as 3 atoms? By multiplying this with 3. Now, unfortunately, we have made this 3 also. Now, what to do? There are 2 of hydrogens on that side, on right hand side, and 3 of hydrogens on left hand side. So, why not to multiply this with 3 to make it 6? So, we have multiplied this with 3. Yeah, total 6. On this side, to make this 6, I have to multiply with 6 here. Completely with 6. So now my chlorines are also 6. 3 into 2, 6. Now how to make 6 chlorine on right hand side? How will I do it? By multiplying this with 2. That will give me 6 chlorine. So I'll multiply this with 2. Aluminiums have been changed now. So now there are total 2 aluminium. How will I change this? By multiplying it with 2. So it is hit and trial, hit and trial. Go forward, come back, go forward, come back. And do it till every atom is equal on both these sides. So it's 2 aluminium, 6 HCl, give you 2 AlCl3 and 3 H2. Well done. Hats off to your performance. Those who have given me this as an answer, well done. Congratulations. Good. Very good. Awesome blossom. All right, guys, solve this one. This is your homework. Zinc sulfide reacts with O2, give you zinc oxide plus sulfur dioxide. That's your homework. Do complete it and let me know in the chat box. Oh, again it got stuck. Yeah, alright. Just give me a minute, guys. It got stuck again. Stuck again. Stuck. All right, guys. Am I audible and visible to you all? And I really apologize for these tech issues which is coming in between. Yeah, am I audible and visible? Give me a thumbs up quickly. Yeah? Okay. Thank you, guys. All right. So this is your homework question, and I could see some of you are actually coming up with the answer, which is really, really good. You are using this time very nicely and wisely. So good job. All right, guys, moving on to the next part. As you are writing chemical equations, many of you always have a question, always have this query, ma'am, or do we have to mention solid, liquid, gas, aqueous in a reaction? Will there be a deduction in marks if we do not mention solid state or aqueous state, liquid, gaseous state? So no. Answer is no, until and unless question asks you to mention the states of matter, you do not have to write it. If you remember, please go for it. But if you do not remember or you are confused, then kindly do not mention solid, liquids and gases or aqueous. If question asks you, they will definitely provide you some hints for you to write solid, liquid, gas, aqueous or any state of matter. Cool? All right. How to make a reaction more informative? See, you might have observed I've put an upward arrow after nitrogen dioxide. I've used a downward arrow for a precipitate. What does that mean? You always have to mention a downward arrow if there is a precipitate which settles at the bottom of a test tube. You should always mention the upward arrow for a gaseous state. Upward arrow means gas is evolving. It is going up. So this is the way you can make your reaction more impressive and more informative. Along with that, you can always mention the states of matter if you remember them correctly. Like for example, NaCl. Yeah, NaCl will be in aqueous state reacting with AgNO3 in its aqueous state. So I know that you do not remember everything. It's very much obvious you have not done everything practically. So in question also, they will give you some hints so that you will be able to mention these states of matter. So please do not take stress and worry about that, ma'am, will marks be deducted if we do not write? That's okay. Okay. So once this reaction will take place, that will form AgCl, which is a precipitate. And for precipitate, I'm using a downward arrow. Along with that, NaNO3 will be prepared as a byproduct, which is aqueous in state. Cool? Okay. Now, what else a reaction tells us? A reaction also gives us the information about the mass of reactant and product, number of moles of reactant and product as well. Now, please listen to this very carefully. If a specific condition is required to complete a reaction, it's mandatory for you to mention it. It's important for you to mention it, otherwise you will lose marks. For example, if a heat symbol is required for thermal decomposition, let's say lead nitrate on heating, that gives you lead oxide plus nitrogen dioxide plus oxygen. If you forget to mention that heat symbol, marks will be deducted. So conditions will be written above or below arrow, but it's mandatory for you to mention all the conditions wherever needed and wherever required. All right, so please keep that in mind. Cool. All right, guys. Now talking about types of chemical reactions. As you all know, there are different types of chemical reactions that you've learned. But on what basis? On the basis of breaking of bond. So starting up with the most simple type, combination reaction. Combination reaction is also called a synthesis reaction. And please make sure that you remember the alternative names. Otherwise, you will get into trouble in your paper. Because most of the time, they will ask you question based upon synthesis. And half of the students have no idea what does synthesis means. So you should always learn the alternative names. Combination reaction is also called a synthesis reaction. Second, decomposition reaction. Third, displacement or a single displacement or a replacement reaction. Then a double displacement. And lastly, it's a redox reaction. So we will be revising one by one, each one of them along with the examples. Starting up with combination reaction. What does combination reaction means? When two reactants combine together and gives you one single product is called as combination reaction. For example, hydrogen reacts with oxygen, gives you water. Carbon reacts with oxygen, give you carbon dioxide, and so on and on and on. All right? Now, there are other types of reactions also. Exothermic, endothermic. Exo, bolido means out, evolve, release. Exothermic, therm means heat. Exo means out or release or evolve. Right? So exothermic reaction, whenever we are diluting the acid, it's exothermic. Neutralization reaction is also exothermic. When you add water to quicklime, that is calcium oxide, that's highly exothermic reaction. Lot amount of heat will be released. Endothermic means when heat is absorbed to give product or to form the products, that's called as endothermic reaction. So endo means absorb, in, therm means heat, and we show the heat with a symbol of triangle and we call it as delta. It's a shortcut way to show heat. That's a symbol of heat. Alright, like for example, boiling of water, you require heat. Evaporation of water, you require heat. Melting of ice, we require heat. All thermal decomposition reactions, like again, calcium carbonate on heating will give you calcium oxide and water. So this calcium carbonate or limestone requires heat, absorbs heat to give you several products. That's endothermic reaction. Clear, boss? Cool. All right. Amazing. Chale. So as we were discussing combination reaction, two reactants combined together give you one single product. It's also called a synthesis reaction. Now listen to me very carefully. How questions land up in your paper? How will they be asked in your exam? They'll give you some reactions. They can ask you what type of reaction is this. Second type of question, match the following. They'll give you two columns. In one, they'll provide you reactions. In other column, they'll give you a type of reactions. And you have to match up those reactions with their types. Third question, what they can give, they'll give you hint. Like for example, XYZ question. Guys, listen to this carefully. These are most lovable hot questions of your board exams. So they were going to ask you a question like there is a compound X, reacts with water, produces a compound Y. Along with that, heat is evolved. Compound Y, when reacts with carbon dioxide, turns it milky. Yeah. Now identify X and Y. Write a balanced chemical equation. What is the type of this reaction? So easily such kind of questions can be of 3 to 4 or maybe 5 marks also. So please be ready for such questions. What is X here? X is calcium oxide, which is quicklime. When added with water, will make lime water, because whenever you will add lime water along with carbon dioxide, it will turn it milky. So you got a hint. You already got a hint from Y that it's calcium hydroxide. So if it's calcium hydroxide, water has been given to calcium oxide, that evolves heat. It's exothermic as well as it is a combination reaction or a synthesis reaction. That's a hot question of your board exams. All right, moving on to decomposition reaction. Now, decomposition is not a reaction which happens without condition. Like for example, you need to bribe the reactants. You need to fulfill their conditions so that they'll give us some products. So some of you might be bribed at home. If you get good marks, you will get so and so thing. If you will get this much percentage, I will bring so and so thing to you, or we'll go on a trip. Am I right? Have you been bribed like this at home? Get 90%. I'll give you this. Whatever you want. Yeah. I know that. I think everyone gets such kind of bribe at home. So, we need to bribe the reactants in decomposition reaction. We have to fulfill certain conditions for a reactant to provide us product. Now, conditions are, it could be heat, right? It could be heat, so it will be thermal decomposition. It could be a sunlight provided to them. That's one condition to give product. It's called photolytic decomposition. And thirdly, electricity. If electricity is provided, in presence of that, a reactant is decomposing, breaking, and giving us simple products. It's called as electrolytic decomposition reaction. Now, the good part here is you have very specific examples to learn in your board exams. So please make sure that you do not miss out on any of the reaction given in your NCERT. Starting up with a decomposition which is carrying out in presence of heat. That's called as thermal decomposition. One reactant, single reactant, will be chopped, break down into simpler products. For example, calcium carbonate on heating will give quicklime calcium oxide and carbon dioxide. Cool? Cool. Similarly, we have one more. The most important example we are doing since the start. Lead nitrate on heating give you lead oxide plus nitrogen dioxide gas plus oxygen. I have one more very important reaction to discuss that might come in your paper this year as it is. So please listen to that very, very carefully. This particular reaction can come to your board paper as well. And that is decomposition of ferrous sulfate. Now they can ask this question for 4 marks also, 2 marks also. So you have to mention it in 2 steps. What is ferrous sulfate decomposed to? It will be ferrous sulfate heptahydrated. This is what? Green vitriol. Green vitriol on heating results into formation of white color, dirty white color powder of anhydrous ferrous sulfate with the loss of 7 water of crystallization. Now, on continuous heating, on continuous thermal decomposition, this ferrous sulfate will result into formation of red color. Sulfur smelling gases will be evolved, which is sulfur dioxide and sulfur trioxide. Clear, boss? This is very, very important reaction for your exam point of view. You always have to show this decomposition in 2 steps, starting up with green vitriol on heating. That will going to form anhydrous ferrous sulfate, which on continuous heating will form red color or reddish brown color of ferric oxide, and sulfur smelling gases will be produced, which is sulfur dioxide and sulfur trioxide. Give me a thumbs up if it's understood. Come on. Cool? Cool. Happy birthday, ma'am. Kya baat hai bhai? It's not my birthday. Yeah. From any section, any section, Kunal. It's up to you. But do not mix 2 sections together. If you start from section A, complete it first and then move on to other section. Yeah. Okay. Yes, Rashiraj. Green color of ferrous sulfate heptahydrated turns into white color of anhydrous ferrous sulfate, which on further thermal decomposition results into formation of reddish brown color of ferric oxide and sulfur smelling gases. This is very, very important. Take a screenshot, learn it. Do not leave this reaction. All right, moving on to a second type of decomposition reaction. Again, a condition is required, and that's sunlight. In presence of sunlight, if a reactant is chopping down, it's breaking down, decomposing to give you further product, it comes under the category of photolytic decomposition reaction. Actually, tell me one thing. Which particular reactant on decomposing in presence of sunlight will participate in black and white photography? Come on. Give me the answer. Which reaction will participate in black and white photography? You might have seen black and white photographs of your grandparents, of your parents' wedding. Not that filter wala thingy on your phone. AGBR? Yeah? Yes. So it is AGBR, silver bromide, in presence of sunlight. This is the symbol of sunlight that we are using. You can simply write sunlight also. You can also mention sunlight, or this is a symbol, H nu. That will decompose to silver plus bromine gas. This particular reaction is used in black and white photography. There is one more example, AgCl, again in presence of sunlight, that forms silver plus chlorine. Now, what question comes from this reaction? They will straight away ask you 2-mark question. Why silver chloride is always stored in dark bottles? They could ask you this question. Why always silver chloride is stored in dark bottles? To prevent from decomposition reaction, to prevent it from decomposing to grey color silver and chlorine gas. Cool? Yeah. Yeah, Priyanshu, as time permit, I'll give you by the end of the session. Okay, guys. Moving on to electrolytic decomposition reaction, there is only one example which is there in your syllabus, and that is water. Water on passage of electricity that decomposes and gives you hydrogen gas and oxygen gas. Now, they could ask you questions like, give an example for electrolytic decomposition, balance it. One is this. Secondly, they can ask you where oxygen is evolved, where hydrogen is evolved. Third question they can ask is why hydrogen evolved is always in double amount as that of oxygen. That's the most common question of your board paper. Now, electrolysis of water or electrolytic decomposition of water is one of the same thing. In presence of electricity, when water is decomposed, that will going to evolve hydrogen gas and oxygen gas. Please mind it, oxygen gas will always be evolved at anode. Hydrogen gas will always be evolved at cathode. Clear, boss? Yeah? Cool. Yeah, slow one. It's a slow one. Okay? Alright. Now, why hydrogen is always evolved in double the amount as that of oxygen? Because of the presence of 2 hydrogen atom and 1 oxygen atom. It is in already double amount. So that's why the gas which is produced after decomposing will also be in double amount as that of oxygen gas. So that's the common question which lands up in your paper most of the time. Okay, this is displacement reaction, one of my favorite reaction. Displacement reaction, you might have seen cartoons in your childhood time. Have you seen cartoons? Yeah, how many of you have seen cartoons in your childhood time? So those who have seen cartoons can relate to this. What's happening here is a displacement reaction. A more powerful one will kicks out the less powerful one is called as displacement reaction. A more reactive metal will kick out the less reactive metal. That will going to give you displacement reaction. Now, what all questions can be landed up? They will ask you, what do you observe? Means color-based questions they will ask. Second, what happened type of questions will be asked from this particular type of reaction, that is displacement reaction. So A being more reactive displace B from its position, forms AC plus B. That's displacement. Alright. How will we get to know that A can displace B? How will you get to know that A is more powerful than B? We get to know by the help of metal reactivity series or activity series. So metal reactivity series, where metals are placed in such a way that they are in the order of decreasing reactivity. On the top, it is potassium, then sodium, then calcium, then magnesium, and so on. So they are gradually decreasing in their reactivity. So for example, zinc is reacted with copper sulfate. Copper is reacting with zinc sulfate. Tell me the products. Come on. Give me the products. Let's see. Yes, Priya, reactivity series. Good. Vanshika says that it will going to form zinc sulfate plus copper. And what about this one? Second, there would be no reaction. Are you sure? No change? Yeah, good job. Yes, there would be no change. So copper reacting with zinc sulfate, there would be no reaction, there would be no change. So you guys be better ready for such kind of questions also, because they try to trick you in question paper sometimes. So please make sure that you're using all the logics before you write the answer. Do not try to make a product in this one, because copper is less reactive than zinc. It cannot displace zinc from its position, so it's not possible. Whereas zinc, when reacts with copper sulfate, zinc being more reactive can kick out copper from its position. Blue color of copper sulfate will turn into a colorless solution of zinc sulfate, and brown color or reddish brown color of copper will going to settle down at the bottom of the beaker. I hope that is clear. Clear, boss? Lakshmi, there would be other non-metals also, because hydrogen shows properties of both metal and non-metal, and that's the reason we are keeping it in the middle of reactivity series. Okay? The reason why hydrogen is there, because it shows the properties of metals also, non-metal. It can gain electron as well as it can lose electrons. I think now it is clear. Okay. So this is the entire reactivity series, where top metals are most reactive, and as we are moving down, reactivity will gradually decreases. So more reactive metal can displace less reactive. So if I ask you aluminium reacting with calcium sulfate, is this possible? Calcium sulfate reacting with, calcium reacting with aluminium sulfate. Which is possible? Which reaction is possible? A first one or a second one? First is no reaction. Okay. Which one is possible? First or second? Second. Yeah, calcium is more reactive than aluminium. So definitely calcium has the ability to kick out aluminium from its position, whereas first reaction is not at all possible. Good. Cool. All right, guys, on that positive note, let's move on to double displacement reaction. Now, what is double displacement reaction? I personally call it as double dhamaka reaction, where two people will going to place, or two elements will going to take each other's position, exchange their position. So A exchange and go to C, and C will come at a position of A, that results into a formation of two new products. This is called as double displacement reaction. Now please note that there are two types of double displacement reaction. What are they? There are two types of double displacement. One is neutralization reaction. Neutralization is also part of double displacement. And next is precipitation, the most common one. Now, some of you ask me, ma'am, precipitation is always double displacement? Yes. Always double displacement or precipitation? No. It's not always. It's not like that the double displacement will always be precipitation. No. It can also be a neutralization reaction as well. What is neutralization? Now let's say NaOH reacting with HCl. Acid reacting with base is called as neutralization. Hydrogen will take a position of sodium and forms HOH. Plus, sodium will take a position of hydrogen. Exchange of ions is happening. That will form NaCl. And guys, HOH is nothing but it's water. Don't get confused. HOH is nothing but it is H2O. I can write it in form of HOH or H2. It's one of the same thing. Precipitation, as you all know, for example, lead nitrate, yeah, reacting with potassium iodide. What will it form? Come on, guys, you can do it. Come on, come on, come on. What precipitate will it be forming? What is the color of precipitate? No one to go. Yes, Kunal. High five. Good job. Just give me a color also. Good. Very well done. Arpit, absolutely right. Give me a color. Yellow. Yellow color of lead iodide will be formed, which is PbI2. All said, guys. You guys are doing super good. So yes, potassium nitrate will be formed. Lead iodide is a precipitate. So I will use a downward arrow. What is the color of precipitate? It is yellow in color. Cool. Awesome blossom. Now it's your turn. Will you be able to do it? Your turn, guys. Your turn. Answer this. On mixing sodium sulfate with barium chloride, dash precipitate barium sulfate is formed. What color? Let's do it. Let's do it. Sodium sulfate, Na2SO4, reacts with barium chloride, BaCl2. That forms barium sulfate as a precipitate along with sodium chloride. Now they are asking you the color of barium sulfate. Ouch! It's not yellow. Yes, it is. It is white. It is white. Good. So it will going to make white color precipitate of barium sulfate. Only lead iodide that you have learned is yellow in color as a precipitate. Okay, lead nitrate reacts with potassium iodide and then it will give you a precipitate of lead iodide. We just did it. We just did it. Come on. What is the color of lead iodide? Yellow. Yes, it's yellow. Cool. So yeah, you have just gained 2 marks, guys. Congratulations. 2 marks, all yours. All right. So as I told you, there are neutralization, which is a part of double displacement, and precipitation is also part of double displacement reaction. We are all very much aware about neutralization. You guys have already learned that in acid, bases, and salts. Neutralization means when acid reacts with base, neutralizes each other's effect, forms salt and water, is called as neutralization reaction, which is again a part of double displacement. Now, one thing which you guys are mostly not aware about is exothermic part. This is again a hot question of your paper. Nowadays, in 1 mark, section A, they sometimes ask an assertion reason question whether a neutralization and exothermic reaction, true or false. It is exothermic reaction, guys. Neutralization, exothermic reaction, it's so slow that you're not sometimes able to identify it. So you have to keep that in mind, that neutralization is actually exothermic reaction and it's also a part of a double displacement reaction. Now coming on to your most favorite one, and that is redox reaction. Tell me in the chat box how many of you are scared from redox reaction. Just give me a thumbs up. Are you scared from redox reaction? Are you not able to do questions related to redox reaction? Yes, Anamika. No, no. Oh, that's so nice. Yes, okay. Some of you are there who gets confused most of the time with redox. So I will be like, try to finish up that confusion today itself, because it's now or never. We are going to complete this redox reaction today, and I'm pretty much sure that you will be so much confident after finishing up this topic. You will definitely feel confident after this, because I'll be sharing some tips with you to solve questions related to redox. Please listen to this very carefully. That will help you to solve questions in your paper. Now, what is redox reaction? It's a mixture of two reactions. What's that? Reduction and oxidation. Reduction and oxidation, once we combine them together, it is called as redox reaction. Now let's understand them separately, right? Like photosynthesis is a redox, respiration is a redox reaction, rusting, combustion, aag laga denge, anything burning is also a part of a redox reaction. Now what is the way to solve questions? Is this table. Guys, this table can help you to solve any kind of redox questions in your paper. Listen to me very carefully. Once you get your answer sheet in your paper, once you go to your exam room, you get your answer sheet, you start writing in your answer sheet if there is a question related to redox reaction. At the end of your answer sheet, it's a simple advice, take it. At the end of your answer sheet, try writing these points. Keep it ready. So whenever you are solving redox question, this part will going to help you to solve question in no time. You don't have to break your flow in between. You should never break your flow in between. So be prepared with some pointers, and you can mention it at the end of your answer sheet, so that while solving the questions, you don't have to stop in between, right? So what is oxidation? What is reduction? Let's compile it in one table, and you can mention this table by the end of your answer sheet also. If you see add of oxygen or loss of hydrogen, it's oxidation. If you see loss of oxygen or add of hydrogen, it's reduction. Now guys, please play smart. Learn any one of it. Either learn oxidation or learn reduction reaction. Do not try to learn both of them. That will going to confuse you completely. So as they are completely opposite from each other, just learn one part. Like oxidation, add of oxygen, loss of hydrogen. If the substance undergoing oxidation, it is called to be oxidized. The substance undergoing reduction is called to be reduced. The one undergoing oxidation is your reducing agent, which is also called as reductant. The substance undergoing reduction is your oxidizing agent, and it is also called as oxidant. The one which is undergoing oxidation will always lose electrons. The one undergoing reduction will always gain electron. And there is a simple trick to remember that. That's OIL, oil, and RIG, rig. What does that mean? That means reduction is gain of electrons. Oil, oxidation means L, loss of electron. That's a very simple trick. Now, removal of any electropositive or gain of electronegative element will be considered as oxidation, and complete opposite of that will be considered as reduction. Let's take an example. Let's see how we can use this table in exam. I will give you a demo for that. Let's take an example here. I will use the above table to answer all questions that can be asked in your exam. Now, for example, copper oxide reacts with hydrogen. That gives you copper plus water. Okay? Now, what all questions that can be asked to your paper? Number 1. Which substance is undergoing oxidation? Okay? This can be asked. Second, they can ask you which substance is undergoing reduction. Fine. Third, they can ask which is a reducing agent. Fourth, they can ask which particular substance is reductant. Fifth, they can ask, I'm giving you all the possibilities of questions here. Fifth, they can ask which substance is oxidizing agent, which is the oxidant here. Yeah, and yeah, that's it. They can also ask which substance is oxidized, and 8, which substance is reduced. Are you ready to answer all the questions? Are you ready to answer all the questions? Come on. Let's start. Let's begin. Ready, steady, po! All right, guys. So, oxidation. Hydrogen to H2O. It's add of oxygen. Yeah? Add of oxygen. I'm going back to the table. Add of oxygen. Oxidation. The one undergoing oxidation is oxidized. Okay? 2 points. Add of oxygen, oxidation. The one undergoing oxidation is oxidized. So, hydrogen is the one undergoing oxidation. Therefore, hydrogen is a substance which gets oxidized. Cool? Cool? Alright. If hydrogen is getting oxidized, this would be my reducing agent. Hydrogen would be my reducing agent. So, hydrogen would be my reducing agent, and the other name for reducing agent is reductant. Clear, boss? Give me a thumbs up in chat box if it's clear. Yeah, it is enough. It's enough, yeah. Clear? So, hydrogen undergoing oxidation, this is the substance gets oxidized. This is my reducing agent. This is my reductant. Rest, you can use copper oxide. That's it. All of the other answers will be copper oxide. The one undergoing reduction, copper oxide to copper, it's loss of oxygen. Loss of oxygen means reduction. Who is undergoing reduction? Copper oxide. Who is reduced, getting reduced? Copper oxide. Who is my oxidizing agent? Copper oxide. The one which is oxidizing agent is also called as oxidant, and that is also copper oxide. Did you observe one thing here? That every answer is from left hand side of the arrow. From the left side, you are getting all the probable answers of redox reaction. So please write it down. Whenever you are solving questions of redox reaction, you will always write your final answer from the reactant side, from the left hand side of the arrow. And this topic is done. See how simple it is. How simple it is. Cool? Done and dusted. Yeah. It's so easy to solve any kind of questions that come to your paper related to redox. Okay. All right. So let's solve some questions. Ready? Ready, steady, po. Let's solve some chemical notes together. Check their forte. Moving on to question number 1. Let's solve question number 1. I'll be giving a poll to you guys. Give the ratio of hydrogen and oxygen present in water by volume. By volume. Hydrogen and oxygen in water by volume. Alright? So I'll be starting a poll for you guys. Thirty seconds. and go. Come on. You can kill it. Give the ratio in which hydrogen and oxygen are present in water by volume. Yeah? Let's do it. Let's do it. Cool, cool, cool. And let's see who are all there on leaderboard. Gaurav Tiwari. Kya baat hai yaar? Tha gaye tusi. Good job, Mr. Claim, Vishesh. So many of you are there. Rash, Lakshmi, good job. Riya, Shivam, and good. Very nicely done. Not bad, huh? Not bad. Cool, 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 cool. So answer here is 2:1. By volume they have asked, no? How many hydrogens are there? 2. How many oxygens are there? 1. That is by volume. If I ask this question by mass, then what would be the answer? It's by volume. If I ask the same question by mass, then what would be the answer? If I ask the same question by mass, what would be the answer? D. 1:8. Cool. That would be 1:8. Moving on to our second question. Be ready, guys. Second question. MnO2 plus 4HCl give you MnCl2 plus water plus chlorine. What I have asked you is a substance gets oxidized in the above equation. The substance which is oxidized. Ready? MnO2 to MnCl2. It's loss of oxygen. It's hydrogen to Cl2, add of hydrogen. Let's begin the poll. Yeah? All right. So let's start. Sorry guys, just a second. "30 seconds, go." Let's do it. Let's do it. All right, guys. 3, 2, 1. Voila! So yes, absolutely, it's option B, and I think most of you are coming up with the same option. So Zed, well done, high five. Gunjan, game of headshots. Lakshmi, Mahesh, Gaurav, Priyanshu. All right, good. Priyanshu, amazing, amazing. Not bad. I think you are ready. See guys, those who have marked for water, those who have marked for MnCl2, it can never be your answer. You can do your own 50-50 lifeline. You can choose your own 50-50 lifeline. As I told you before, answers will always be from the left hand side of the arrow, not from the right hand side. So do not pick the products. Do not pick the products. You can straight away cancel them out in redox question. That's a trick. Okay, next question on your screen. Be ready. Lead plus copper chloride gives you lead chloride plus copper. The above reaction is an example of combination, double displacement, decomposition, or displacement reaction. That's easy peasy, lemon squeezy. Be ready. 3, 2, 1. Third question. We are solving third question. And here it goes. Alright, lead reacts with copper chloride, gives you lead chloride plus copper. What type of reaction is this? These type of questions are common for your board exams. It seems you guys are like giving bang on performance right now. All set to for victory this time, huh? Good. Anamika, you can just refresh your page once, huh? All right, so let's see what's the answer. As I'll go with the majority, it's definitely option D, which is displacement reaction. So good job. Gunjan, Priya, Regi, Mr. Claim, clever. Wow, twin sisters, Divyansh. Good. So many of you have answered this and answered it right. So be proud of yourself, guys. So it is displacement. Lead being more reactive than copper will kick out copper from its position. Lead chloride, a new substance will be created and copper will be formed as a byproduct. Moving on to question number 4. Ready. What happens when lead nitrate reacts with potassium iodide? Lead nitrate, that is PbNO3 whole twice, react with potassium iodide, which is Ki. They will not react. A large amount of hydrogen will be released. Yellow PPT of lead iodide and potassium nitrate will be produced and evolution of gas will occur. Let's start. And go. Come on, kill it, man. Nice one. Nice one. They will not react. Large amount of hydrogen will be released. Yellow PPT of lead iodide and potassium nitrate will be formed. Evolution of gas will occur. And 3, 2, 1. Answer is actually option C. So 97.14. Cool, 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 cool. So it's Chiku, nice. Atharv, twin sister, Gunjan, game of headshots, Vanshika, Lakshmi, Priya, and so many of you have answered this one right again. So yes, definitely it is a yellow color precipitate of lead iodide and potassium nitrate will be given out. Guys, how come hydrogen is released? There is no hydrogen in the reactant part. How will you get hydrogen in the product? So definitely this is not an answer. This is not the right one. It will react. And what type of reaction is this? Do let me know in the chat box. What type of reaction is this? Come on. Priya, refresh, please. My name, Zaid Rachita. Double displacement, cool. It's double displacement reaction. Yeah, and in double displacement, it's actually a precipitation reaction. All right, guys, moving on to what are the effects of oxidation? Now, as we have learned about redox reaction, what is oxidation, what is reduction? Now, what is the effect of oxidation in our day-to-day life? I don't know if you have seen this or not. If you go to a public washrooms and which are made up of metal, gates are made up of metal, they get rusted from the bottom and they start shedding off. In fact, in some of the houses also, people use metal gates for their bathrooms. And with the continuous effect of water and moisture and air, that lower part gets affected more frequently and it starts rusting and shedding off. Have you seen this? Any one of you have experienced this ever? Yeah. So that's called as rusting. See, rusting is something which cannot be reversed most of the time. So better to prevent it rather than trying to cure it. And let me tell you, corrosion is a bad thingy. It's very, very bad. So better we should prevent it. It could even affect the economy of our country. Not only that, it could even affect human life. You might have heard some newses like a train was going and it got off that particular rail track. And so many people have died. Such kind of newses nowadays are very common. Why it's so common nowadays? Because we are not repairing them. We are not protecting iron from getting rusted. Because once it rusts, it deteriorates. That surface of metal will be prone to break. So better to prevent it rather than try to cure it. So corrosion is a parent term where metals, usually with the continuous attack of moisture, air, acid, will deteriorate. The surface will start changing its color, shedding off, break. That's when we call it as corrosion. Now, under corrosion, we have two major terms that's important for your exam point of view. Two terms that you should learn under corrosion. One is called as rusting. One term is called as rusting. And other term is called as tarnishing. Now, what is the difference between rusting and tarnishing? If corrosion of iron takes place, it's called as rusting. So a term rust will be only used particularly for metal iron. You cannot use this term for copper or for silver or any other metal. This term rust will particularly be used for metal iron. So if corrosion of iron happens, which require two necessary conditions, one is oxygen and other is moisture, that results into a formation of rust. Now, one mark question that can land up in your paper is, what is a formula of rust? Right? Assertion reason questions can be made up on the part of rusting. What is formula and chemical name? Chemical name is iron 3 oxide. Hydrated iron 3 oxide actually. You should write hydrated iron 3 oxide, or you should mention hydrated ferric. Ferric is nothing but it's iron with 3 plus valency oxide. That's the chemical name of rust. Right? Formula will be Fe2O3 dot XH2O. Formula will be Fe2O3 dot XH2O will be written as a formula for rust. Cool, 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 cool. All right. Now, as we come to tarnishing, tarnishing as a term will be used for two metals. One is for copper and other is for silver. If copper is in presence of water, moisture, carbon dioxide, carbon monoxide, oxygen, for a long period of time, it turns into green color. Do let me know in the chat box, anyone wearing copper ring or copper bangle and their skin has turned into green color? Anyone here? Yeah? See, we were going to find some real life examples. Yeah, see Dhruvika. So those who are wearing copper ornaments, they turn green into color. The skin will change green into color. Why is that so? Because they are every time washing their hands. Copper is in contact continuously with moisture, oxygen, right? So that will turn into basic copper carbonate. What is this? This is called as basic copper carbonate, and this is actually responsible for green color. This particular compound is green in color. In fact, sometimes if you are owning a copper bottle, if you have a copper bottle, that will also start turning green in color after some time because of a creation of a layer of basic copper carbonate, which is CuCO3 dot CuOH whole twice. This complete process is called as tarnishing of copper. Now, another example that you might have seen for tarnishing is silver. Silver turns black in color after some time. It gets oxidized. How is it possible? So, silver on reaction with H2S gas present in air. What is H2S gas? Hydrogen disulfide gas. So, once H2S gas reacts with silver for a prolonged period of time, that results into formation of Ag2S plus hydrogen. Now, what is Ag2S here doing? Ag2S is actually a black color compound. That is silver sulfite. This is BaCk, black color compound. So, when silver is coated with black color, that black color layer is of silver sulfite. This is also called as tarnishing of silver. Cool? Clear? Sorted, boss? Give me a thumbs up in chat box. Siddhant, please refresh. I'm just at my pace, boss. No. Shanta, no. It's not deleted, bache. Alright, cool. Awesome blossom. All right. Now, rancidity. Some of you think that rancidity is out of syllabus. It's not particularly mentioned in CBSE part, but they have mentioned oxidation. So please listen to this carefully. Some of you might think that this is not in syllabus, though rancidity from past few years they've not asked. But as this is a very small topic, we will not leave this part. Okay? Anyone hungry? Anyone feeling hungry and tempted by these chips? Okay. All right. So once I'll give you a two break, you can go and eat. All right. So what is rancidity? In simple words, let's say if you if you eat some cookies at your home, okay, your father or mother has kept some cookies into a box. You're chilling out, you're eating those cookies, and you've not put a lid on it. What will happen? If you do not close that dabba, if you do not close that box, your parents will going to scold you hard. What are you doing? Are we the ones working all the time? You eat everything, but you do not close the lid. Are you always get it scolded for this part? We do not close things properly, and they gets rancid. In Hindi, sealna. Cookies seal जाते हैं. In Hindi we call that. So once it is rancid, it has a weird smell. It has a weird texture. Specifically, rancidity happens in the oil or unsaturated part of food. Fatty or fats basically gets oxidized in presence of the air. You might have complained sometime that mama namkeen mein se na पुराने तेल का स्मेल आ रहा है. Have you ever complained to your parents like that from namkeen we are getting a smell of old oil? That means it is rancid, it is not consumable. So oxidation of the fats is called rancidity, which makes it undesirable for consumption part. You will get unpleasant flavors, textures will going to change, and odor will be very, very bad. It's called rancidity. How you can save it? Preserve it in refrigerator, preserve it in a vacuum containers, and using nitrogen or any antioxidant. There are certain ways by which you can prevent a food from getting rancid. Cool? Cool, cool, cool. So do not leave such small topics, because you never know if it is asked in your paper. All right, guys. So after looking at this chips in, and most of you got tempted, let's take a 2-2 Kit Kat break. Okay? Go have some food, and we'll be back. So let's take 10 minutes break. Cool? 10 minutes. After that, we'll start with our next chapter, acid, bases, and salts. Chips lene. Okay. All right. Shall we, guys? Let's begin. So everyone is back, I suppose. Hi, Motivational Hub. How are you? Hi, Adiba. Oh, that's so sweet. Shall we, guys? So let's start and let's be back with a bang. All right. So, thank you, Santosh. We'll be starting up with Uttari. Baba. क्या भयंकर टाइमर है. All right. So now we'll be starting up with our new chapter, that is acid, bases and salts. Second chapter. I hope you all are ready. Ready? Ready, steady, po. Hi, Drupti. चलिए. So again, thing will be same. I'll be telling you the concepts. In between, we'll be solving the questions related to the topic. So I hope you have eaten something. You got the energy back. So before we start, how is the Josh? Do let me know in the chat box. How is the Josh, guys? Hi, Divya Kunal. Good afternoon once again. Yes. High, very high, OP. OP it is. All right, so it seems that Josh is very high. Everyone had their food, got their energy back. So let's begin with acid, bases, and salts. Okay, guys. So give me 5 acids in your kitchen or 3 acids in your kitchen. Chalo. Anyone who loves to eat chow mein or Manchurian fried rice? Yeah. Again, you must be thinking, oh, ma'am, why you're tempting us? Now we have to order chow mein and Chinese food in our lunch. Vinegar. Yes, vinegar it is. And oxalic acid, malic acid, citric acid. So there are n number of acids which is present in our kitchen. What about bases? What about bases? Toothpaste, the one, once you wake up in the morning, you start your day with brushing your teeth. So that's a basic substance you start your day with, which is toothpaste, then baking powder, baking soda, soaps, detergents. Amazing. So yes, they are all bases. Cool. So we have n amount of acids and bases around us. But how will we get to know whether it's acid or base? Some of the acids and bases we can consume and taste, but there are most of acids and bases or substances which we should not taste or touch because they might be corrosive in nature. So let me give you an example of citric acid. As you guys must be knowing, if we eat lemon straight away, so you look like this. See how cute it is. So it is sour in taste. It's khatta in taste. If we talk about bases, they are kadwa, bitter in taste. Right? So acids are sour in taste generally, but again, let me remind you guys, you are not supposed to taste or touch anything without being knowing about that particular substance. Acid shows acidic character because of the presence of hydronium ions or H3O plus ion or H plus ion aqueous. Or in simple words, if I say that hydronium ions are actually responsible for the acidic character. HCl is acidic because of presence of hydronium ion. H2SO4 behave as an acid because of the presence of hydronium ion. Or any acid we talk about, whether it's citric acid or malic acid or oxalic acid, every acid will going to produce hydronium ions in aqueous medium, in water, to behave as an acid to show the characteristics of the acidic substance. Now, acid do conduct electricity. This is your assertion reason question. But acid conduct electricity only in aqueous state. For example, if I ask you 2-mark question here, HCl in its gaseous state do not turns blue litmus red, whereas HCl in its liquid state do give a test and turns blue litmus red. Why? Why HCl in gaseous state do not conduct electricity or do not shows any acidic character? Because it lacks hydronium ion. Because there is no presence of hydronium ion in HCl in gaseous state. Whereas HCl in aqueous state, where HCl will be added with water, that will going to give you hydronium ion and chloride ions. So because of the presence of hydronium ion, HCl in its aqueous state will behave as an acid. It will show all the characteristics of the acid and turns blue litmus red. Alright, now as we are talking about bases, bases are bitter in taste. They are karwa in taste. You can try baking soda at your home. You can put it a little bit on your tongue and you will get a feeling of how bases taste like. Majority. Bases are also slippery and soapy in touch. You might take a detergent in your hand, and then wash it with water. You will feel that slippery and a soapy touch. This is how generally bases feel like. So bases are bitter in taste, slippery or soapy in touch. But how bases behave as a basic substance? What is one thing in bases which make them as a base, or which shows that kind of character? And that's none other than hydroxyl ions or hydroxide ions. So in simple words, OH minus ions are responsible for the basic character. But some of you might ask me, ma'am, there are some bases which cannot dissolve into water. Like for example, ferric hydroxide, aluminium hydroxide, etc., etc. They cannot dissolve into water. Then how will we get to know whether they produce OH minus ions or not? So what scientists told, that if we react them with acid, they will easily react. Being a base, they can easily react with acid and give salt and water. This is how we can prove that they are bases. But there are some bases which can be dissolved into water smoothly, very easily, and those bases are then categorized as alkali. What are alkalis? Those bases which are dissolved into water easily and smoothly, those bases are called as alkali. For example, sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, ammonium hydroxide, and so on and on and on. There are list of bases which get dissolved into water and they are called as alkali. Now, one more question, assertion reason, what they can ask you: alkali are bases, but all bases are not alkali. Is that true or false? All alkalis are bases, but all bases are not alkali. Clear, boss? Give me a thumbs up in chat box. Clear? Yes, absolutely, Dhruvika. True, true, true. All right. Okay, guys. Moving on to, as I told you, how to detect. You're not supposed to taste or touch anything. Like in childhood days, our parents always instruct, do not take anything from strangers. Do not taste everything. Do not touch anything, right? So just like that, your teachers are now telling you, do not taste or touch everything, because they might be corrosive in nature, that might be dangerous to you. Specifically, once you are entering into a chemistry lab, you should be straight enough and do not get those kind of things in your mind. Oh, can I touch that? What will happen if I touch that? Oh, can I taste it? If I taste it, what will going to happen? If you're having such thoughts, please go out from that chemistry lab. It's quite dangerous. So for that, we have indicators. What are indicators? Which help you guys, your curious mind, to know or to determine whether a substance is acidic, whether a substance is basic. Now, there are various types of indicators present. It could be a natural indicator, synthetic, or olfactory. Natural and synthetic indicator are overall color-based indicator. What does color-based indicator means? The ones with the change in color, they will help you to identify or indicate. So change in color will help you to indicate whether a substance is acidic or basic. And if it's olfactory, olfactory means smell, sense of smell. With a change in smell, you'll be able to know whether a substance is acidic or basic. But olfactory indicators are usually used by visually impaired people, the one who cannot see, the one who are blind. Visually impaired people mostly use olfactory indicator, which includes clove oil, onion juice, or vanilla essence. Now, as we are talking about natural indicator, one of it is litmus. Why litmus is called as natural? Because it is made from lichens, from the pigments of lichens, and therefore we consider it as a natural indicator. Now, what about turmeric? Let me tell you one story about turmeric. I think that would be a story of every one of us. Whenever we wear white color clothes, we always tend to spill something on our clothes. I think that's true for every one of us. I don't know. If I'm wearing black, nothing will be spilled. If I wear white, something or the other will come and make a spot on my white clothes. And what happened after that? Our parents run with a chappal behind us, telling that wash it right away, otherwise the stain will not go. Hai na? The stain will not be removed if you do not wash it quickly. Now, just washing your white clothes with water, will that be enough? No. You have to wash your white clothes. That turmeric stain needs to be removed, needs to be washed with a basic substance. So, turmeric itself is yellow in color. Now, once you put a base on it, maybe a detergent or a soap, it will turn into red color, and this red color will be evaporated later, and that white cloth will be cleaned. But if you just put it into water or an acid, that yellow color will remain as such and there would be no change. So whenever you spill something on your white clothes like turmeric, quickly wash it by using detergent. Do not just wash it with water. It will not going to change anything. Cool. Now, China rose. In Hindi, we call it as gudhal. We also call it as hibiscus flower. So that is also one of the natural way to identify whether a substance is acidic or basic. Now, once we come to synthetic, synthetic means man-made, or in labs we used to make this. Two examples. One is methyl orange and other is phenolphthalein. Phenolphthalein and methyl orange are two synthetic commonly used indicators to determine whether a substance is acidic or basic. Now, looking here at the examples, if we put phenolphthalein, guys, phenolphthalein itself is colorless. I hope you did this in your laboratory because it's so beautiful to watch. It's treat to an eye. If you put few drops of phenolphthalein, colorless indicator, into a basic substance, that will immediately turns it into a beautiful pink color. It gives a pink color. It's magic. So if it gives pink color, it's a base. If colorless indicator phenolphthalein do not changes any color, it's an acid. So colorless will remain colorless in acid. It will turn pink into a base. Whereas methyl orange itself, it's orange in color. It will give pink color into acid or dark magenta color into an acid, yellow color into a base. So with a change in color, you'll be able to identify whether a substance is acidic or basic. Good to go? Awesome blossom. Good question, Lakshmi. Very good question. I will answer that. Yeah? Yes. This is asked in paper. Yeah, they do ask you about colors sometime. Yeah. It's a very good question. I would love to take that. Why ammonia is a base? Okay, let me take that question because this is important one for your paper as well. Why ammonia is a base? It was actually asked few years ago in your board exams for 2 marks. Why ammonia is a base? It does not have OH in it. Still ammonia is considered to be as a base. So what happened? Once we add ammonia with water, it formed immediately ammonium hydroxide. Ammonium hydroxide will going to dissociate immediately and form ammonium ions and hydroxide ions. So now, have you heard about A is equals to B is equals to C, therefore A is equals to C? Have you heard this thing in maths? Same thing is happening here. A is equals to B is equals to C, therefore C is equals to A. Ammonia on adding with water will form ammonium hydroxide, which immediately ionize and form ammonium ions and hydroxide ions. So because of the presence of these hydroxide ion, ammonia is considered to be as a base. Clear, boss? Give me a thumbs up in chat box if it's clear. Cool, 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 cool. Yes, we have to learn the colors on pH scale. I'll tell you, Adiba, how you can do it. Yeah? Okay. All right. All right, guys. Moving on to the next part. About acids and bases. Classification of acids and bases are done in two ways, depending upon its concentration and depending upon its strength. It's not just about acids, we can also consider bases along with that. Now, what we call concentrated HCl, dilute HCl, concentrated acetic acid, CH3COH, dilute CH3COH. What is dilute and concentrated means? What is the difference if I'm taking acetic acid in concentrated form or if I'm taking concentrated H2SO4 or HCl? What is the foundational difference between these terms? So let's have a look. It's very, very important. Please make sure that you focus here. Depending upon strength, acid or base could be a strong acid or base or a weak acid and base. Whereas based upon concentration, it could be a concentrated acid or base or a dilute acid and base. But how will we get to know? Now, depending upon strength, strength depends upon the percentage of ionization. Carefully listen to this. Strength depends upon the percentage of ionization. If an acid or a base 100% ionizes and give 100% ions, they are called as strong ones, either acid or base. For example, if I take NaOH, NaOH in water will ionize 100%, that will form 100% ions of Na plus and OH minus ion, or HCl into water will ionize completely into hydronium ions and Cl minus ion. So if they ionizes 100%, they are called to be as stronger ones. But if they partially ionize, if there is a partial ionization, in that way they will be considered as weak. For example, ammonium hydroxide. Ammonium hydroxide will partially ionize in ammonium ions and hydroxide ion, and few of them will not even ionize. Some of them will not break. That means few ions are formed and some of them are as such as molecules. So partial ionization make them weaker form of acids or bases. Now let's take one more example of acid, acetic acid. CH3COH. If I put acetic acid in water, that will partially ionize, means some of the acid will break into ions and some will not. Like CH3COO minus. Some will form acetate ion and hydronium ion. But some of them will not even going to break. Some will not going to ionize and form ions. So for that reason, it is considered to be as weak acid. Both of them are strong acids and strong bases because of 100% ionization. Here it is considered to be as a weaker base because of partial ionization. Now what does concentrated means and dilute means? Say concentration depends upon the amount of water. What does that mean? What does amount of water means? If more acid is there, less water is present in it, it's concentrated form. If percentage of water is less as compared to percentage of acid or base, it is called as concentrated. If percentage of acid or base is less as compared to percentage of water, or amount of water is more as compared to acid and base amount, we will consider to be them as dilute form of acids or base. Now from this part, one question can arise. I'll come to that question. I hope till here it's sorted. How acids and base in a given salt. Yeah, I'll come to that, Harshad. Once we start with salts na bache, I'll tell you that. Yeah. Okay. All right. So again, let's go through this again. Strength depends upon the percentage of ionization. If it's 100% ionized, completely ionized, it is considered to be as strong. If it's partially ionized, it is considered to be as weak. On the basis of concentration, it depends upon the amount of water. If amount of water is less and acid or base quantity is more, large quantity of acid, small quantity of water, it's concentrated. But if it has much more higher percentage of water as compared to acid or base, it is considered to be as dilute. But my question to you guys is this. Are concentrated acid and bases always strong? Or are dilute acid and bases always weak? Do let me know in the chat box. Think before you write anything. Come on, give it a try. Oh, nice question. Nice. Are all concentrated acid and bases always strong? Yes, no, yes, no, yes, no. I'm getting both of those. Majority of you are saying no. Some of you are saying yes. Let's see what is the answer. Now I'll ask you to differentiate concentrated HCl, concentrated acetic acid, CH3COH. Now both of them is a strong acid, B, weak acid, C, none. Okay? For it also, I'm doing the same thing. Strong acid, B, weak acid, or C, none of the above. Tell me for this one. Strong acid, weak acid, none. Concentrated HCl. Tell me for concentrated HCl whether it is strong acid, weak acid, or none. Lakshmi, good job. HCl. For HCl only we are talking about. So for concentrated HCl, you guys are saying it is a strong acid. Okay, what about concentrated acetic acid? What about concentrated acetic acid? Please look at each term. Concentrated acetic acid. What is it? Okay. So as per you guys, it is considered to be as a weaker acid. Cool. Yeah, simple. Yeah, why not? Why we are saying this? Being both concentrated, one is a stronger acid and other is a weaker acid. How? Acid strength or a basic strength is decided by the percentage of ionization. HCl undergoes complete ionization, whereas acetic acid undergoes partial ionization. So based upon ionization, acetic acid is weaker, whereas HCl is stronger acid. Concentrated only tells us about the amount of water. That in both of them, amount of water is less, but quantity of acid is more. So concentrated and dilute has nothing to do with whether it's a strong acid or it's a weak acid. In fact, if I compare between dilute form of HCl and concentrated form of acetic acid, guys, listen to this very carefully. Concentrated acetic acid is again a weaker acid, whereas dilute HCl is a stronger acid. Because HCl can completely dissociate. So HCl is a stronger acid, no matter it is dilute or it is concentrated. If it's clear, give me a thumbs up in chat box. Lakshmi, we'll deal with that today. Don't worry. It would be fun. Yeah? Cool, cool, cool. All right. Amazing. So be ready for such twisted questions also in your paper. Now, coming up to chemical lochas and chemical properties. Now, talking about acids and bases, how acids and bases behave with other elements. Do acid react with metal? Do bases react with metal? Do acid reacts with metal oxide or non-metallic oxides or not? And same goes with bases. So we have to see how acids and bases behave with other elements, and that comes under chemical properties of acids and bases. So starting up with acid reacts with metal derivatives like metal carbonates and bicarbonate. Why? Why acid react with metal carbonates and bicarbonates? Because they are basic in nature. Please note, acid and acid will never ever going to react with each other. Base will never react with base. There would be no reaction between two acids. There would be no reaction between two bases. So if acid is reacting with metal carbonates or bicarbonate, the reason behind it is that these elements, these compounds are basic in nature, so they can easily react with acid and give further products. On the other hand, acid reacts with base. Yeah, we know that. That's a neutralization reaction. Acids react with metal oxides because again they are generally basic in nature. So that's why metal oxides can react with acids. On the other hand, bases react with metal. But there is a small twist here. Do all metal react with bases? No. There are very few metals which react with bases, and we call them as amphoteric metals. Only amphoteric metals can react with bases. And bases can also react with non-metallic oxide. Why? Because they are acidic in nature. Because of its acidic behavior, they can react with base very easily. Let's take quick examples. Yes, Lakshmi. Okay. All right. Moving on, acid reacts with metals. We have ample amount of examples. Zinc react with HCl. That gives you zinc chloride, ZnCl2 plus hydrogen gas. Guys, you should remember the general reactions always. What is general reaction? Whenever metal reacts with acid, that will always result into formation of salt and hydrogen gas, and along with that, heat is evolved. And yes, it is exothermic reaction. Okay, we can take more examples. Like for example, copper reacts with HCl. What will be the product? What is the product when copper reacts with HCl? That's so sweet, Aniket. See, you will punish yourself. I cannot do that. You have to do it. Can copper react with HCl? Guys, no reaction. Lakshmi, good job. No reaction. I told you, don't start just mentioning the products without applying some logic. Ouch. That's out. So there would be no reaction because copper, being a low reactive metal as compared to hydrogen, cannot displace hydrogen from its position. So yeah, it's no reaction. I tricked you guys. I tricked you. Okay. Bases react with metals. So as we discussed, only amphoteric metals can react with base like aluminium, zinc, lead. But the ones in your syllabus is aluminium and zinc. Aluminium on reacting with NaOH. or zinc on reacting with NaOH will again form salt and hydrogen gas. Now there is a little different type of salt which is formed here, and that is sodium aluminate. That is NaAlO2 plus hydrogen gas will be evolved. It is called as sodium aluminate. Now one request to you guys is, whenever you are writing reactions in your board paper, always try to mention the names below. Whenever you are writing a reaction, please try and mention the names of the chemical compounds below. That increases the paper presentation, as well as that gives a nice impression to your examiner as well. It puts a good impact. Zinc reacts with NaOH, that forms sodium zincate, which is Na2ZNO2 plus hydrogen gas. And what is the name of it? It is named as sodium zincate. Sodium zincate. Cool? Cool. Yes, Na2ZNO2. Good. Very nicely done. Next chemical reaction. What happened when acid reacts with base? We all know it is none other than double displacement, neutralization reaction. How many of you like golgappas here? Anyone who love golgappa or chaat, bhel puri, chaat papdi? Yeah. Me. Yeah, na? So many of you love golgappas. So you might have done golgappa competition with your friends, maybe. You might have done. So once we eat lot of golgappas, we eat lot of chaat and all, pani puri. Yes. So what will happen? You will have acidity. Now once you have acidity, your parents will try to feed you with Eno, Pudin Hara, Gelusil and so on, which is a basic substance. So acid will be neutralized, or excess of acidity will be neutralized by an antacid, which is basic in nature, results into formation of salt and water. So acid reacts with base, that forms salt and water. So let's take an acid, H2SO4. Let's take a base, calcium hydroxide. Come on guys, give me the products. Give me the products. Okay. Yeah, milk of magnesia, Kunal. That's right. Come on. Give me the products. Calcium sulfate, CaSO4 plus H2O. Now, acid reacts with metal oxide. Before we move on to this part, let me make this clear to you guys. Let me revise this for you all. Metal oxides can be basic in nature and can also be amphoteric. Fine? Basic will the ones which react with acid. Amphoteric can react with acids also and bases also. What are amphoteric oxides? Like zinc oxide, aluminium oxide, they are amphoteric oxides. So they can be reacted with acids also and bases also. Whereas basic metal oxides will react with only acids. For example, copper oxide being basic in nature, reacts with HCl. And please mark this reaction as super important. It can come to your paper this year. So please mark this as very important. Yes, Lakshmi. Come on. Copper oxide plus HCl. What do you observe? Copper oxide, black in color, reacts with HCl, give you green color of copper chloride, which is CuCl2 along with water. So a basic substance reacts with acid, give you salt and water. This is similar to that of neutralization reaction. Very, very important. All right. Moving on to the next chemical note, what happens if base react with non-metallic oxides? So non-metallic oxides also carry two types of nature. Some of the non-metallic oxides are acidic And some of the non-metallic oxides are actually neutral in nature. Neutral ones are like carbon monoxide, nitric oxide, water. They are all neutral. Acidic, like carbon dioxide, non-metallic oxide, sulfur dioxide, sulfur trioxide, nitrogen dioxide, and so on. They are all considered to be as acidic non-metallic oxide. Being acidic in nature, they can easily and smoothly react with bases. For example, carbon dioxide reacts with calcium hydroxide. Come on, guys. That's the most common reaction you guys have learned. Even you have learned this reaction in your lower grades. You know this one very well. Lime water turns milky. Yes, go with dreams. Bluish green, yeah. Calcium carbonate plus water. Well done. Yes, it's calcium carbonate plus water. Lime water passed through carbon dioxide passed through lime water. It turns it milky because of the formation of calcium carbonate and water. Cool. Cool. That's a simple example. Okay. Acid reacts with metal carbonates and metal bicarbonates. Metal bicarbonates are also called as metal hydrogen carbonates. Right? So, what are the examples of metal carbonate? It could be Na2CO3, it could be CaCO3, it could be K2CO3, it could be MgCO3, and so on and on and on. These are all examples of metal carbonate. And what are the examples of metal bicarbonate? NaHCO3, CaHCO3 whole twice. Similarly, MgHCO3 whole twice. They are all basic in nature, and being basic in nature, they will always react with the acids very easily. Now, general reaction is, please remember general reaction, whenever acid react with metal carbonates or bicarbonates, they will always result into formation of salt, water, and carbon dioxide gas. Please do not forget to put carbon dioxide here. They will always going to produce salt, water, and carbon dioxide. Clear, boss? Give me a thumbs up in chat box. Yeah? Yes, girls with dreams. Yash, I'll give you by the end. Yep. All right. Okay, guys. So on that positive note, we are here to solve some more questions. So are you ready to solve more questions? Clear, boss. Okay, Adiba. Cool. Chali, let's solve some question, and here it is on your screen. Starting up with question number 1 here. What is formed when zinc react with sodium hydroxide? We are doing question number 1. I'll be starting a poll here. What happened when zinc reacts with sodium hydroxide? You all can kill it off. This is very simple question. Okay. 30 seconds and very steady po. What is formed when zinc reacts with sodium hydroxide? Come on, guys. Kill it. आज फिर जीने की तमन्ना है. Let's see. 3, 2, 1, and thumbs up. So it is going to give you option B. Let's see the results. 87.5%, not bad. Ashwini, Sneha, Adhar, Regi, Vanshika, Ishki. Okay. Dhruvika, and so many of you have answered this. Adiba, Radha. Good job, guys. Not bad. So it's sodium zincate, as we discussed. It is definitely sodium zincate, which is Na2ZNO2 plus hydrogen. So that will make option B as your perfect answer. Moving on to question number 2. Sodium hydroxide turns phenolphthalein solution to, or if you add phenolphthalein into sodium hydroxide, what color will you get? Will it be turning pink, yellow, colorless, or orange? So again, giving you 30 seconds and go. All right. So let's see. What's your answer? It is, oh, not bad. Better than before. So yes, it is the option A, which is pink in color. So guys, you have to remember the colors and make sure that you remember colors for synthetic also as well as natural also. So sodium hydroxide being a basic substance, phenolphthalein, colorless indicator, if you put even few drops of it in basic substance, that will going to give you pink color, a beautiful pink color. So yes, Yash on the top, well done. Gunjan, podcast class 10th. Ashwini, Shakina, Harshit, all right, not bad. Good. Okay, moving on. Moving on to our next question. Write the chemical equation for the reaction when zinc reacts with potassium hydroxide. You usually use sodium hydroxide, but what happens if zinc reacts with potassium hydroxide? Just give me a name, guys. Give me a name in the chat box. No, Priyanshu, there would be a reaction. But see, if zinc reacts with sodium hydroxide, zinc will also react with potassium hydroxide. There would be a reaction. Come on. Oh, podcast class 10th. High five. Yes, it will going to form potassium zincate. See, instead of sodium zincate, it is going to form potassium zincate plus hydrogen gas. So it will be K2ZNO2. If it would have been sodium, then what do you make? Na2ZNO2. Now instead of sodium, it's potassium. That's it. I've just twisted a question. Instead of NaOH, I took KOH. And they both have similar properties. Yeah. Hai na? All right. I hope it is clear. So be ready for this answer, this question also in your paper. Next, write the chemical formula of bleaching powder and how bleaching powder is prepared. Okay, I have given you before. I will ask you later, but that's okay. I should have given this later. Anyone remembers it? Yes, CaOCl2. CaOCl2 is the formula of bleaching powder, which is calcium oxychloride. How is bleaching powder prepared? How is bleaching powder prepared? Anyone? When dry slaked lime, which is calcium hydroxide, is reacted with chlorine, that results into formation of CaOCl2, which is calcium oxychloride. Along with that, water will be given out as the byproduct. So dry slaked lime reacting with chlorine. Absolutely, Anil. Good job, Tanay. Nicely done. Okay. Moving on to pH. Okay. Let me ask you one question here and think before you answer. Okay. I have asked you things like HCl will going to dissociate and give 100% ions. It's a strong acid. Acetic acid in water will partially dissociate, partially form ions, and it's a weak acid. This is something which I told you before. But have you ever wondered How will we see ions? No, you have not seen ions. I have not seen ions. Nobody can see ions in a solution. So how will you and I have decided whether it's a strong acid or a weak acid, whether it's a strong base or a weaker base? So for that reason, we have pH in a picture. pH helps us to determine about the ions, whether they are completely ionized, whether they are weakly ionized, whether it's a stronger one or whether it's a weaker one. So pH helps us to find out the concentration of the ions. And based upon that, we have pH values. pH could be 0 to 14. It ranges from 0 to 14. If pH value lies between 0 to 7, it's an acid. If pH value lies between 7 to 14, it's an alkali, it's a base. If pH value lies at 7, it would be neutral in nature. What is the full form of pH? One thing that could be asked in your paper. Assertion reason questions, they could ask you about what is the use of pH, right? Whether it's true or whether it's false. So pH is the potence of hydrogen. That means it will tell you about the potential of hydrogen ions or the power of hydrogen ions. Now strength of acid and bases will depends upon what? Total number of hydrogen or hydronium ions and hydroxide ions present in them. And who will help us to tell the strength of acids and bases? None other than pH. pH will help us to find out the strength of acids and bases. So a scale for measuring hydrogen ion concentration in a solution is called as the pH scale. Now, one of you have asked me in chat box, there was a question in the chat box, do we have to learn the colors, ma'am? Do we have to learn exact colors of the pH scale? So the answer is not exact colors, guys, but you have to learn the colors because questions have been asked in your previous year question papers related to the colors. How will you learn it? Let me help you with that. So, as you all know, let me skip this. Yeah. So, are you aware about Vibgyor? Are you all aware about Vibgyor? You know what is Vibgyor is? So, I will put this in opposite direction. V-I-B-G. Green should be in the center. Green should be in the center. Y-O-R. Now the question, whenever they ask you the question related to colors and pH, they will never ask you to write the exact color. That's not possible, guys. Obviously, until and unless you perform it into lab, you cannot give exact colors, but you can give range of colors. So, if it's very strong base towards pH value 13, 14, it would be violet in color. If it's around 11, 12, 10 to 12, it will be indigo in color. If it's around 8 to 10, then it would be blue in color. Green will be for pH 7 when it is neutral. Yellow when it is weakly acidic. Red once it's a very, very strong acid having a pH value towards 0 to 1. Now, there is one relation from which questions are asked. pH is inversely proportional to H plus ion concentration. Lower the pH value, higher will be the concentration of H plus ion and stronger will be the acids. So, as I told you, strength of acids and bases are decided by the total concentration of H plus and OH minus ion. So, if H plus ions are more, pH value will be down. pH value will be very low and considered to be as a stronger acid. If pH value is higher, H plus ion concentration will dip and that will be considered as a weaker form of acids. Clear? Clear, clear, clear? Ma'am, can we write red for all the acids? No, Atharv. You cannot. Say, if you are talking about Atharv litmus, that's different thing. If you're talking about pH, it's different. Okay. So this is how questions could be put up in your paper related to color. They will only ask you about the range of color. They will not expect you to give the exact colors. Now, where is pH used in our day-to-day life? We are learning a lot about pH. We have learned the colors also. We have learned the range also. But what is the use of all this? Acha, doctor must have advised you to brush twice a day. Yeah, before you sleep and after you wake up. You should always brush your teeth. Why? Once you eat food, obviously some of the enzymes are working in your mouth and that would release and make your mouth acidic. To balance that acidic medium, because your tooth decay will start at a pH below 5.5. Learn this pH value. If pH goes below 5.5, that will start with the tooth decay. It can be asked in your paper for 1 mark, section A MCQ. If pH goes lower than 5.5, that starts with the tooth decay. So to balance that pH level, you should brush your teeth because it is basic in nature. Right? Now, another use of pH or effect that you have of pH in your day-to-day life is your whole body. Our entire body works at a slightly alkaline medium. Our stomach works at the acidic medium because of the digestive juices. But our whole body, if we see overall, that works at a slightly alkaline medium. So if your body becomes really acidic, you will fall sick. If your tummy becomes excessively acidic, you will fall sick. So we have to maintain the pH in our day-to-day life also. Okay, let me ask you one thing. If you might have seen in movies or maybe on TV, farmers put white color substances in their field like this. Have you seen? Farmers throw white color substance in their field like this. It's not urea I'm talking about. It's not the urea which I'm talking about. Yes, Palak, very good. It's calcium oxide. It's quick lime that I'm talking about. Or slaked lime, calcium hydroxide. So, fertility of the soil will decrease with the acidity. More acidic soil is, less fertile that soil will be. So, to increase the fertility of soil, they have to put a basic substance to maintain and balance the pH level. Now, next example might be a relatable one for most of you. It relates me. Anyone has ever been stung by honeybee? Me. Twice, as far as I remember, I have been stung by honeybee twice. And it's so painful. It's so painful. So what people do usually, if you are stung by honeybee, they will start rubbing chabi, key. This is what they do. So, but nobody rubs a basic substance. I don't know why. See, if you are rubbing a key, that will only helps to remove that sting wala part of honeybee so that it does not cause any infection later on. But that key will not give you any kind of relief. A relief will be given from the pain if you will rub some basic substance like a baking powder, baking soda paste, right? So baking soda paste will neutralizes the acid that is being produced. What kind of acid is produced by honeybee sting? Methanoic acid, which is also called as formic acid. Formula is HCOOH. Structure is HC double bond OH. Guys, being chemistry student now, you can relate with this compound, right? So HCOOH or formic acid or methanoic acid causes burning sensation. It even causes blisters. So to soothe that, to neutralize that and to bring the pH up, we have to put a basic substance like a baking soda paste. Now, if you want to go to a forest and you by mistake got stung by nettle plant. Nettle plant, anybody heard of it? Anybody heard of it? Nettle plant? Nettle leaves. So nettle leaves have little bit of hair-like structure, which we just cilia-like structures on the edges, on the place of stomata. है ना? So if you got rubbed by it, your hand got rubbed by these leaves, you will get blisters, redness, burning sensation, itching. And what is the reason behind it? None other than methanoic acid. So if methanoic acid has been there in your skin, you have to search for a basic substance. Now, let me tell you, beauty of nature. You will find the medicine of this plant nearby nettle leaves. Nearby nettle plants, you will find dock plant. Guys, beauty of God, beauty of nature. If you ever got stuck by nettle leaves, you will find dock plants nearby that place, which is basic in nature, and you can just rub those leaves on your hand and you'll be okay. Cool? Isn't that cool? Yeah, adjacent to nettle plant, you'll find dock plant. Okay. All right, guys. Now, cool? Yeah? Moving on to salts, we are very much comfortable with acids, we are very much comfortable with bases, but most of the time, you guys back off when it comes to salt. Anyone here who ever felt like that, ma'am, I'm not able to do questions related to salt, I'm not able to identify salts, because most of the time, salt for you guys is NaCl, that's it. Hai na? Yeah, motivational house, I'll clarify that. So most of us know salt means NaCl, which is a common salt or a table salt. But that's not true, guys. That's not true. Other than NaCl, we have other metal halides. I'll explain you this part. Metal carbonates, metal bicarbonates, metal sulfates, metal nitrates or nitrites, they are all considered as salt. It's not just NaCl is a salt, KCl is also a salt, potassium iodide is also a salt, right? And sodium iodide is also a salt. NaCl, obviously, you know it as a common salt. Metal carbonates like sodium carbonate, potassium carbonate, calcium carbonate, they are all salts. Metal bicarbonates are salt. Metal sulfate like zinc sulfate, that's a salt. Metal nitrate like lead nitrate, that is also considered to be as salt. I hope that is clear. Yeah. So acids and bases, in lab usually if we talk about acids and bases, will give you salt and water, which is a simple neutralization reaction. And the major natural source of salt is mountains. Salt mountains are there, oceans are there, so we get salt from there as well. Now, types of salt. Questions lies here. Question lies in this part. Whether it is acidic salt, basic salt, or neutral salt. Identify. How questions will come? Let me tell you. So we all know what are acids, what are bases, which of them are stronger acids, which of them are weaker acids, stronger bases, weaker bases. You should have a clear idea about strong acids and bases, weak acids and bases. Now, to find out whether a salt is acidic salt, basic salt, or neutral salt, you have to search for their parents. See, if you have to find out the character of a bacha or a nature of a child, you will search for their parents. How parents are will define the nature of a child. Same thing is happening here. Parent acid plus parent base will going to give you salt, means a child, and water as a byproduct. If parent acid is a stronger acid and parent base is also a stronger one, then child will be neutral. If both of the parents are stronger and strict, child and bacha will be very neutral and sehmawa, right? So strong acid, strong base will give you a neutral salt along with water. Neutral salt means pH is equals to 7. But whereas if it's a stronger base reacting with weaker acid. Weak acid, strong base. One of the parent is stronger, that would be a dominant one. Stronger one will show its characteristic into a bacha, will show a characteristic into a salt. So it would be considered as a basic salt plus water. And basic salt means pH will be greater than 7. Now thirdly, what happens if it's a weaker base reacting with stronger acid? Strong one will show the characteristics in child, will show characteristics in salt. So salt would be the acidic salt plus water. That means acidic salt pH will be less than 7. Now most of you have a doubt, what happened, ma'am, if weak acid reacts with weak base? What will happen? If weak acid reacts with weak base, that always results into a formation of neutral salt again along with water. Neutral salt means again pH is equals to 7. Clear, boss? Give me a thumbs up in chat box. Done? Done and dusted? Okay. Now, how questions are asked? In questions, they will give you product and they'll ask you the reactants. So they will give you ulta reaction. They'll give you the bacha. They will ask you to search their parents and find out the nature of child. I'll give you one example here. Let's say calcium carbonate, okay, or sodium carbonate, Na2CO3. Let's take this example. So in question, they have given you sodium carbonate and they're asking you what is the nature of sodium carbonate. What is the nature of sodium carbonate? How will you get to know? Until and unless you search their parents, you will not be able to find out the nature of this bacha. So it is made from acid and base. What acid is there which consists of carbonate? Guys, you have not much options, so there would be no confusion. There is one acid which is of carbonate, and that is H2CO3. You have not much options, so I don't think so you will have any confusions here. Sodium. There is one base of sodium that you have learned, and that's none other than NaOH. Done. Done. Now, looking at the parents, what do you see? Carbonic acid is a weak acid. You should know. NaOH is a stronger base. You should be aware about it. Strong base, weak acid. What kind of nature will it be? Base is stronger, acid is weaker. The stronger one will be more dominant, and that shows the characteristics in salt. So it would be a basic salt. What would be a pH? Greater than 7, and voila, that's it. Such kind of questions will be asked in your paper. Let me give you more examples here. NaCl is a neutral salt because it reacts with strong acid and a strong base. Potassium nitrate, KNO3 is a neutral salt because it's reacting with strong acid and a strong base. Acidic, let's take copper sulfate, is acidic because both of them, one of it is weaker base reacting with stronger acid. So it would be an acidic salt. If we come to basic, sodium bicarbonate is formed because of carbonic acid, which is a weaker acid. NaOH is a stronger base, so results into a basic salt plus water would be there as a byproduct. All right? All right. Now back to common salt. Actually, let me ask you one question. You all see dreams, right? You might see dreams of your crush, your love, loved ones, your relatives, and so on. Have you ever seen dreams of common salt? Have you ever saw dreams of common salt? Oh, if I don't get common salt, my life will be ruined. Na neend hai, na chain hai. Have you give that much importance to salt ever? No, we have not given so much importance to salt. But imagine one day without salt. In pizza, there is no salt. In Maggi, there is no salt. In pav bhaji, there is no salt. In butter paneer masala, there is no salt. How will that day will be for you? That would be the horrifying day ever. So let's give some importance to sodium chloride from now on, because that is something we are all relied upon. Now, why I'm saying this, guys, we have no idea. कॉमन सॉल्ट, जस्ट एक चुटकी कॉमन सॉल्ट की कीमत तुम क्या जानो रमेश बाबू, है ना. सो दैट कॉमन सॉल्ट कैन अफेक्ट so many industries directly or indirectly. Yes, common salt can affect industries like chlorine, hydrogen making industries. It can affect industries of bleaching powder. It can affect industries of baking soda. It can affect industries of washing powder, and so on and on and on. So NaCl, being a common salt, can directly or indirectly impact lot of industries. So it is a raw material which is used in preparation of so many other salts. It's used in the preparation of other salts at industrial level. Not only that, NaCl is used in manufacture of soap, in glass fibers, in cooking food, as a preservatives in pickles if you love to have achar, and also as a raw material for a lot of chemicals. Starting up with NaOH, caustic alkali. NaOH is what? Sodium hydroxide. What is its common name? It is called as caustic alkali. Clear, boss? Okay. Yeah, that's rock salt only, Shanta. It's rock salt. That's actually a name of ore of NaCl. We call it as rock salt. Adiba, good question. Write and learn, bache. Write and learn. Okay? All clear? Good. Now, talking about the preparation of sodium hydroxide, where NaCl is used directly. NaCl, sodium chloride, is directly being utilized to prepare sodium hydroxide. How? NaCl into water. Normally what we call it as salt water. At home, if you want to ask for salt water, you will just tell, oh, give me 1 glass of salt water. But instead of that, try this. Mom, can you please give me 1 glass of brine solution? Please try it at your own risk, because after that you will get a flying chappal. अच्छा, सारी सब कुछ मेरे साथ ही निकलेगा. So, brine solution, salt water, is simply called as brine solution in chemistry. If we pass electricity through salt water, brine solution, that results into formation of sodium hydroxide, chlorine and hydrogen gas. This entire process is called as chlor-alkali process. Why? Because scientists have not given much thought. Chlorine is formed, alkali is formed, so they thought, okay, just write it as chlor-alkali process. So this entire process is called as chlor-alkali process. Now guys, some of you think that there would be no diagrams in chemistry, but you are wrong. Chemistry paper can have some diagrams. They can ask you diagrams to explain chlor-alkali process with diagram, with all the reactions. So be prepared with such diagrams, because most of you think that diagrams are only in physics and bio, but it's not like that. So how will you explain chlor-alkali process? Let's say it comes for 5 marks. Let's say it comes for 5 marks. How will you explain it? So you will make a diagram first where you will explain the presence of NaCl. So you will put NaCl. From the other side, you're putting water. This is the easiest way to draw the diagram, guys. So you can practice along with me. Yeah? Now, there is a membrane in between. That membrane allows only positive ions to pass through it. Positive ions are allowed to pass through it. That's it. Period. It only allows positive ions to pass through it. Do remember that. Okay. Now we have two electrodes here. One of it is anode, other is cathode. Anode is the one which is connected to positive terminal of the battery, and cathode is the one which is connected to negative terminal of the battery. So negative side will be called as cathode and positive side will be called as anode. Right? That is it. Now let's begin with the reaction part. At anode, what will going to happen? What will happen at cathode? Now, let's begin. Obviously, if we have used a battery, we'll switch it on. So let's switch on the battery. What we'll see here, Na plus Cl minus ion, H plus OH minus ion will show some movement. With the passage of electricity, there would be a movement of ions. Plus will going to run towards negative. Obviously, opposite charges attract each other. So positive one will move towards negative side. But there is one more positive here which will move towards negative side. Right? Positive ions can be passed through this membrane. Remember, only positive ions are allowed to pass through membrane. So Na plus went on right hand side. Now, negative cathode is attracting both of them. Eventually, Na plus will end up reacting with OH minus ion. This Na plus will end up reacting with OH minus ion and form NaOH, will be collected towards or nearby cathode. I'll repeat this part again. Listen to this very carefully. Na plus will pass this membrane, go towards cathode side where it reacts with OH minus ion of water and form NaOH, which is caustic alkali. This caustic alkali will be collected near cathode. Remember, NaOH will be collected near cathode. Now at the same time, H plus ion will go towards cathode, gains electron because it undergoes reduction. At cathode, reduction takes place, means it will going to gain electrons, balance it out, and that will going to give you hydrogen gas. Hydrogen gas will be liberated at cathode. On the other side, Cl minus ion will be attracted towards positive side because as we all know, negative and positive attract each other. Cl minus goes towards anode. And there would be loss of electrons because at anode, oxidation takes place. Oxidation means loss of electrons. That results into formation of chlorine gas. And please do not forget to balance the reaction. So chlorine gas will be evolved at anode. Hydrogen gas will be evolved at cathode and NaOH will be collected near cathode. Guys, this is where question comes in your section A, MCQ. Where hydrogen is collected? Hydrogen collected at cathode. Where chlorine is collected? At anode. From where NaOH is collected? Near cathode. Clear? This is your 5-mark answer along with the diagram and reactions. Cool? Cool? Abhishek, because chlorine is formed, alkali, which is NaOH is formed, so we call it as chloralkali. Yeah? Okay. Okay, guys, cool. So this is chloralkali. But as I told you, NaCl, we don't give much of importance to sodium chloride, though it is used in so many industries. See, if there would be no sodium chloride, there would be no hydrogen, there would be no chlorine, there would be no NaOH. Imagine, if there is no chlorine, there would be no swimming water which will be chlorinated. So, NaCl is responsible for the preparation of these compound, which results into further use in application and other industries. Like hydrogen is used as fuel. Hydrogen is used as margarine. What is margarine? Margarine is a tasting agent that we used over breads. That is called as margarine. Ammonia for fertilizers, where hydrogen is used. Further, it is used for cleaning steel, for medicines also. HCl has been used where hydrogen and chlorine will combine. Chlorine is used for water treatment, for swimming pools, for PVC, for disinfecting, CFCs, pesticides, etc. NaOH is used for degreasing metals. In fact, it is also used for fiber industries as well. And this all has happened because of NaCl was added into water in presence of electricity. And all of this has happened because of this reaction. So now, from now onwards, we will give some importance to sodium chloride. All right. Now, sodium chloride indirectly also affects some industries like bleaching powder. Bleaching powder is not using sodium chloride directly. Instead, it is using chlorine from chloralkali process. You remember, NaCl added with water gives you NaOH plus chlorine plus hydrogen. So this chlorine, which is produced during chloralkali process, further used for preparing bleaching powder. So this is how indirectly NaCl is participating in this industry. So dry slag lime reacts with chlorine, gives you bleaching powder, which is calcium oxychloride, plus hydrogen will be given, water will be given you as a byproduct. Next part, which is important and something you guys ignore, are uses. Please do not ignore uses. You think that it's not important, it will not be asked in paper, but trust me guys, uses are as important as preparation, and they do compile a question. They'll ask you, prepare bleaching powder, give 2 uses. So uses are always asked in paper. So what is the basic use of bleaching powder? For bleaching wood, for cleaning clothes, white clothes specifically, bed sheets and shirts, for industrial purpose, as an oxidizing agent, and also for the manufacture of chloroform. Do you remember this reaction? Tell me in chat box, do you remember the preparation of chloroform, guys? Margarine, Shanta. Yeah. Yes, Naitik. Margarine hota hai. Margarine is a tasting agent over bread that we use now. It's called margarine. Yes, Ashwini. Good job. Yes. No, Hina. No. Alright guys, I hope good to go, all set. Moving on to baking soda. How many of you like pakoda, especially if it's raining and we are eating pakoda and chai? How many of you like that moment? Yeah? Because Abhishek, it reacts with acid bhaji and sodium bicarbonate. It's made up from carbonic acid and sodium hydroxide. So carbonic acid is weak. Sodium hydroxide is a stronger base. So strong base reacting with weak acid will be giving you a basic salt. Okay. So many of you now. So I also love to have pakoras during rainy season, especially with a cup of tea. But imagine if pakoras are not crispy. We will not like it now. So pakoras will be made crispy by the addition of baking soda, and from baking soda is being prepared. So baking soda is being prepared using sodium chloride. So now can you imagine, sodium chloride is helping preparing baking soda to make your pakoras crispy. So what is the preparation? Firstly, what is the formula of baking soda? NaHCO3, which is sodium bicarbonate, which is also called as sodium hydrogen carbonate. bicarbonate or hydrogen carbonate. It's part of the same thing. And it's a very mild basic salt. Now, again, what are the uses of baking soda? Used for making baking powder. Do you know a difference between baking soda and baking powder? Huh? Difference between baking soda and baking powder. Baking soda is used to prepare baking powder, which helps to make cakes fluffy because it produces carbon dioxide. It makes cakes and breads very, very fluffy. Baking soda is used for an antacid. It is also used for soda acid fire extinguisher and also used for cooking. I hope it is clear till here. Yeah. Now let me tell you how baking soda is prepared. So preparation includes NaCl plus water plus ammonia plus carbon dioxide. Now listen to this very carefully. It's important for your exam point of view. If NaCl added with water, it is called as brine solution. But if it's added with some amount of ammonia, it is then called as ammonical brine solution. And we will pass small amount of carbon dioxide through it, which results into formation of sodium bicarbonate, which is your baking soda. Along with that, ammonium chloride will be given as a byproduct. Clear, boss? Give me a thumbs up in chat box. Okay, Abhishek, after this we'll do metals and non-metals. Okay? Okay. Amazing. Alright guys, now moving on to washing soda. Let me tell you an amazing thing here. Do you know from edible stuff, we are making washing stuff? Now eat sodium chloride. Now, while eating sodium chloride, no, you will think, oh, sodium chloride is edible. Using that, we are making baking soda, which is also edible. And we are also making washing soda, which is not edible. So from edible stuff, we are making non-edible stuff. Guys, that is chemistry. That is chemical locha. So sodium bicarbonate, which is a baking soda. How baking soda was prepared? Baking soda was prepared using NaCl with water, ammonia and carbon dioxide. That results into formation of baking soda. Right? Now, using this baking soda, they have heated it, formed Na2CO3, which is soda ash. Soda ash reacts with carbon dioxide and water. That gives you carbon dioxide and water. Later on, sodium carbonate undergoes recrystallization. This is your third step. Undergoes recrystallization. Recrystallization means what? You heat sodium carbonate with water and then cool it down at room temperature. Heat properly. And then cool it down at room temperature. That results into formation of crystalline form of washing soda. That will give you crystals of washing soda, and that is Na2CO3 dot 10H2O, which is decahydrated. Sodium carbonate decahydrated, guys, is a washing soda. Clear? So it happens in 3 steps. First, sodium chloride was used to prepare washing baking soda. Baking soda on heating gives you soda ash. This is called as soda ash. Soda ash then further recrystallizes in presence of good amount of water, and that results into a formation of washing soda. Washing powder Nirma, washing powder Nirma, do this is safedi. Clear, boss? Clear. Perfect. All right. Now, uses of washing soda, we all know it's used for cleaning, right? For cleaning purpose, for removing permanent hardness of water, for glass and soap industry also, and for paper industry also, we use washing powder, washing soda, which is Na2CO3.10H2O. Now, please answer one question here. How many water of crystallizations are there in washing soda? How many water of crystallizations are there in washing soda? देखिए जरा देखिए. 10? Yes, absolutely, it is 10. Well done, guys. It would be 10 water of crystallization in washing soda. Now, on that positive note, let's see what is water of crystallization. Let's revise it quickly. So, water of crystallization, they ask you direct definition of it. Define water of crystallization. Or what is water of crystallization? Give examples. Or they can give you some formulas and they'll ask you how many water of crystallizations are there and so and so. Such kind of questions are asked in your paper. Starting up with definition part. Guys, this is the keyword. If you do not write this part, you lose marks, definitely. So water of crystallization means fixed number or definite number of water molecules attached to the loose chemical combination of a compound. Like for example, I talk about copper sulfate pentahydrated. So copper sulfate is surrounded by loose bonding with 5 water molecules. 1, 2, 3, 4, 5. So what is the formula? CuSO4.5H2O. So these 5H2O are loosely bonded to this particular salt. So this shows loose bonding. Dot means loose bonding, guys. This dot means loose bonding. 5 water molecules will always be fixed, and that is your water of crystallization. Alright? So that fixed water molecule attached with loose chemical bonding with this particular salt is called as water of crystallization. So if question comes to you, how many water of crystallizations are there in blue vitriol? 5. How many water of crystallizations are there in gypsum? 2. How many? CaSO4.2H2O. So there would be 2 water of crystallization in gypsum. How many water of crystallization are there in green vitriol? Ferrous sulfate. How many water of crystallizations are there in green vitriol or ferrous sulfate? 7. FeSO4.7H2O. 7H2O called as heptahydrated. How many water of crystallizations are there in POP? Let's see. How many water of crystallizations are there in POP? Plaster of Paris. Half. Yes, it will be half, called as hemihydrated. Now, next question, 2 marks. What is the significance of water of crystallization? Guys, you can write this down because that can be asked in your paper. What is the significance of water of crystallization? What is the significance of water of crystallization? It provides the color to the compound. It also provides the crystal structure to the compound, and we can prove this. We can prove it very easily. These 5 water molecules is giving it blue color. These 5 water molecules providing it a crystal structure. How come? Let's prove it. Now let's say if I have blue color of green blue vitriol, copper sulfate pentahydrated, I take it into a test tube, heat it onto a flame directly. Okay? I'm heating it. That turns into copper sulfate and all water molecules will be evaporated, will be vaporized. So earlier with 5 water of crystallization, it was blue color crystals. But after heating, it loses all the water of crystallization, turns into white color powder. And how is that so? What is the reason behind that? Earlier it has water of crystallization. Once it is lost, color is gone, crystal structure has been gone. So we can prove this. Because of that, we proved it that water of crystallizations are responsible for the color and crystalline structure of the compound. So these are two significance of water of crystallization. Now, what is the name of this compound? Blue vitriol. Is it a hydrated form? Yes, it is hydrated. So please remember a difference between hydrous and anhydrous. Anhydrous means without fixed water molecules. Hydrous means with fixed amount of water molecules. That means water of crystallization. Clear, boss? Give me a thumbs up in chat box. Clear? Cool. Cool, cool, cool. Okay. All right. Chale. Moving on to our next example of water of crystallization, and that's none other than POP, which is plaster of Paris. So, plaster of Paris formula, as I asked you before, how many water of crystallizations are there? And all of you have told half water of crystallization means hemihydrated. But why it is half? Sorry, why it is half water molecule? What is the use of this half water molecule? Why it's not one? So let me tell you this part, guys. Calcium sulfate, 2 calcium sulfate owns 1 molecule of water. 2 calcium sulfate is bonded with 1 water molecule. Therefore, simple maths. 1 calcium sulfate will going to own half of water molecule. Simple. 2 calcium sulfate own 1 water molecule. Therefore, 1 calcium sulfate will going to own half water molecule. That's the significance of half. There is no rocket science behind it. It's all because of the bonding and the structure. So CaSO4.half H2O is the formula of POP, where it is called as calcium sulfate hemihydrated. Now you can ask your parents also. Your parents must be knowing this. Do we do POP during rainy season? No, we avoid. We avoid doing POP during rainy season. Why? Because if POP gets little bit of moisture into that, that white color powder will turn into a white solid hard mass of calcium sulfate dihydrated, which is called as gypsum. Anyone who got fracture, I wish, I hope, no. But ever if you have experienced or your friends have experienced fracture, we always end up writing some stuff on their hand, right? Because it's hard solid mass. Earlier, it was a powder which is used to prepare that hard solid mass. So doctors put a powder in water and they coat it on the hand, which make it as a gypsum hard solid mass, which provides support. Not only that, POP is also used for making sculptures. It is also used for making false ceiling. Yeah. Right? So I hope you all are aware about it. Chale. So now it's time. It's time for you to answer some questions. So ready, steady, go. Chalo, jaldi se mujhe bata do. Quickly tell me, how's the Josh? Very steady, po. Yeah? How's the Josh? High? Very high? It has to be high, man. So we are very close to the victory now. We cannot give up. We cannot give up. Full high. All right. Moving on to the question. Let's solve it. Jagdevate. Farmers utilizes the effect of acidity on the soil by adding slate lime, gypsum, caustic soda, baking soda. Come on. Farmers utilizes the effect of acidity on soil. So I'll be giving you poll here. Be ready. We are solving question number 1. 30 seconds starts now. Come on. A, B, C, D. And 3, 2, 1. That's it. Time's up, guys. So it is definitely A. A is absolutely perfect answer. 100% of you. Hats off. Good. Dhruvika, Ashwini, Shakira, Adiba, Priya. Attitude Stadius video. क्या बात है? ASV, one Shikha, nature of knowledge. Okay, guys. Good. Not bad. Not bad. बहुत बढ़िया. So it is definitely slake lime here as an answer. Moving on to question number 2. Which salt is a neutral salt? I'll give you more time here. You need more time to find out the answer. What salt is a neutral salt? So let's give you 45 seconds this time. Ready? Shall I start? Let's begin. Come on, come on, come on. I'm getting D, B as the answer. D also, B also, C. Why you have left A, right? A also. A, B, C, D, E, F, G, H, I, J, K, L, M. Okay. All right. 2, 1. And time's up. Answer is actually option B. Ouch. Ouch. Some of you have answered it right. Oh, chaliye. Let's find it out. Why it is option B, I'll tell you. Ashwini, very well done. You just took few seconds, so high five. Good job. Bhumika, AVS, Deepika, Rash, Regi, and Radha. Uh, yeah, so let's see. Let's focus. What is a neutral salt? Neutral salt is when strong acid reacts with strong base that always give you a neutral salt. It could be this situation, guys. Either it could be a this strong acid, strong base, or it could be weak acid reacting with weak base. That also results into a neutral salt. If you've not forgotten this, I've told you, if weak acid and weak base react with each other, they also results into a formation of a neutral salt plus water. Now, looking at NH4Cl. NH4Cl was prepared when ammonium hydroxide, let's look at the A1. Ammonium hydroxide reacts with HCl. Okay? It's a strong acid reacting with a weak base. That will give acidic salt. B. CH3, CH3, COO, NH4. It is prepared from CH3, COOH plus ammonium hydroxide. Guys, both of them are weak. It's a weak acid. It's a weak base that results into a neutral salt, ammonium acetate. What is the name of this salt? It is called as ammonium acetate. Fine? And this is actually your neutral salt with pH is equals to 7. I hope it is clear. Clear, clear, clear? Yeah. So option B is your answer. Moving on to metals and non-metals. Now, before we jump on to this chapter, let's take a quick break. Yeah, break. Toilet break. Yeah, I'll give you a break. Guys, lunch break. Let's keep it for 20 minutes. Oh, 20 minutes it is. Cool? Lunch हो गया मेरा नहीं हुआ है. Let's have 20 minutes of lunch break. Don't drink. Start. Let's catch up after 20 minutes. Hmm. Hi आर्मी लवर. तुम लोग का अलग चलता है ना चैट बॉक्स में. हाय प्रात्याक्ष. हाय दिनेश. All right, so yeah, let's begin. I think one more minute and we'll start. Uh, Thank you, Liz. Hi, Makrant. Hello. इसके नोट्स सब मिल जाएंगे बच्चे आपको. I'll share. सेव कर लो ना वीडियो. All right. Namaskaram, Kamlesh. Chale guys, I think 1 minute is done. So let's begin with our next chapter, metals and non-metals. And after this chapter, we'll be starting up with carbon and its compound. So I hope you all are rejuvenated again, have ate something, hydrated yourself. So sit tight and let's enjoy. And are you ready to go on a quick ride with me? Yeah? Ready, steady, po? Okay. So starting up with the basics of metals and non-metals. Oh. Okay. So as you all know that metals have a tendency to lose electrons. Like if we see some examples of metals, gold, silver, calcium, magnesium, aluminium, iron, copper, right, platinum, these are all examples of gold. And gold always have the ability to lose its electron and become positively charged ion, which we call it as cations, right? So metals have a tendency to lose electrons and therefore they are electropositive in nature. What does electropositive means? Elements which have a tendency to lose their valence electrons to attain stability. On the other hand, non-metals are opposite. They love to gain electrons. They are greedy kind of elements. Once they gain electrons in their valence shell, they attain stability, they complete their electronic configuration and attains negative charge on them. Negatively charged ions are called as anions, and the elements which gains electrons and which have a tendency to gain electron are called as electronegative elements. So metals are always electropositive. They will always form positive ion. Non-metals, on the other hand, would love to gain electrons, become negatively charged ion. They are always electronegative. For example, non-metals like fluorine, chlorine, bromine, iodine, nitrogen, phosphorus, sulfur, and so on and on and on. There are ample amount of non-metals available in nature. Okay. Now, as metals and non-metals are available in nature, but we should always know that how do metals exist in nature? Are they available in combined state? Are they also available in free state or not? Yes. Metals being electropositive, they always love to lose their electrons. And as they lose their electrons, they combine with some other anion and exist in nature in form of compound or combined form. Like sodium exists as sodium chloride, potassium exists as potassium chloride, calcium exists as calcium carbonate, potassium also exists as potassium carbonate, magnesium being a metal exists as magnesium carbonate, copper exists as copper sulfide, zinc exists as zinc carbonate, zinc sulfide, and so on and on and on. So metals are available in nature in combined state because of its stability. Whereas there are few metals which exist as free state also. Free state is also called as native state, or it is also called as elemental state. Why? Why they are available in free state in nature? Because of its stability. Like gold, platinum, they are so stable that they do not want to react. Their reactivity is so less that they will not make a bond to survive. They will not be in a combined state. So they are found in free state or elemental or native state in nature. Now, as we are talking about metals and non-metals, let's revise quickly the physical properties of metals and non-metals. And if I'm not wrong, you guys are learning this since your grade 7. Isn't it? You're learning this since your grade 7, na? So you're all aware about the basic difference between metals and non-metals, like ductility, sonority, lustrous behavior, electrical conductivity, thermal conductivity, and so on. But the most important part for your grade 10 board exams are exceptions. So guys, exceptions are the most important part for your board exams. We all know that metals are lustrous. Everyone knows that metals are non-lustrous, but there is one metal or one non-metal. Tell me one non-metal which is which is lustrous. Come on. Give me one non-metal which is lustrous. Exceptional. Yeah, Kumar. Not found in free state, bache. Iodine, yes, anonymous. High five, good job. Iodine is one such non-metal which is, being a non-metal, is lustrous. It's a purple color crystal. Diamond is also lustrous. Now, talking about the state, usually metals are solid in state, but mercury is one of the metal which is present in liquid state at room temperature. So this is one of the important one for your exam point of view, not only for your board exams, but also for your competitive as well. Talking about non-metals, non-metals are solid also, liquids, gases also, but there is one liquid non-metal, and that is none other than bromine. Bromine is an exceptional liquid non-metal present in nature. If we talk about hardness, metals are hard. Like if you take an iron rod, obviously iron is very hard. Copper, gold, silver, platinum, metals are usually very, very hard, except there are exceptions. Na curly. That's in Hindi, but you can remember it straight away also. Sodium, potassium, lithium. These three metals are so soft that can easily be cut with knife. In fact, your house knife can also cut these metals. They are so soft, have very low density. On the other hand, non-metals are generally softer, but diamond is one such exception and known to be as one of the hardest natural known substance on Earth. Based upon density, metals have high density, non-metals have low density. Malleability, ductility. Ductility means to turn into wire. Metals have the ability to be turned into thin wires, like copper wire, which is used in our electrical fittings. Malleability. To understand malleability, let's understand about one of the most favorite sweets of ours, that is Kaju Katli. How many of you like Kaju Katli? Tell me in chat box. How many of you like Kaju Katli? Nahi, Kumar Divakar, I'll come on that point. How many of you like Kaju Katli? I love Kaju Katli. Kaju roll. है ना? So we have seen silver foil has been coated on Kaju Katli. That foil has been made because of the ability of a metal to be malleable. Malleable means turning into thin sheets. In fact, gold is the most malleable metal. Gold is the most ductile metal also. So, ductility, malleability, where gold wins. Gold is number 1. Now, based upon conductivity, there is 2 types of conductivity, heat and electricity. Metals are good conductor of electricity, whereas non-metals are not good conductor or poor conductor except graphite. Graphite is an exceptional non-metal which is actually a good conductor of electricity. In carbon and its compound, I'll give you a complete reason behind why graphite is a good conductor and why diamond is not a good conductor of electricity. That is 2-mark question for your board exam. Now, alloys, obviously metal make alloys. Non-metal also participates in making alloys because alloys are what? A homogeneous mixture of metals and metals or metals and non-metal. So they do participate. Conduction of electricity, as I told you, metals are good conductor whereas non-metals are bad. One of you have asked me a question. Let me correct you here, Divakar, I think. So, cesium is not liquid at room temperature. Please make sure you do not write this thing. Mercury is the only metal which is at room temperature. Guys, cesium and gallium are 2 metals which has exceptionally low melting point. Usually, metals have very high melting point except these metals which has exceptionally very low melting point. Like our normal room temperature is what? Our normal room temperature is 25 degrees Celsius. These metals have melting point of 29.5 degrees Celsius approximately. Now, see the difference. They'll start melting even if you keep it on your palm, but they are not liquid at room temperature. So please do not make this mistake. They are not liquid at room temperature, but they have exceptionally low melting point. They will start melting even if you keep it on your palm. So from your palm heat only, they will start melting. Clear, boss? I hope you will not make that mistake ever. Now, as we have talked about the physical properties of metals and non-metals, now it's time for us to learn about chemical natures of metals. Ready? Steady? Po. There would be a lot of reactions learning today. Yes, Kumar. Yes, absolutely. Yeah? Ready, steady, po. Let's learn some chemical nature together. So, metals have reactivity towards different element. Now, problem is some metals react vigorously, so fast. Some metals react, okay types, moderately. Some metals do not react. So, how will we get to know that which metal reacted, which metal does not react? Let's take a look. Normally, when metal react with oxygen, what is the general reaction when metal react with oxygen? That results into formation of metal oxide. Like for example, the most common example you guys are learning since your chapter number 1 is when magnesium reacts with oxygen, that forms magnesium oxide. Similarly, when copper has been burnt in presence of oxygen, that forms copper oxide. When potassium reacts with oxygen, that forms potassium oxide. When sodium reacts with oxygen, that forms sodium oxide. But what is the difference between all of these reactions? There has to be some difference, right? They are all giving metal oxide, but some of them are giving the product at room temperature. Some of them are vigorously reacting and giving product at room temperature. Some of them requires prolonged heating. You have to heat them in presence of oxygen for a long period of time to get the product. And some of them will make a product at lower temperature also. So, they all will react and make metal oxide, but the difference will be based upon temperature. So, sodium and potassium, 2 metals, highly reactive, placed on the top of reactivity series. So, obviously, they will react so vigorously. You cannot keep these metals out in air. One question. Why we keep sodium and potassium dipped into kerosene oil? Why we store them into kerosene oil? This is why. Because they tend to react vigorously with oxygen at room temperature. If I keep sodium piece out without dipping it in kerosene oil, it will burn. Literally, it will burn. And same goes with potassium also. So to prevent it from burning, prevent it from bursting out, we have to store them into kerosene oil to disconnect oxygen presence, to prevent it from reacting with air. Now, talking about magnesium and zinc, they do not react with oxygen at room temperature, but instead they require strong heating. Now, if we talk about copper, if we talk about iron, they require prolonged heating. Prolonged heating is required to make product here, to react metal with oxygen and create metal oxides. So they will all react. Instead, silver will not react directly with oxygen. Gold will not react with oxygen. Platinum will not react with oxygen. So there are few metals which are called as noble metals. Noble metals means metals which do not react and have least reactivity are called noble metals. So they will not respond towards oxygen at any cost. Now, as we have got metal oxides, metal on reacting with oxygen give us metal oxide. But are metal oxides going to further react? Yes. Some of the metal oxides have the ability to get dissolved into water and give alkali, like sodium oxide, potassium oxide. These are two metal oxides which can easily get dissolved into water and form respective alkali. Sodium dissolves into water. Sodium oxide dissolves into water, forms sodium hydroxide as an alkali. Potassium oxide dissolves into water easily and form potassium hydroxide, which is again an alkali. So they are basic in nature, and because they are basic in nature, they can easily react with acids. Whereas, twist, where is that twist come? Whereas there are few metal oxides which are amphoteric in nature and can react with acids also and bases also easily. Zinc oxide can react with acid, and what will it form? It will form zinc chloride and water. Aluminium oxide reacts with NaOH. Please do the honors. Give me a reaction here. Give me a product. Very nice. Blissy. Perfect. Give me a second one. Answer for the second one. High reactor door. Come on, come on, come on. Yes, very nice, Priya. Good job. So it will give you sodium aluminate, NaAlO2. And along with that, it will not give hydrogen, it will give water. Da. Please. Guys, listen, listen, listen. Common mistake in your paper. Please do not repeat this common mistake in your paper. If a metal like zinc or aluminium reacting with a base, that will result in formation of salt and hydrogen gas. If it's a metal oxide like zinc oxide or aluminium oxide, guys, there is oxygen present here, reacting with a base, that will result in formation of salt and water. Please make sure that will result into formation salt and water as a byproduct. If you go wrong with the byproduct, you will get 0 marks. Byproduct is equally important as your product. So please make sure you do not go wrong with it. So aluminium oxide being amphoteric can react with base also. It can easily react with acid, form aluminium chloride and water. Similarly, zinc oxide can be reacted with a base which is NaOH, and in return that gives you sodium zincate, Na2ZnO2 plus water. Simple, easy peasy, lemon squeezy. Yes, absolutely right, Kumar. Yes, I'm gamer 1. Pretty good. Alright, moving on to second chemical locha of metals. Do metals react with water? Do all metals react with water vigorously or not? Do metal react with hot water or steam or cold water? To answer all of these questions, I have a trick for you. Let's follow this trick, guys. If metal reacts with water, that either gives you metal oxide or hydroxide and hydrogen gas. Listen to this carefully. If metal reacts with water, it either gives you metal oxide or hydroxide and hydrogen gas. But how will you get to know? How will you remember and learn which metal reacts with cold water, hot water or steam? Which metal on reaction with water will give you hydroxide or oxide? So, this is your reactivity series, and I'm pretty much sure you guys have learned reactivity series till now. If not, there is a simple trick you can use. Please stop calling me a zebra. I like her calling me smart, goat, guy, girl, whatever you want to. Right. So that's your reactivity series. Now, first three metals will react with cold water. Okay. Magnesium reacts with hot water. Aluminium, zinc and iron reacts with steam. One thing, salt. Now you can remember which metal reacts with cold, which metal reacts with hot and which metal reacts with steam. Now, whether it will make oxide or hydroxide, first three metals on reaction with cold water will form hydroxide of the metal. So that will form KOH, NaOH, calcium hydroxide. Along with that, obviously hydrogen gas will be given. Now only first two reactions will be exothermic. Why? Because these two are so reactive with water that it produces large amount of heat. So only first two reactions will be considered as exothermic reactions. Now moving on to magnesium. Magnesium reacts with hot water and it forms magnesium hydroxide again plus hydrogen gas. Now let's take a look on aluminium, zinc and iron. So there is a love story going on here. Aluminium, zinc, iron, they are in true love with oxygen. So they will always going to create oxide of the metal in presence of steam. So they will give a steamy, lovey-dovey reaction. Steamy reaction where aluminium will form its oxide, which is aluminium oxide. Zinc will form its oxide and iron will form oxide, which is Fe3O4. Along with that, hydrogen gas will be released or evolved. I hope that is clear. Voila. Clear, clear, clear? Perfect. Okay. Now, next question which arises to your mind is, what is Fe3O4? Fe3O4 is called as ferrous ferric oxide. It is the mixture of two valencies of iron which forms ferroferric oxide, which is also called as magnetic iron oxide. It is also called as magnetic iron oxide. Rest of them will show no reaction at all. No reaction with water. So you have learned these reactions all at once. With a simple trick, you have learned so many reactions. Cool? Cool, cool, cool. No, it's not Fe2O3, but it's Fe3O4. Huh? Okay. All right. On that note, let's move on to our next chemical note, our next chemical property of a metal. What happens if metal reacts with dilute acid? Does all metal react with dilute acid? No, not at all. Metals react with acid, give you salt and hydrogen gas, but only active metals react with acid. What are active metal means here? Active metals which comes above hydrogen in reactivity series. That's very obvious now. If I give you copper reacts with HCl, copper is less reactive than hydrogen, so it will not give this reaction. Instead, if I tell you zinc react with HCl, yeah, this is possible. This metal react with acid and give respective salt and hydrogen gas. This is possible. Why? Because zinc is more reactive. It's the active metal which comes above hydrogen in reactivity series. Cool? Clear, boss? Yes, absolutely, Kumar. Yeah. Heat will be evolved out. Yes, Priya, it will be only evolved in potassium and sodium once react with water because they are highly reactive. They are vigorously reactive towards water. Okay. All right. On that positive note, let's move on to further reaction. Tell me what will be made if Na is reacting with HCl. Come on, guys. That's on you. That's on you, guys. Sodium react with HCl. Sodium reacts with HCl. That gives you NaCl plus water. That gives you NaCl plus water. Sodium reacts with H2SO4. That gives you, again, salt and, hydrogen gas. My bad. And hydrogen gas, which is Na2SO4 plus hydrogen gas. Cool. Formula is wrong, Kumar. Just check that formula once. Yeah, it's Na2SO4 plus H2. Next reaction, Fe reacts with HCl. Chalo. Complete it. It's your homework. Okay. Now, based upon this, they have found out that some metals react vigorously with its acid, but some metals give a moderate reaction, like potassium and sodium, calcium, magnesium. They react so vigorously with acid. But if we talk about iron, if we talk about aluminium, and so on, as we are going down in reactivity series, vigorosity of a reaction will going to reduce eventually. Copper will not going to give reaction. So after hydrogen, metals will not going to give reaction with acid because of its less reactivity as compared with hydrogen. On that positive note, let's talk about aqua regia. We are talking about acids. We are talking about concentrated acid. I have even told you before that acid does not react. Base and base will not going to react. But what is happening under aqua regia? Guys, aqua regia is nothing but it's also called as royal water, which is a mixture of two concentrated acid, specific concentrated acid in a proper composition, in a proper proportion. So it is a mixture of 1 part of HNO3 and 3 parts of HCl. 1 part is to 3 part. 1 test tube of HNO3 concentrated and 3 test tubes of concentrated HCl. That will going to form aqua regia or royal water, which has the ability and the power to dissolve noble metals like platinum can be dissolved, gold can be dissolved in it. And please mind it, guys, from this you get case-based question. That's important. From this aqua regia part, they'll give you case-based question which carry 4 marks. Can you imagine? Just one line can give you 4-mark question, case-based, which is your section E. Yeah, no, XYZ, it's not, but no. Yep. All right. Now, as we have learned about what happens if metal reacts with oxygen, it forms metal oxide. Metals react with water. It forms either metal oxides or metal hydroxide. Metal do react with acid to form salt and hydrogen gas. But what happens if metal reacts with metal solution? This reaction has already been done by you in chemical reactions and equations under displacement reaction. Zinc reacts with copper sulfate. A metal is reacting with a metal solution. Is this reaction possible? Tell me in the chat box, is this reaction possible? Yes or no? Yes, it is possible. Absolutely. So zinc will displace copper from its position, form zinc sulfate plus copper. So blue color solution of zinc sulfate will turn into colorless solution of zinc sulfate with brown color of copper deposited on the surface. Copper reacting with zinc sulfate. Please tell me what would be the product form. Second one, what would be the product here? Come on, guys, keep it, man. All right, no reaction, Priya. Good job. High five. Yes, there would be no reaction in this case. Why? Because copper, being less reactive than zinc, will not allow copper to displace zinc from its position. So there would be no reaction, no change. How are you feeling, guys? As we are coming towards the end of this chapter, coming towards the end of today's session, 2 chapters already finished. How you feeling? Hi? Okay. Good. Good to know that. Good to know that. बहुत बढ़िया. चलिए guys, chakde fateh. Let's move on with the same energy, with the same josh. Let's solve some questions. Okay, which gas is produced when dilute hydrochloric acid is added to a reactive metal? Write the chemical equation or chemical reaction when iron reacts with dilute H2SO4. Come on. Come on, come on, come on. Which gas is produced when hydrochloric acid is added to reactive metal? Yes, that's none other than hydrogen gas. Bahut badhiya. Very good. It's none other than hydrogen gas. Right? Chemical reaction when iron reacts with dilute H2SO4. When iron reacts with dilute H2SO4, that results into formation of FeSO4 ferrous sulfate with the evolution of hydrogen gas. Cool. Do balance the equation. If you do not balance the chemical equation, you will definitely end up losing marks. Why is sodium kept immersed in kerosene oil? I asked you this question before also, and it's important for your exam point of view. Sodium vigorously reacts with air and forms sodium oxide, which actually burns. Right? Sodium burns in presence of oxygen. It vigorously reacts with oxygen. So to prevent it from coming in contact with oxygen, we immerse it into kerosene oil. So basically, kerosene oil prevents it coming in contact with oxygen. Okay? Yeah. Right. Highly reactive. Okay. Next question on your screen. What would you observe when zinc is added with iron 2 sulfate, FeSO4? Write the chemical reaction involved. What do you observe? Observe, guys. Observe means you have to mention the color here. Because, yes, Priya, that's right. Come on. What do you observe? Colorless. What colorless? So see, earlier zinc, when added with ferrous sulfate was earlier green in color. Once reaction takes place, that results into formation of zinc sulfate plus iron. Is this reaction possible? Is this reaction possible, firstly? Yeah? Acha, let me take you zinc and iron. Hai na? Let me take you to reactivity series. Let's go to reactivity series, guys. I'm taking you back to reactivity series. Zinc and iron. Zinc, being more reactive, can displace iron from its position. So yes, this reaction is possible. Zinc is more reactive than iron. Okay, I'm taking you back to the question again. Zinc is more reactive than iron. So yes, zinc has the ability to displace iron from its position. So green color will eventually turn into colorless color of zinc sulfate solution. Now, whenever they ask you a question related to what do you observe, then you have to give the color of reactant also and product also. Guys, please practice in such a way. While you're writing the answers, you should mention the color of reactant and product both. Green color of ferrous sulfate will turn into colorless solution of zinc sulfate as zinc displaces iron from its position. And this is your chemical equation. Done and dusted. Voila. Clear? Okay. Alright guys, now moving on to what happens if metals and non-metals interact with each other. Will there be a lovey-dovey part here? Yes. So metals are caring one. Metals love to lose electrons, whereas non-metals are very greedy and they love to gain electrons. So metals will going to transfer its valence electrons to a non-metal, results into a formation of oppositely charged ions, cations and anions, and that will going to form the strong electrostatic force of attraction, and that results into ionic compound or ionic bond. So transfer of electrons needs to be shown with the arrow. Metal will transfer its valence electron to a non-metal which love to gain in its valence electron. That will result into formation of M positive cation, non-metal negative ion, anion. Plus and minus attract each other. That attractive force is electrostatic force of attraction, which is quite strong. They were going to result into formation of ionic bond, which is also called as electrovalent bond, and a compound formed is called as ionic bond, ionic compound or electrovalent compound. Now, how questions are asked in your paper? Questions are asked on formation of NaCl, formation of aluminium chloride, using electron dot structure. So let's practice. How will you form sodium chloride? Using electron dot structure. Rule number 1, you always have to write electronic configuration. Please mention electronic configuration. Sodium atomic number 11, electronic configuration 281. Chloride atomic number 17, electronic configuration 287. Now the best part of electron dot structures is that you only have to consider valence electrons. That's it. You don't have to worry about inner electrons. Let's focus on valence electrons. Show them by dot and cross. Sodium has 1 valence electron. Chloride has 7 valence electrons. 1, 2, 3, 4, 5, 6 and 7. Now, everyone needs to attain stability by completing their valence shell, by completing their electronic configuration. So if sodium transferred 1 electron to chlorine, that chlorine become 8 electrons. Octet will be completed for chlorine. So transfer of electrons will happen. As sodium loses 1 electron, that become Na plus 1. Electronic configuration would be complete. On the other hand, chloride ion will going to gain 1 electron. Its octet would be complete, forming 1 minus. Plus 1, 1 minus, there would be a strong force of attraction, and that results into formation of sodium chloride. Voila, that's it. Simple, easy peasy lemon squeezy. Now, yes, Hianshi, it is enough, bache. So one thing which is very important is transfer. Transfer needs to be shown with the arrow. If you don't write and mention this arrow in your paper, half marks gone straight away. So be careful. Transfer needs to be shown with the arrow from metal towards non-metal. Electrons should be shown with dot and cross. That's your valence electrons. Ions should be shown properly. Positive, how many positive, how many negative, okay? Positive always come first, negative will always come later. Practicing next part, aluminium oxide. Let's practice this one. I always get a doubt for this. Ma'am, how will we make electron dot structure for aluminium oxide? So I thought to keep this question for you all. Let's do it. Yeah. Aluminium, electronic configuration, oxygen, electronic configuration. Come on, tell me. Aluminium's electronic configuration. I'm waiting, I'm waiting. Come on, guys, you can do it. How will you write? Oxygen, atomic number 8, electronic configuration 2,6. Yes, very good, Vanshika. It would be 2A3. Yeah. So 3 would be its valence electron. Aluminium, 3 electrons in its valence shell. Right? 3 electrons I've depicted with cross here. On the other hand, it's oxygen. How many oxygen? 3. There are 2 aluminiums. 2 aluminium with 3 electrons. Oxygen 1, 2, 3. Al2O3. 3 oxygen. Each oxygen will have 6 valence electrons. So how will I show? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let me show this with dot only. Let me show this with dot, bache. Yeah. 1, 2, 3, 4, 5, 6. Okay. Aluminium needs to eagerly lose 3 electrons. One aluminium needs to lose 3 electrons to attain octet configuration. Oxygen requires 2 electrons to complete its octet configuration. Now look here carefully. So there would be a transfer of electron. How many is required with this oxygen? 2 more electrons are required. This aluminium is like, okay, I'll give you 2 electrons. Happy? This one, I require 2 electrons. So one aluminium will give 1 of its electron. Other aluminium will give 1 electron. Sorted? Third oxygen also requires 2 electrons. So second aluminium has rest of 2 electrons which will be transferred towards oxygen. So aluminium has lost it all 6 electrons. 2 aluminium has lost their electrons. So now it will be Al3 plus. Al3 plus, because both of them loses their 3 valence electrons. Oxygen 2 minus, oxygen oxide 2 minus, and this is 2 minus. 3 oxide ions have been prepared. Yeah. So can I write 2Al3 plus 3O2 minus? Can I write this way? Can I write this way? 2Al3 plus, there are 2 aluminium, each of 3 plus. 3 oxide ions, each of having 2 minus, O2 minus. Done and dusted. Khatam. That's it. You have made Al2O3, guys. That's how you show the formation of aluminium oxide. Cool? Cool. Magnesium chloride is your homework, which is again easy peasy lemon squeezy, and I hope you all can do it. Yes. Okay, magnesium chloride, easy one. You can do it. Aram se. Now, moving on to metallurgy part, which is the biggest part of your metals and non-metals. Guys, till now we have gone through a very basic things of metals, like physical properties of metals, chemical properties of metals and non-metals, and now it's time for you to start with metallurgy part. Metallurgy is the place where you will get maximum number of questions, and let me tell you, metals and non-metal chapter have majority of weightage. So majority of weightage will be there with metals and non-metals and carbon anions compound. So be ready for long answer questions from this particular chapter as well. And metallurgy will give you questions in your section E and section D. So be prepared for that part. So let me take you through this. What is metallurgy? I'll try to make this very easy peasy for you guys. Metallurgy, to understand that, there are few definitions that you need to go through, which you've already learned in geography. Minerals, ores, you're already aware about it. What are minerals? Elements and compounds which is extracted from the earth crust naturally. They are called as minerals. What are ores? Those minerals from which metals can be extracted profitably and conveniently are called as ores. What are minerals? Natural process where elements and compounds are extracted from earth crust. So stone, mica, gems, clay, bauxite, they are all minerals. But only those minerals from which metals can be taken out, metals can be extracted profitably and conveniently, easily, those minerals are then categorized as ores. Note, please tell me whether it's true or false. All ores are minerals, but all minerals are not ores. True or false? Yes, Anup. Yeah, true. Yes, it's absolutely true. All ores are minerals. Whatever ores have been made, they were minerals eventually, but all minerals cannot be ores. Why is that so? Let me tell you. Let me give you one simple example here. I have clay with me and bauxite. Okay, both have a common metal present in them, that's aluminium. Clay also have aluminium, bauxite also have aluminium. But problem is that I cannot extract aluminium from clay. I cannot extract aluminium from clay because it's not convenient, it is not easy, it's not giving me good amount of yield or product. So this is a proper waste of time. Now, whereas bauxite, from bauxite, I can easily extract aluminium, easily, conveniently, profitably, in a good amount of percentage yield. I get a high amount of yield in that. So, this particular bauxite will be called as ore, whereas clay is just a mineral. They both have been extracted naturally from the earth crust, but clay is not allowing us to extract metal from it profitably and conveniently. So it is considered just to be as a mineral. But those minerals from which metals can be extracted, only those minerals are then categorized as ore. So bauxite is a ore, whereas clay is not passed as ore. It is just considered to be as mineral. These are some examples of ores given to you on screen, which includes hematite, which is the ore of iron from where iron can be extracted. Magnetite, from where iron metal can be extracted. Bauxite, as I told you, it's the ore of aluminium from where aluminium metal can be extracted, but using certain techniques. Zinc blende, zinc can be extracted. Cinnabar is the ore of mercury from which mercury can be extracted. Calamine, from which zinc can be extracted. But again, it comes down to a process. How we can extract these metals. There are certain techniques that we need to follow, and this is where metallurgy comes into picture. What is metallurgy? The process by the help of which metals can be extracted profitably and conveniently, that is called as metallurgy. What is metallurgy? Process of extraction. This happens at the industrial level. Everything happens at industrial level, means on a large scale. So obviously industries want money, industries want profit, and they will only try to extract metal from those ores which can give them metals in a good amount of yield in large percentage, right? So it has to be a profitable business. So metallurgy is just a process for extraction, but this process occurs in 3 simple steps. First step, concentration of ore or enrichment of ore. Second step, once ore is concentrated, we will start extracting metal from that concentrated ore. Third step, we will refine the extracted metal. Now we'll go through these steps one by one. Are you all ready? Ready, steady, pill? Yeah? All right. So starting up with the first step, enrichment of ore or concentration of ore. Guys, this is very simple. It's all साफ सफाई, ऊपर ऊपर की साफ सफाई. How do we do it? By removing gang particles. What are gang particles? It's Gangue. It's not Gang. Please make sure you don't write that gunda wala gang. It is Gangue. These are the impurities which is removed in the first step. Simple. First step is the removal of gang particles by certain technique. Now, once your ore is clean, once your ore is free from gang particles, from all the impurities like stone, sand, mica, once it is clean, you will put it into a technique where you can extract metal from that respective ore. Now, extraction of metal from concentrated means clean ore is done based upon the reactivity of metal. Now, if metal is more reactive, there would be a different technique to extract it. If metal is moderate reactive, it has a different technique to extract it. If it's least reactive, it has a different way of extracting a metal. Now, once metal is extracted, we will put electrolytic refining on them. We will clean the metal from within by removing the impurities present within. So this is the entire summary of your metallurgy process. I'll take you through this quickly. Now, firstly, we did concentration of ore or enrichment of ore. We have cleaned the ore by removing the gang particles. Now, if metal is a part of high reactivity series like sodium, potassium, calcium, magnesium, aluminium, we will go through electrolytic reduction technique. What is electrolytic reduction technique? I'll explain you in detail later. Electrolytic reduction, in presence of, we'll undergo reduction in molten ore, and that will result into formation of a pure metal. So we'll be extracting pure metal straight away from high reactivity series. Second, if a metal a part of moderate or medium reactivity like zinc or iron, in that case they exist as either carbonate ore or sulfide ore. From carbonates and sulfides, we have to first convert them into their oxide ore by a process called calcination and roasting respectively. Once they're converted into their oxides of the metal, we will add some reducing agent into that, and that undergoes reduction, which gives you metal. So extraction of metal is done this way. If metals are a part of low reactivity, now in this case, either metal exists as sulfide ore or oxide ore. If it's a sulfide one, it undergoes roasting. You just have to simply heat it further and metal is out. There is not much of work in low reactive series. If it's the oxide form, you just have to straight away heat it and metal will be extracted. So it's the most simple way to extract the low reactive metal, the simplest technique. Now, starting up with the high reactive metal. If metals are a part of high reactivity, how will you extract those metals from their respective ores? How do they actually exist? Firstly, you have to work upon this. What is the occurrence of those metals? How they occur in nature? So, metals of high reactivity found in halide form or oxide form, like sodium chloride, aluminium oxide, yeah, which is your bauxite. NaCl is called as rock salt, as a ore. So high reactive metals are found in either halide form or oxide form. So to break this bond and to extract these metals out of it, we require a special kind of reduction technique, and that is called as electrolytic reduction. Whereas moderate reactive metals are present into carbonates, sulfides and oxides. So from carbonates and sulfides, we have to first convert them into oxide. Carbonates needs to undergo calcination and sulfide has to undergo roasting process. Once they are converted into oxides, we have to add a reducing agent to it. They undergo a process of reduction and metals will be extracted. That's voila. If metal in low reactivity series, we just have to heat the oxides alone. and metal will be out. Whereas if it's less or least reactive, in this case, metals will be found in a free state or an elemental state. You don't have to worry about it. You don't have to put a mehnat of extracting or metallurgy part. They are already present in a free state. You just have to extract it. Simple, easy peasy, lemon squeezy. Now, let's practice, let's revise electrolytic reduction, because this is where your important question comes in your paper. Questions comes from electrolytic reduction. Let's do. Are you all ready? Ready? Kya baat hai, Sanatni? Okay, all the best. All right. So now we are starting up with extraction of metal from very high reactivity, on the top of reactivity series. So let's say I have to extract sodium from sodium chloride. I have to extract sodium from sodium chloride. I will take molten form of NaCl. That's my ore. NaCl is what? It is the ore from which metal sodium needs to be extracted. One thing which you have to remember here, you always have to take the molten form. You will not take aqueous form, guys. Do not put even a single drop of water here. No aqueous form. It will be only taken in the molten form. Now, once we have NaCl in the system, which is the ore, we will connect it using electrodes and a battery. The one connected to positive side of the battery is called as anode, and the other one connected to the negative terminal of the battery will be called as cathode. Now again, we are having battery, so we'll switch it on. Once we'll switch on the battery, what will happen? At anode, because it is positively charged, negative chloride ions will going to attract towards anode. Or in simple words, anions will move towards anode. Cl minus goes towards anode. What will happen? It will undergo oxidation. Oxidation means loss of electrons. So chloride ions will lose electrons and form chlorine gas. So where chlorine gas is liberated? Chlorine gas will be liberated at anode. Cl2 will be evolved and collected from anode. On the other side, Na plus being positively charged will be attracted towards negative side, which is cathode. So what is happening at cathode right now? Cathode being negative, cations will be attracted towards cathode, which undergo reduction. Reduction means what? Gain of electrons. So sodium ions will going to gain electrons and form sodium metal, guys. We have extracted sodium from sodium chloride. Done and dusted. We have achieved it. We want sodium out of sodium chloride. We did it. So all the sodium metal will be deposited on cathode. So metal will be collected at cathode. Whatever metal we are extracting from high reactive metal ore, we are collecting it from the cathode side. Cool? Clear, boss? Yeah? Perfecto. Hi Ashu. Yeah? Okay. Yes. Amazing, Yashu. So this is all about electrolytic reduction. Now talking about moderate reactivity. If metal is a part of moderate reactivity from the middle part of reactivity series, like zinc, like iron, in that case, they are existed or they are occurred in nature as carbonate or sulfide ore. Now problem is carbonates cannot be broken that easily, or sulfide ores cannot be broken easily. So what they did, they converted them into oxide and from oxide they extracted the metal. So they do ulta wala part. Rather than holding the ore from this side, they are just holding it from the other side. So zinc carbonate, which is called as calamine, this is the name of ore. This is the chemical name, zinc carbonate. So what they did, instead of extracting zinc directly out of zinc carbonate, they converted it into oxide form, and carbon dioxide gases evolved as a byproduct. This complete process is called calcination. What is calcination? Heating the carbonate ore in limited supply of air. Heating strongly in limited supply of air. Carbonate ores only. Calcination occurs only on carbonate ores where they are heated in absence or in limited supply of air, that results into formation of their oxide form. Whereas those ores which are present in sulfide form follow the same story. So sulfides also cannot release metals easily. So we have to convert them into oxide first, where sulfur dioxide gas was given as a byproduct, and this entire process is called roasting. What is roasting? When sulfide ores are heated strongly in presence of excess of air, we call this process as roasting, where it converts sulfide ores into its oxide, where sulfur dioxide gas is given here as the byproduct. Now it's very important. Once you have your oxides, once you will have your oxides like zinc oxide, you have to add a reducing agent to extract metal out of it. Like zinc, you have made zinc oxide, but to extract zinc from zinc oxide, you have to add a reducing agent here. You have to undergo a process of reduction. So you have few choices here. Either you do reduction by carbon, by using aluminium, by using sodium, and so on. Now carbon is most widely used reducing agent because it's sasta sundar tikau. It is cheap and easily available. So carbon is most widely used reducing agent because it is very cheap and it's easily available. So what scientists did? Let's put carbon as a reducing agent here. So we have zinc plus carbon monoxide as the byproduct, and voila guys, zinc metal is extracted. We have extracted zinc metal from its respective ore. I'll take you again. Zinc carbonate, on calcination, on strong heating in presence of limited oxygen, first they have converted themselves into zinc oxide. Then zinc oxide was reacted with a reducing agent, which is carbon. That results in formation of zinc as a metal in carbon monoxide, and this is how we have achieved and extracted zinc as a metal. Similarly, if we go for zinc sulfide, it's the same story. Zinc sulfide, we cannot extract zinc straight away, so we undergo roasting process where we have heated strongly in presence of excess of air. We form oxide of the metal plus sulfur dioxide. Now zinc oxide will be then reduced by the help of a reducing agent, that is carbon. And carbon will react with zinc oxide, metal zinc will be out, and carbon monoxide will be given as a byproduct. Clear, boss? Give me a thumbs up in chat box. Sulfide ores means metal sulfides, Anu, like zinc sulfide, HGS, mercuric sulfide. Yeah, cool. Cool. So this is called roasting. This is called calcination. Alright. Now there are some terms that could be asked to you in 1 mark, like smelting. What is smelting? Where carbon is used as a reducing agent to extract a metal. Like zinc oxide was reacted with carbon as a reducing agent, where zinc was extracted and carbon monoxide was produced as a byproduct. So where carbon is acting as a reducing agent, we call this process as smelting. That's it. Very simple. What is smelting? Where carbon is used as a reducing agent to extract a metal from their respective oxides. And where aluminium is used as a reducing agent. We call this process as aluminothermy. Last to last year, in most of your previous year questions, you will find question from thermite reactions. It's super duper important. Please mark it as important. You'll get many questions from thermite reaction. Please mark this as important. Hi, Om. Okay. All right. Now, what is thermite process? Where aluminium is used as a reducing agent to extract metal from their respective oxides, like Fe2O3, ferric oxide, reacted with aluminium. Aluminium will going to remove iron from its position, form aluminium oxide. Iron will be left out alone, which is in liquid state. Plus lot amount of heat has been produced here. So this reaction is exothermic reaction, and this is used for railway tracks. For joining railway tracks, we use this particular reaction called as thermite reaction, or it is also called as aluminothermy. What does aluminothermy means? Where aluminium is used as the reducing agent. All right, joining railway tracks as well as for repairing big machinery parts. We use this particular reaction. Guys, now it's your turn. Tell me, what type of reaction is this? It's your turn now. What type of reaction is this? Come on, come on. Priya, halides means halogens, fluorine, chlorine, bromine, iodine, with their ions like F1 minus, Cl1 minus. They are called halides. Displacement. Okay, let's take it as displacement. One of you have called it as exothermic, which makes sense. And one more. One more. Come on, there is one more reaction going on here. Vanshika, exothermic is right. Priya, displacement is right. Ranjita, correct. Shripad, correct. One more, guys. You're missing on one more type of reaction here. Yes, Vanshika, that's absolutely perfect. It is redox reaction. See, guys, it is redox reaction also. Aluminium adding up of oxygen, aluminium oxide. So it is undergoing oxidation. On the other hand, Fe2O3 is turning to Fe, means loss of oxygen. Loss of oxygen means reduction. Aluminium is being used as a reducing agent. So Fe2O3 is used as the oxidizing agent here. So it is redox reaction also. It's 3 in 1. It's displacement, exothermic, and redox. Important for your exam point of view. They do ask you questions from this type also. They'll ask you how many types are there in this one reaction. It's displacement, it's exothermic, and it is redox as well. Cool? Cool, cool, cool. Perfect, perfect. Right? All right. Now moving on to electrolytic refining. Once we'll complete electrolytic refining, we'll take a short break. And then after that, we'll be moving on to corrosion. And lastly, carbon and its compound. Your most awaited chapter for today. Yes, Samanvita. Yeah, it's enough, Vijay. But do solve and practice more questions. Yeah. Okay. All right. Chaliye, what is electrolytic refining? It's your third step of metallurgy. What is that third step says? Refining means removing the impurities within the metal. To remove impurities which is there present inside the metal is done by the most widely used technique in presence of electricity, and we call it as electrolytic refining. So let me remind you, 3 simple steps. First, concentration of ore. Second step, was extraction of metal. But once metal is extracted, that doesn't mean that you will sell and earn money out of it. No. Once metal is extracted, you have to refine it further. You have to clean it further to sell and earn money. So that is done by a widely used technique called as electrolytic refining. Now let's say, for example, we have to purify copper. We have been given the impure block of copper and they have asked us to purify copper. So what we'll do, first thing to remember, anode should be used as impure metal. You will use impure metal at anode, means connected with the positive terminal of the battery. Second, you will use pure metal strip at cathode. Pure metal will be used at cathode. Third that you need to remember is the choice of electrolyte. What is electrolyte? The solution present in the beaker which helps you to conduct electricity. So electrolyte should be the same metal solution. Same metal solution. Like for example, if I have to purify metal copper, then copper related solution will be there as the electrolyte. That should be my choice. So these are 3 points to remember under electrolytic refining. Now let me make this more easy for you. To do electrolytic refining, you need an electrolytic tank filled with copper sulfate, which is aqueous solution behaving as the electrolyte. Yeah, they are connected with, electrodes are connected with battery. Positive side is connected with impure copper metal block and negative terminal of the battery is connected with pure copper strip. Cool? Till here it is clear. So we have taken an electrolytic tank. Thick block of impure copper was connected with positive terminal of the battery. So it will going to behave positively charged and it is called to be as anode. On the other side, it is considered to be as negatively charged because connected to negative terminal of the battery and it is named as cathode. And we have what? We have copper ions and sulfate ions floating in this entire electrolyte, in this entire solution. Now, the best part of electrolytic electrolytic refining. Chale, Acha, tell me one thing. All your crushes has been turned into a relationship. Huh? If you like any cricketer, will you end up marrying that cricketer? No. If I like a celebrity, will I be able to marry that celebrity? No. So we have a lot of crushes, but we cannot end up marrying that particular person. That's crazy. So same thing has happened here. Sulfate ions being negatively charged got attracted towards positive. Listen to this. Sulfate ions got attracted towards positive because of opposite charges. But there was no relationship or bonding that could happen. So this was just attraction, but that could not end up into a relationship. So at anode, what will happen? Impure copper is like, oh, I don't need you sulfate. I'm on my own. I'll go solo. I don't want any kind of relationship. I don't want any kind of chemistry and all that stuff. I will go alone. So impure copper block at anode participated into a reaction by itself and undergoes oxidation. So impure block of copper loses electrons and form copper 2 plus ion. So copper 2 plus ions will come into this electrolyte. As it loses, this particular impure copper block will start losing electrons. It will form copper ions which come into this particular solution. Now on the other hand, these copper 2 plus ions being positive gets attracted towards negative cathode. And that's ended up into a relation. Yes, there was a bonding that happened. There was a relationship that has been created. So at cathode, it undergoes reduction, and these copper ions which were attracted towards negative side has gained electrons and form what? Pure copper metal. Guys, we did it. We want pure copper metal and we got it eventually. So slowly and gradually, pure copper metal will be settling onto the surface of cathode. Slowly and gradually, copper ions will come there, undergoes reduction, pure copper will start settling onto the cathode. Meanwhile, impure copper is utilizing itself and copper ions will be dipping into this electrolyte. So what will happen? Anode will get thinner and thinner in size, whereas cathode will get thickened and thicker in size. Anode becomes thin and cathode becomes thicker in size. This is how this complete reaction will go on and on and on. And pure metal will be collected where? Dash. Come on, pure metal will be collected at dash. Pure metal will be collected at cathode. Yes, Vanshika Priya, but absolutely right. It will be collected at cathode. This is your 1 mark MCQ question. Where pure metal is collected? At cathode. Now, impurities are coming out from impure copper, but where those impurities are going? So there are 2 types of impurities. Bacha Pati. 2 types of impurities. One is soluble and other is insoluble impurity. Soluble impurity will definitely solubilize an electrolyte. You cannot catch that. Leave it. Insoluble impurity will settle at the bottom of anode. Insoluble impurities will settle at the bottom of anode, which is then named as anode mud. Done and dusted. Khatam. Clear? That's all about electrolytic refining. In presence of electricity, how you are refining a metal, how you're removing the soluble and insoluble impurities out of it, and that's electrolytic refining. Pure copper will always end up settling onto the cathode, and impure copper will start losing its electrons and give copper ions, which will go into the electrolyte eventually. Sorted, boss? Okay. Now it's time for you to sort some questions. I hope you all are ready. So let's begin to sort some chemical order together. Question number 2. What chemical process is used for obtaining metal from its oxide? Come on. Hi, King Kong. Come on, come on, come on. You can do it. What chemical process is used for converting metal from its oxide? Yeah, very close, Anu, very close. But you can write just reduction. Hai na? From its oxide, if we have to get a metal out, we are undergoing a process called as reduction. Now in reduction, if you're using carbon as a reducing agent, we call it as smelting. And if you're using aluminium as a reducing agent, we'll call it as a thermite process. Clear, boss? Simple? Is it clear? So reduction is the process for converting oxide into the respective metal to extract a metal. But reduction happens in presence of reducing agent. If carbon is a reducing agent, that process is called smelting. And if aluminium is being used as a reducing agent, that is called as a thermite process. Next is, what are alloys? Give an example. Now the keywords that you need to use to get full marks: homogeneous mixture. Okay? This needs to be written, otherwise you'll get 0. Homogeneous mixture of metals along with non-metals or metals along with metals. That is when we call them as alloys. It's a homogeneous mixture of metals and non-metals. Now example, yes, one of you have given me brass, which is good. Yeah, brass is right. Solder, fuse material, good. As well as steel, stainless steel. There are n number of examples you can quote. है ना? Steel, stainless steel. These are the examples. Good. Cool. Next question. State which of the following metals would give hydrogen when added with dilute hydrochloric acid. Come on, come on, come on. Quickly. State which of the following metals would give hydrogen when added with dilute HCl. So iron will give hydrogen. Will iron give? Yes, it will give. So that will form FeCl3 plus hydrogen gas. As well as if copper reacts with HCl, will it give hydrogen gas? No. When magnesium react with HCl, will it be able to give hydrogen gas? Yes. Because it is more reactive than hydrogen. Magnesium more reactive than hydrogen. Iron is more reactive than hydrogen. So it's the second one which is not able to give. Rest, both of them are able to give reaction with hydrochloric acid and produces hydrogen gas. Alright guys. So now we are very close towards our last chapter. So next is carbon and its compound, and do not give up right now, okay? I know we are sitting from so long. We are studying since I think afternoon, and we have completed 3 chapters proudly. So let's finish what we have started and be proud at the end of this session that we have completed chemistry in one go. So tell me how's the Josh, and then I will give you a pretty quick break. Okay. Yeah, Radha. Absolutely. Absolutely. Let's take 5 minutes break here. Very high. So nice to see. Oh, that's so sweet, Adiba. So, how are you feeling, guys? All good? Feeling amazing? Feeling tired? Vanshika, we have actually covered that corrosion part in chemical reactions and equations. है ना? I remembered then. We have already covered in chemical reactions and equations last part. If you want to revise it, that entire part, you can just have a look there. All right, guys. So let's begin with carbon and its compound. I think most of you were waiting for this one. So again, I'll take you from scratch of this chapter. Still, if you have any doubts, I am pretty much sure that will be covered up in today's session. So please keep your pen and paper handy, keep yourself hydrated and focused. So let's begin. Hi, Shivam. Hello. Nay, no, Vax. Chill, man. That it will be okay. If you have read everything, if your concepts are clear, you can kill it off very easily. Uh, so if reactions are messed up for you in carbon and its compound, you better start writing and learning. Okay, hi Tanmay. All right, so let's begin. Chakravarti and energy should be top notch right now. Let's begin. So let's talk about carbon. But have you ever wondered why they have chose carbon out of any other element? You know what? There is the entire different branch of chemistry which have been completely focused upon carbon, and that is called as organic chemistry. There are different parts of chemistry. So one branch which is entirely focused upon carbon is organic chemistry. But why carbon is getting that much of importance? Why not other elements are getting that much importance from us? Because carbon has versatility in it. Carbon can show different variety of properties, as well as it has resulted into millions of compounds around us. Let me tell you, starting up with the clothes up we are wearing, polythene bags, chair, pen, everything, our DNA, ghee, paneer, everything is made up of carbon. So, carbon is everywhere, it's versatile, it is stable, and that is the reason we are giving a lot of importance to carbon rather than any other element. So, we are all aware about that carbon is having atomic number 6, electronic configuration is 2, 4, and its valence electrons, the electrons present in the outermost shell, is 4. Therefore, its valency is also 4. What is valency? Valency is the combining capacity of an atom. What does combining capacity means? That carbon can make how many bonds with other element. So total combining capacity of carbon is 4. That means it will going to make 4 bonds with other elements. Maybe with hydrogen or other elements, but it definitely be 4 bonds. Not less than 4, not more than 4. Please remember that carbon has to make 4 bonds to be stabilized. Not more than 4, not less than 4. Clear? Alright, so as we know basic thing about carbon, but have you ever thought that why carbon cannot give electrons, cannot take electrons? Why always carbon participates in covalent bonding? This question comes for 2 marks in your board paper. So to explain that answer, you have to write 2 points along with the reaction. Guys, please look here because I'm telling you the presentation of your answer also. If question comes to you that why carbon only shows covalent bond, why carbon does not participate in ionic bonding, or why always carbon shares electrons, not give or take like any other element. So these are the points that you need to mention. Number 1. If carbon tries to gain 4 electrons, or if carbon tries to lose gain 4 electrons, it becomes C4 minus anion. Now carbon has electronic configuration of 2, 4, right? Now if it gains 4 electrons, it will going to complete its octet configuration. This is how it works. So it will form C4 minus anion with the electronic configuration of 2, 8. But there is a chemical lota going on. There is a problem here. What is that problem? Carbon with 6 electrons has 6 protons in it. It has 6 protons in it. But after gaining 4 electrons, earlier electrons were 6. Later, after gaining electrons, there were total 10 electrons. But proton number will not going to change. Proton number always remain constant. Even electrons are lost or gained, proton number will never change because proton resides in the center of the nucleus, deeply seated. So proton number will remain constant. But does that make sense to you? How can 6 protons hold 10 electrons? It's not energetically possible. So as this will make system unstable, 6 protons cannot hold 10 electrons. In that case, carbon cannot gain electrons to attain stability. So this option is gone for carbon, that carbon cannot gain electrons. Whereas carbon has the ability to lose 4 electrons to make C4 positive. Now let's say if carbon tries to lose 4 electrons, it becomes C4 positive. Carbon's electronic configuration is 2, 4. After losing 4 electrons, its duplet will be completed. But is this possible? No. Losing 4 electrons required high amount of energy, and if energy is required, system become unstable. So carbon finally understood that, boss, give and take is not my piece of cake. Better I should start sharing my electrons. So carbon remembered what carbon parents taught carbon. Sharing is caring. So carbon loved to share its electrons mutually with other elements rather than giving or taking electrons to attain stability. So carbon shows covalent bonding. Instead of ionic bond participation, carbon loves to mutually share its valence electrons to attain full electronic configuration or to complete its electronic configuration, and hence it participates in covalent bonding and compound form will be covalent compound. The most simplest carbon compound, guys, is CH4. Methane. The simplest most carbon compound is methane, which is also called as natural gas. It is also called as marsh gas. Why I'm telling you these names? Because you have to remember the alternative names. Otherwise, if question comes to your paper, give the structure of marsh gas or draw the formation electron dot structure of marsh gas. You will end up having a question mark, thinking, oh, what is marsh gas? Ma'am have not taught us. Oh, we have not learned this in NCRT. So please do not panic. Instead, learn these common names, because this is something you've already learned in your lower grades like 6th and 7th. So we all assume that you are aware about what is methane's alternative name is. It also called as natural gas. It is also called as marsh gas. So be ready with the worst situations also. All right. Now, as we're talking about mutual sharing, let's see how we can do it. How many electrons required to make one bond? How many electrons are required to make 2 or 3 bonds? So if you are preparing hydrogen, hydrogen means by default we are talking about H2. Guys, H as an atom does not exist. So we are actually talking about H2 by default. To prepare H2, how many bonds are required? So to see that, we have to first look into its electronic configuration. Hydrogen atomic number 1, K shell has 1 electron. So hydrogens, one atom has 1 valence electron. Other hydrogen atom will have 1 electron in its valence shell. Now, it requires mutual sharing to complete its duplet. Obviously, 1 electron is required in K shell to complete duplet. So this hydrogen will be like, oh yeah, let's mutually share. So we get stabilized. So this hydrogen shared one of the electron from its neighboring hydrogen, completed its duplet, and the other hydrogen did the same thing. That results into H single bond H. Please mind it, guys. Please note it. One bond or a single bond is made by one pair of shared electrons. One shared pair of electrons will result into one bond or a single bond, or 2 electrons in total which are sharing will result into one bond which is single bond. We will call it as single covalent bond. Why single covalent? Because it's one bond single. Covalent because it's been mutually shared between 2 atoms, and bond. That's something you know. Okay. Clear till here? Now, next question is for you guys. Be ready. How many total number of, give me total number of covalent bonds in oxygen, O2? Yeah, Novax. Yeah. Come on, guys. How many total number of covalent bonds will be there in oxygen molecule? Amazing. Vanshika, Ashwini, rightly said. Absolutely good. Very good. So we can prove it. Some of you are saying 2 bonds. 2 bonds means double bond I can take. Yeah, double covalent bond. So oxygen's atomic number is 8, electronic configuration is 2, 6. One oxygen atom has 6 electrons, 1, 2, 3, 4, 5, 6. Other oxygen atom also has 6 electrons, 1, 2, 3, 4, 5, 6. 6 electrons in the valence shell require just 2 more electrons to complete its octet. So those 2 electrons come from where? From neighboring oxygen atom. And same thing will happen on this side. I have 6 electrons in my valence shell, require just 2 more. Can you please share with me your 2 electrons? Okay, we mutually share and be happy and stable. So one pair of electron gives you one bond. Another pair of electron gives you one more bond. So overall, it would be double covalent bonding in oxygen molecule. Next, nitrogen. How many? In nitrogen, how many covalent bonds will be there? Nitrogen means N2. Impressed, impressed. Good. It's 3. Absolutely, it is 3. There would be total 3 bonds, which is nitrogen, triple bond, nitrogen. Actually, I'll tell you one trick. I have simple trick for you guys. Hydrogen require how many electrons to complete its duplet? Listen to this. It's very fun trick. Hydrogen requires how many electrons to complete its duplet? 1, right? Hydrogen require just 1 electron. So electron required to complete electronic configuration, yeah, is equal to total number of covalent bond formed between same atoms. That's the keyword, okay? Now, if hydrogen required 1 electron to complete its duplet, therefore hydrogen and hydrogen will make 1 bond, single bond. Oxygen, on the other hand, required how many electrons to complete its octet? Number of electrons required to complete the octet is equal to the number of bonds it will going to make. So oxygen required 2 electrons, so there would be 2 bonds. Crazy? Nitrogen, atomic number 7, electronic configuration 2,5. How many electrons required to complete the octet? 3 electrons are required to complete the octet. So nitrogen and nitrogen will have 3 bonds or triple bond. Cool? Cool, cool, cool. I hope you love this trick. Yeah, easy peasy lemon squeezy. That's good for your competitive exams. You can use such tricks for your competitive exams. All right, guys. Now, another 2-mark question which could land up in your paper is the difference between ionic and covalent. Or they could even ask you questions related to these two as assertion reason in section A. Ionic compounds are always formed between metal and non-metal, whereas covalent is always formed between non-metal and non-metal. Ionic always formed because of the transfer of electrons, whereas covalent results by mutual sharing of valence electrons. So it loves sharing, it just loves the transfer of electrons, give and take relationship. Covalent do not ionize. Ionic ionizes in solution or molten state, molten and aqueous state. Covalent are very bad conductor of heat and electricity, whereas ionic compounds are good conductor of electricity and heat just because of the presence of ions in them. Free ions are responsible for good electrical conductivity. Covalent bond is a weaker bond as compared to ionic bond. Ionic bond shows a strong electrostatic force of attraction, which is one of the strongest bond as compared to the covalent bonding. Now, as we have learned about basic thing about carbon, so let's understand about allotropes. What are allotropes? See, diamond, graphite, fullerene, they are all made up of carbon. But isn't it weird that how carbon looks, how diamond look, graphite can even be broken by a small bacha. Literally, 2-year-old, 3-year-old can break the nib of the pencil. But diamond is one of the hardest natural known substance. And the weird thing about them is that they are all purely made up of carbon. Then how come they have different nature? So that difference is because of the spatial arrangement. Though they are all commonly made up of carbon purely, but that carbon is arranged in very different manner. Their spatial arrangement, their structural difference is too much that makes them entirely different from each other. Their physical properties are different, whereas their chemical properties are similar. Mind this thing, allotropes have similar chemical properties, but their physical properties will be different. Why the chemical properties are same? Because they have all same valence electrons, because they are all made up of carbon. So they have same chemical properties, but physical properties will differ because of the difference in the structural arrangement. So as there are 3 allotropes of carbon that you'll be learning, along with that, uses are also important because they are asked in your paper. Let's start with diamond. Diamond is a 3D rigid structure. 2 questions which are very, very important from this particular part of allotropes. Why diamond do not conduct electricity? Why graphite being a non-metal conducts electricity? This particular question is super duper important for your exam point of view. Write it down. So diamond, 3D rigid structure, very compact. Because of that rigid structure, they are very, very strong. They are very solid and known to be as the hardest substance. Because of that 3D rigid structure, their melting point and boiling point is very, very high. Now, they will never ever conduct electricity, but they are good conductor of heat. They are not good conductor of electricity. Now, what is the reason here? Guys, listen to this very carefully. Why diamond is not a good conductor of electricity? Look at the structure of diamond here. It's a 3D rigid structure. Now, as we all know that carbon's atomic number is 6, electronic configuration is 2, 4, and carbon has 4 valence electrons. Now, if one carbon's 4 valence electron is occupied in covalent bonding with other carbon atom, will there be any free electrons left? No. All 4 electrons in valence shell of carbon is further occupied in covalent bonding with other carbon atom. And that's the reason, because there are no free electrons, they are not able to conduct electricity. So you can look here, this carbon is bonded here, 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 and here. So it is 1 bond, 2 bond, 3 bond, 4 bond. All 4 valence electrons are already occupied in covalent bonding. So there are no free electrons, means there would be no electrical conductivity in case of diamond. Where are diamonds used? Now, again, I would remind you guys, please do not ignore uses. Uses are important and they are asked in your paper for sure. Now, diamonds are used for obviously jewelry purpose because of its brilliance, because of its shine. They are used for jewelry purpose. They are hard also. Now, I have just selected this picture for you to show you guys. This is actually a blade. If you see this closely, it's a blade and there are diamonds embedded in it. I have selected this picture to show you guys specifically. So these diamond pieces are used in cutting. Because it's very, very hard and strong, it's used for cutting instrument, for cutting glass, for rock drilling as well. And sharp edges of diamonds are also used by eye surgeons in their particular instruments, in their tools. I hope it is clear. Sorted, boss? Yeah? Yeah. Diamond structure will not be asked, whereas graphite structure can be asked. You know? Sorted. Okay. All right. Now, as we're talking about graphite, on the other hand, we all know that graphite is also made up of carbon, yet it is very much different from that of diamond. The reason is structure. In case of diamond, it was a 3D compact rigid structure, whereas in case of graphite, it is a layered structure of carbon hexagonal rings. So it would be again this kind of layers of carbon will be used, carbon rings will be used, and in layers they will be sliding over each other. That sliding is because of a weak van der Waals force of attraction. Let me show you the structure. So this is one layer, this is second layer, and there are n numbers of layers one above the other. It's a planar structure. It's a 2D structure. Each layer is connected with the other one with a very weak force of attraction called as van der Waals force of attraction. It's one of the weakest force of attraction, because of which it is soft, it is slippery, and the reason it is soft and slippery, we are able to write it as we use pencils. Yeah, it is soft and slippery. It is grayish black opaque structure, good conductor of electricity. It is important again. Now, please look on the screen. In case of diamond, if you guys remember, carbon, all 4 valence electrons were occupied in covalent bonding with other carbon atom. That was a case of diamond. In case of graphite, this carbon atom is connected with 1, 2, 3 bonds. There is no 4th bond. That's an exception. In the start of this chapter, I told you that carbon has to make 4 bonds to stabilize. Not more than 4 bonds, not less than 4 bonds. But this is one of the exceptions where one carbon who is having 4 valence electrons, only 3 of them got occupied in covalent bonding and 1 electron is moved. It is free. So 1 electron is free, which is responsible for conducting electricity. Why graphite is able to conduct electricity? Because of free electrons. But why? Because one carbon atom has 4 valence electrons, out of which 3 electrons will be occupied in covalent bonding. Rest 1 electron will be free, which is responsible for conducting electricity. I hope it is clear. Give me a thumbs up in chat box. And this question is important, comes for 2 marks in your paper. Yeah? Cool? Cool. Now guys, if you're just writing presence of free electrons or absence of free electrons, this will not give you full marks. Being chemistry student, you have already learned too much about bonding now. So you better explain your answers in form of structures. This is what expected from you guys. If you're just mentioning, oh, graphite and conduct electricity because of free electrons, you'll get half marks from that. But if you explain why exactly in terms of bonding, you'll get full marks for that. Okay. All right. So as again, we are coming to uses. We all know from childhood onwards, everyone has their pencils in the hand. We are using pencils, which is graphite because it's soft and slippery. We are able to write it, as well as it is also used for making electrodes. These are the carbon electrodes, graphite electrodes used in batteries also. And it is also used as a lubricant. Because of that van der Waals force of attraction, they slide over each other. Because of that reason, we are also using graphite as the lubricant in machineries and all. Now, moving on to third allotrope of carbon, which is Buckminster fullerene. Fullerene has various names. It's also called as Buckminster fullerene. It is also called as buckyball. And it was named after a person who has actually created a dome-like structure which looks resembling towards that Buckminster fullerene or fullerene, which consists of, the structure of fullerene suggested to be like a soccer ball. It's a spherical dome-like structure which is consisting of 12 pentagons and 20 hexagons. Guys, you should be aware about one thing of fullerene, that it is made up of 60 carbon atoms and it's a dome-like structure used for medical uses. So there is not much of questions asked in your paper related to fullerene, but you should be aware about how many number of carbon atoms are used here to create fullerene, which is also named as Buckminster fullerene or buckyball. All right, so that was all about allotropes. So with the start of this chapter, I told you guys that why we are giving carbon so much importance. Why not we are studying for aluminium or for iron or for gold? Why we are not putting so much effort on other elements? Why it is carbon? Because of its versatility. What does versatile means? Do you know what does versatile means? Yeah, versatile nature. Why? Because of its versatility. Versatile means it shows many unique properties which is not shown by any other element. Like, it shows catenation. It shows tetravalency. It shows multiple bond formation. And lastly, it shows isomerism. Let's go one by one. Carbon is tetravalent in nature. It has the ability to make millions of compounds in nature. Already millions of compounds have been studied by scientists, that is of carbon. So it's a huge deal because of tetravalency. Tetravalency means it can make 4 bonds. It has 4 valence electrons. It participates into catenation. What is catenation? Catenation is a unique property of carbon where carbon is like self-obsessed. मैं अपनी favorite हूँ. Like that. So carbon is like मैं अपनी favorite हूँ. So carbon will going to bond with other carbon atom, create long chains like structure. It can also create branch chain structures, as well as it can create ring-like structures. So it's kind of self-obsessed. Carbon loves to bond with itself. So that kind of unique property is what we call it as catenation. It's self-linking. Thirdly, formation of multiple bonds. Carbon can result into single bond, double bond, triple bond. It could make single and straight chain. It could make double or triple and straight chain, branch chain, ring-like structure. That's the reason it has a variety of compounds. Variety, large number of compounds can be made and prepared. The best part is they are stable. They exist. They exist in nature, in your clothes, in bread, butter, DNA, everywhere they exist because they are quite stable. Why they are stable? Let's find it out. Okay, guys. So, first point, tetravalency. As we have seen, carbon has 4 valence electrons. So, it can make 4 bonds with other elements. Catenation is a unique property where it will be self-linking. Carbon self-link through covalent bond results into large number of molecules. It could be a straight chain, branch chain, or ring-like structures. Reason is small size of carbon. Because of small size, it can undergo formation of long chain of carbon. One more question that arises from this part is carbon the only element who shows catenation property? Come on, guys, tell me yes or no. Is catenation the only element shows catenation property? No? Acha. Why? Novax? Which other element shows catenation property? Yes? Okay. Why yes? No. Yes. No. Yes. Okay. Let me answer this question. This was asked last to last year in MCQ question. So, please focus. See, carbon is not the only element to show catenation. It's true. Carbon is not the only element to show catenation. Silicon is also the one which shows catenation property, but to a very low extent. Silicon comes below carbon in periodic table. If you've seen periodic table, silicon comes just below carbon, and silicon do show catenation property, but to a very, very small extent, not as carbon. Why? Carbon have a small size. Small size of carbon makes it very, very strong. Now, I will tell you triple S theory. Triple S theory is not given in any book, but you will understand the concept here. Triple S means small, strong, stable. See, smaller the element, smaller the bond, shorter the bond, stronger the bond. And if bond is stronger, it will exist and it will be stable. Size of silicon is big. It's bigger in size as compared to carbon. If size is bigger, bond will be bigger. If bond is bigger, it is weaker. Weaker means it will going to break easily and it will be not stabilized. It will not exist. Silicon can make a bond with other silicon atoms. Can make a bond with other silicon atom, but not long chains. It will going to break because of the bigger size. It will break. That's the reason I'm telling that silicon shows catenation, but to a very small extent. Whereas carbon can make long chains because of its smaller size. Shorter bonds, stronger bonds, stable bonds. Clear, boss? Sorted? All right. Yeah. Okay. Clear? Now moving on to isomerism, that also one of the factor to make carbon more versatile in nature. Isomerism is one of the factor because of which carbon makes large number of compounds. What is isomerism? Okay. You guys have siblings. You guys might be having siblings. I also have a sibling. Mummy, papa is common. Parents are common. But siblings can be different. Siblings might like same things or they dislike things as well, common things. So, as isomerism, molecular formula is same, but structural formulas are different. That's when we call it as isomerism. Mummy, papa is same, but bachas are different. That's isomerism. Molecular formula for this particular structure, molecular formula is common, but it is available in different structure. How many carbons are there? 1, 2, 3, 4, 5. 5 carbons. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. How many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogens. It also have 12 hydrogens and this one also have 12 hydrogens. These three structures are entirely different from each other, but molecular formula is same. So these three are isomers to each other. Again, I would repeat, molecular formula same, but structural formulas are different. So this is called as isomers. This complete phenomena is called as isomerism. Sorted? Clear, boss? Yes, it is important. It is absolutely important. Yeah. Okay. All right, guys. So that's all about isomerism. Acha, tell me how many isomers are there? Structural isomers are there for butane. How many structural isomers are there for butane? Yes, we can make unique, but isomers are of different types. What is there in your syllabus is just structural isomer. There are functional group isomers also. In that, ketone and aldehyde we'll be talking about. 2, Pakka 2. Yes. So total number of structural isomers in butane is 2. Absolutely right answer. Butane's molecular formula is C4H10. That's the molecular formula of butane. We can create a structure like 4 carbon atom. Rest of them will be hydrogen, 10 hydrogens. So this is called as the straight chain compound of butane is called as N-butane. There is one more possibility of the structure, that is 1, 2, 3, 4 carbon. Not in straight chain. There could be a branch. Rest of 10 hydrogens I will be distributing to complete tetravalency. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there would be 10 hydrogens distributed all over this compound. Different structure. This is called as isobutane. Different structure, same molecular formula, mummy, papa, same, बच्चे अलग अलग, that is when we call them as isomers. Sorted. One more. How many structural isomers are there for hexane? How many total number of structural isomers are there for hexane? Bujho to jari. Let's see who can find it out. Okay, I'll give you one trick. Trick is 2 की power n minus 4 plus 1, where n is equal to number of carbon atoms. 4, 5. 4, 5, 7. Baba. No. Try. Hex means what? 6. Yeah, it would be 5, guys. It would definitely be 5. Yeah. Cool. 5 isomers will be there. Total 5 isomers of hexane will be prepared. You can try that out at home. It's your homework. Try to prepare 5 total isomers of hexane. All right, after isomers, after isomerism, we have now clearly understood that how come carbon is very versatile in nature. Why we are giving a lot of importance to carbon, we understood. We also heard about multiple bonds. There is one more reason why carbon is very, very versatile, and that's because of the multiple bond formation. Carbon can make single bond, carbon can make double covalent, as well as it can make triple covalent bond. And this is where hydrocarbon comes into picture. Guys, complete organic chemistry has hydrocarbons under that. A branch, complete branch, is holded with hydrocarbon. What is hydrocarbon? It's compound of hydrogen and carbon. Atoms below 4, rather it will not create isomers. Isomer starts with 4 carbon atom. If it is below 4, you're not able to make different structures with 3 carbon atoms or 2 or 1 carbon atom. Clear na, Radha? So isomerism starts minimum with 4 carbons. All right, but that's a good question. All right, hydrocarbons, from name itself, it's screaming out loud, compounds of hydrogen and carbon are called as hydrocarbon. But what if hydrogen is replaced by any other element? Like, for example, hydrogen attached with carbon completing its tetravalency. This is purely hydrocarbon because it's purely made up of hydrogen and carbon. But let's say if hydrogen is replaced by some element, X element. So carbon have 3 hydrogens now, but one of the hydrogen is replaced by some other element. It is now called to be as hydrocarbon derivative or derivative of hydrocarbon. It's not purely hydrocarbon anymore. You should understand the difference here, guys. It's purely hydrogen and carbon compound called hydrocarbon. But if hydrogen has been replaced by any other element, it is then called to be as derivative of hydrocarbon or hydrocarbon derivative. But the best part here is that they are both organic compounds. They both have organic properties. That's the best part of derivatives here. Hydrocarbons are of 2 types, saturated and unsaturated. Saturated hydrocarbon means single bond. One thing that should click your mind once you hear the term saturated. Okay, saturated, single bond. Single bond means alkanes. General formula is CnH2n plus 2. You should connect the dots. You should know how to connect the dots. Saturated means single bond. Between carbon and carbon means we are talking about alkanes. That means we are having a general formula of CnH2n plus 2, where N is equal to number of carbon atoms. And N minimum starts with 1. These are the steps that should come in your mind. Similarly, if you hear unsaturated, okay, unsaturated means it could be a double bond, it could be a triple bond. If it's a double bond, it's alkene. If it's a triple bond, it is alkyne. Now, alkenes means general formula is CnH2n, and alkynes means CnH2n minus 2, where N is equals to minimum starts with 2. N can never be 1 here. Number of carbon in alkenes and alkynes can never be 1. Please write it down. It's super duper important. It will be used in your homologous series also. Homologous series say you will get question as well. And this year, there is a very high chances of getting question from homologous series. Okay. So CnH2n, CnH2n minus 2, where N is equals to 2, N can never start, or number of carbon cannot be 1 in case of alkenes and alkynes. So unsaturated means it can have double bond and triple bond between carbon if it's a double bond alkene, if it's a triple bond between carbon alkynes, and alkenes it will be a single bond between carbon and carbon. Clear, boss? Sorted? Yeah? Why alkene? Okay. Lakshmana, I will answer that question under combustion. Okay? Under chemical properties of carbon and its compound, I'll answer that question. Okay? All right. Now, before we move on to functional groups, let me tell you the surname part. You know? Alkanes have a surname of ane, alkynes have a surname of enes, and alkynes have a surname of ines. This is very, very simple. Just take the last part of alkenes, alkynes, and alkanes. You will get the surname. You will get the suffix of single bond, double bond, and triple bond. Now, as I was discussing about hydrocarbon derivative or derivative of hydrocarbon, that is actually relating to functional groups. What are functional groups? Like, for example, you're having some relatives at your home. Okay? You're having some relatives at your home. Now, tell me one thing. Will your parents ask you what you will eat? Or will your relatives will be telling what they are eating? Who will be more preferable to your parents at that point of time? If their favorite relatives are at home, they will not ask you what will you eat. They will ask the relatives what will they eat. Isn't it? So they are the deciding factor for everything. Even if you want to have pav bhaji and your relatives want to have paneer butter masala, so your parents will going to make paneer butter masala and they will ignore your priorities, right? They will ignore what you want to eat. So they are the deciding factor coming from outside, and they are deciding the chemical property. This is when we call them as functional group. So functional groups are those heteroatom or group of heteroatoms which determines the chemical properties of the compound. They're coming from outside, attaching to the compound, but they are the ones who entirely decide the chemical property of the compound. For example, CH4 methane. Right. Now, if it is replaced by alcoholic group, if it is replaced by OH, like CH3OH, so this functional group will going to decide the entire chemical property of the compound. It was alkane. Now this is alcoholic. So yes, this is alcoholic property. This has alcoholic property because of the functional group OH. So the heteroatom coming from outside will going to decide the entire chemical property of the compound. That is when those heteroatoms are called as functional group. These are the list of functional groups which are there in your syllabus. Halogens means X here, which includes fluoro, chloro, bromo, iodo. Alcohols represented by OH, aldehydes CHO or C double bond OH. Ketones C double bond O, and it will always come somewhere in between the chain. It will never be terminal. Please mind this thing. Ketone as a functional group can never be in the corner of the compound. It will always somewhere in between. Carboxylic acid C double bond OH. Alright? Yeah. Okay, guys. So now, as you're now aware about functional groups, it's time for you to learn about homologous series. As I told you before, this year there are high chances of you getting question from homologous series. So please practice it as much as you can, as well as learn the characteristics of homologous series. What are the pointers that you need to remember for homologous series? To make you understand this part, I'll give you one simple example. Now, let's say you have got a list of items from your parents and they have asked you, okay, beta, now you are very old enough, you're responsible, go buy some stuff for house. They have given you a list of grocery where they have asked you to buy chips, some soaps, lentils, vegetables, leafy vegetables, and all that stuff. They have given you a proper list. You went to a departmental store, okay. Now, please tell me, once you go inside departmental store, you see different categories are placed separately. Like vegetables will be placed in one corner. There would be edible items like lentils will be placed somewhere else. Detergents will have a different shelf. You will never buy cookies or biscuits from detergent shelf. I hope you will not buy. You know? You will never buy, no? I hope you don't buy. So I'm not going to buy biscuits from detergent shelf because that will have a smell of the detergent. There is a reason why shopkeeper has kept them into different categories because of different properties. Right? So homologous series doing the same thing. We are placing different groups according to the properties. Like all the compounds of alcohol will be in same family, because they are all having alcoholic properties. We are putting all alkanes in one group because they are having single bonds. We are putting alkenes in a same category because they are all having double bonds, and so on and on. Such complete series are called as homologous series. So each homologous series will going to have a difference of 14 unit or CH2 unit. Like every member should have a difference of CH2 or 14 mass unit. That's the basic criteria and the condition of homologous series. Like for example, CH4, first member of alkane family. है ना? Second is C2H6. Third is C3H8. Then it would be C4H10. Now, if you look here carefully, every member has a difference of CH2. Second and third will have a difference of CH2. Third and fourth will have a difference of CH2. So, we call them as homology to each other. You cannot say that CH4 and C3H8 are homologous to each other. Not at all. Not at all. CH4 and C3H8 is not homologous to each other because they will have a difference not of CH2. They will not have a difference of CH2. So only if they have a difference of CH2, they are homologous. C2H6, C3H8 has a difference of CH2? Yes, they are homologous. C3H8, C4H10 has a difference of CH2? Yes, they are homologous to each other. So I've placed all alkanes in one. Therefore, they are all following same general formula. So each member of this alkane family is following CnH2n plus 2. Each member of this alkane family is following the same general formula, which is CnH2n plus 2, where n is equal to number of carbon atoms. Now, members show gradual change in physical property. Yes. CH4, C2H6, C3H8, each element will have different density, different melting point, different boiling point. Why? Because of the change in mass. With gradual member, there is an increase in masses. Because of increase in molecular mass, there is a change in properties that will going to eventually come. Now, talking about chemical property, they are having same chemical property. They are all alkanes. If I talk about alcohol series, it would be much better for you. Now, for alcohol, first member is methanol. Second member is ethanol. Third member is propanol. Each member has a difference of CH2 unit. So this is homologous to the second one. Second member is homologous to the third one. They are all following same general formula, CnH2n plus 2 plus 1 OH. They are all having alcoholic properties. Their chemical properties are same, but their physical properties will going to differ. Their densities, their melting point, their boiling point will going to differ gradually because of the increase in the masses of the compounds. Is that clear to all of you? Give me a thumbs up. Because methanol is going to contract the body organs, Lakshmana. Just like if you have ever seen how anda bhurji is made, it coagulates. Like if you put egg into heated part, so it will coagulate. Similarly, our liver will going to coagulate if we consume methanol. So all the organs will start failing, and that's why it is poisonous. Yeah. Okay. Yeah, Divya, we'll do that, bache. Yeah, we'll do that. Alright guys, so it's time for you to solve some questions, and here I have also placed a homologous series question. As I told you, it's very important for your exam point of view this year. So let's solve it. Are you all ready? Ready, steady, po? Okay. What is the structural isomer of butane? Assertion, they have given you the structure. Reason states structural isomers have same molecular formula but they differ in the structures. I'll start a poll for you guys, okay? 30 seconds and go. Come on. Kill it off. Structural isomers have same molecular formula but differ in their structure. Assertion says following are the structural isomers of butane. And it seems you guys are killing off. Good. बहुत बढ़िया. All right. So yeah, it's option A. Absolutely fatty answer, guys. So most of you are right. Within few seconds, Regi, you killed it. Ashwini, Priya, Vanchika, Anu, everyone have given the right answer. So yeah, good job, guys. It's perfect. So answer is option A. Both of them are true, as well as the respective explanation for the given assertion is also right. Moving on to our question number 2. Write the name and formula of the second member of homologous series having a general formula of CnH2n. Careful, careful, careful. CnH2n is a general formula of alkenes, where N starts with 2. This is the first member, guys. Why I told you this is important? Because if first homologous series start with 2 carbon atom, then second member will be having 3 carbon atoms. No. You guys are giving the wrong answer here. Please check again. They are asking you for the second member. I told you before, first member of alkenes will start with N is equals to 2. Having general formula CnH2n, C2H4 will be the first member. Second member of homologous series will have the increment of 2 hydrogens and 1 carbon. N is equals to 3. So C3H2 into 3, that means C3H6. What are they asking you? Name and formula. Name will be 3 carbon alkene. It would be propene. Molecular formula C3H6. Very good. C3H6 is the right answer. And also provide the structure. Sometimes they also add up in this question and they'll ask you the structure of the compound. So structure will be C, C, C. 3 carbons. 1, 2, 3, 4, 5, 6, I think. Yeah. 5, 6, double bond. Hydrogen, hydrogen, hydrogen. 4 bonds are complete, tetravalency is complete. And for this carbon also tetravalency is complete. And voila, this is the structure of propene. Clear? Sorted. Yeah? Okay. So structure means you have to write the open bonded structure. You have to write and open each and every bond. You have to show every bond. This is how structures are corrected. Now if you just write CH3, CH double bond CH2, this is not considered as structure. You will get 0 for this. If they are asking you the structure and you're writing this, you will get 0 straight away, guys. Mind it. For structure, you have to open every bond and show each and every hydrogen here. Okay, now it's the favorite part. IUPAC nomenclature. What is IUPAC? International Union of Pure and Applied Chemistry. Okay, now imagine and ask your parents, if your name was given to you, when name was given, there was a complete ritual that might have happened. Other places or other parts of the country, there are different rituals that people follow while they are keeping a name of child. Similarly, IUPAC has made certain rules and regulations, or you can say IUPAC has created certain rituals to give a name or nomenclature to a compound, to a carbon compound. We have to follow those rules and regulations. All right, let's do it. Firstly, you always have to identify the parent chain. What is parent chain? Longest carbon chain. You have to identify the longest carbon chain here to nomenclate any compound. Secondly, once you have given the longest carbon chain number, you have to see if there is a substituent, if there is a branch, if there is a functional group. You always have to give them the priority. For example, Cl, CH2, CH3, right? So I will not start numbering from this side. I will start number from the other side because this is my functional group. So the carbon attached to the functional group will be the priority for me. So I will start numbering from this side and this will be my second carbon atom. Clear, boss? So always give priority and give the lowest number to that carbon atom which is connected with functional group or which is having the branches. Third rule, if there is any vowel, I will show you one example. You'll understand this rule if I'll show you one example. Let's do that. To write a name. Now let's say my name is Miss Rachita Sachdeva. Let's sum up all the rules in this. Miss is considered to be as a prefix. Okay? Rachita is a root word. And Sachdeva is a suffix. Suffix is what? Surname. So I have broken my name into few parts. We'll also do the same thing with organic compound. We will cut down the names into certain parts. We will divide them into certain parts. Like prefix, root word, suffix 1 plus suffix 2. What is suffix 1, suffix 2? Maybe if I put Kumari here, which I don't. If I put Kumari here, it would be my suffix 1. Sachdeva would be my suffix 2. Fine. So prefix is decided by branch. If there is any branch or alkyl group, I must say, then I will put it as a prefix. Or if there is any halo group, halo bole to fluorine, chlorine, bromine, iodine. If there are groups like halogens, I will put them as prefix. Now, root word is decided by number of carbon in parent chain or the longest chain. Like for example, if it is 1 carbon, meth. If it is 2 carbon, it, and so on. That would be my root word. Suffix 1 will be decided by the type of bond. Type of bond means if it's a single bond, in, if it's a double bond, in, if it's a triple bond, that would be I. Suffix 2 will be decided by functional group, like if it's OH, all, if it is CH double bond O, aldehyde, al, if it is COH, then it would be oic acid, and so on. So I have divided the organic name into 4 parts. Let's take an example here. You'll understand it much better. CH3, CH2, C double bond OH. First rule says that I have to find the longest carbon chain. What is my longest carbon chain? This is my functional group having a carbon chain of having a carbon of itself. Functional group itself has carbon in it, so I will give priority to this carbon. So that's my number 1 carbon. This would be number 2 for me, and this is number 3 carbon. That's the longest carbon chain. Now, is there any prefix? Is there any branch or halo group here? No. So I will not use prefix here. Prefix is not for me. So I'll remove this part. For root word, there are 3 carbons here. So root word will be decided based upon total number of carbon in parent chain. 3 carbon means prop. Plus single bond between carbon and carbon. So for suffix 1, I'll use in. There is a functional group which is carboxylic functional group, and that has a suffix named to it called as oic acid. Now, according to the rule, between suffix 1 and suffix 2, if there are 2 vowels coming together, what are vowels? A, E, I, O, U. If there are 2 vowels coming together, I will going to chuck out first suffix vowel. This is the rule. If I have 2 vowels together between suffix 1 and suffix 2, I have to leave this vowel of the first suffix. I have to chuck out that first suffix vowel. So now, after compiling all that together, that will be considered as propanoic space acid. Do not write it together. There would be a space between oic and acid. Otherwise, your 1/4 marks will be lost here. Cool? Cool, cool, cool. Clear, boss? Yeah? Two functional groups is not in your syllabus for now, but yeah, if you're going for competitive, then we have a list of functional groups and their priorities. So depending upon that, you will be numbering. You know? In your board exams, you will not going to get 2 functional group in one compound because it's not in your syllabus. Okay, clear? Chale. So on that note, let's practice few questions. They are easy peasy lemon squeezy, and I hope you can answer them quickly. Starting up with number 1. What is the name? Come on, it's your turn now. Butene. Pakka. Okay, let's take it as butene. Here's guys, 1, 2, 3, 4. Root word plus suffix 1 plus suffix 2. Root word is but. Suffix 1, because of a double bond, we have put in. There is no suffix 2. So overall, it is butene. Or you can write but1-ene. Or you can also mention 1-butene. All 3 of them are absolutely perfect. All of these 3 are correct. ठीक है ना? Yeah. All right. Next one is second one. Help of blueprints, mom class. Yeah, you can take just help, Kanish, but that's not something you should rely upon completely. Chloroethane, absolutely, it will be chloroethane. Second one is chloroethane. Perfect. Or 1-chloroethane also you can write. You can also mention 1-chloroethane. Cool. Third one. Now, OH is the functional group. Connecting carbon will be the first carbon. This is the longest carbon chain. Prefix plus root word plus suffix 1 plus suffix 2. There is no prefix. Root word consists of 4 carbon atom but. Suffix 1, single bond between every carbon ane, and all for alcoholic group. 2 vowels are there. I have to remove the vowel for the first suffix. Overall, it will be butanol. Yes, perfect. Good job, guys. Very well done. Nicely done. Last one. Come on, kill it off. Last one. Yeah? Propanol? Pakka propanol. Yes, it is propanol. Perfect. Fourth one, aldehyde group. So we'll use al as a suffix too. 3 carbons are there. Prop with single bond in between ane, and al for aldehyde group. So yes, it is called as propanol, not propanol. Don't pronounce it as propanol. It's propanol. So yes, good job, guys. Well done. Congratulations. Those who have given complete, full answers. 4 marks. How many of you got 4 marks here? Sachi Sachi. Be honest. How many of you have given all correct answers? Areva. Good. Nice, nice, nice. Me. Kya baat hai? Good. 4 out of 4. Not bad. Alright guys, now moving on to chemical lotas of carbon. What happens if carbon compounds react with other elements? What type of reaction does carbon compound participates in? Starting up with number 1. Carbon compounds, hydrocarbons participates in combustion. Combustion is like aag laga denge types. So we burn it in presence of oxygen. That's combustion reaction. Second, it participates in oxidation. Thirdly, addition reaction. Fourth, the substitution reaction. Now, what is important here? Oxidizing agent in oxidation is important. Addition and substitution difference is important for you guys. For exam point of view. So, starting up with combustion. One of you have asked me a question, Abhi, that what happened if hydrocarbon is burnt incompletely. So, there are 2 types of combustion that takes place. Firstly, combustion takes place in presence of oxygen, and that could result into a formation of carbon dioxide in water. If it is the complete combustion means you're providing sufficient amount of oxygen. If sufficient amount of oxygen is given, the product form will be carbon dioxide and water. But if it's incomplete combustion, incomplete means if you're providing insufficient amount of oxygen, that would result into the formation of carbon monoxide and water. And please mind it guys, carbon monoxide is considered to be as one of the silent poisoner. It is silent because you cannot smell it, you cannot see it, but yet it will going to affect your body slowly and gradually, and it can even lead to death. So be careful with such kind of gases. Alright, so as I told you, if combustion is happening of methane, like CH4 is being combusted, that will, the beauty of combustion reaction is that always end up giving you same product, which is carbon dioxide, water, heat and light. So it will be exothermic reaction. Combustion reactions are exothermic reactions. Cool? Cool. Okay, so what is the basic difference between complete and incomplete combustion? As I told you, if you provide sufficient amount of oxygen, complete. If you provide insufficient amount of oxygen, incomplete. Then in complete combustion, you will always get carbon dioxide and water, whereas in incomplete, carbon monoxide and water. In case of flame, clean flame will be given in case of complete combustion. Now, if you see a flamer in your kitchen, sometimes we see a yellow flame. or a sooty flame. Because of that, a complete vessel turns black in color. Why are vessels in kitchen turns black in color? Maybe because we are providing them insufficient amount of oxygen. So that gives you sooty flame, means black. It will be yellow in flame with black color of carbon coming out. That's a sooty flame. Smoke produced in case of incomplete combustion, but no smoke will be produced in case of complete combustion. That would be a completely clean blue flame. Now, under oxidation, it is very important because of these oxidizing agent. Now, please mind it, guys, as we are doing oxidation of organic compounds of hydrocarbon, that happens in a presence of a very specific oxidizing agent. Either you can write acidified potassium dichromate or alkaline KMNO4, where alcohols will be converted into carboxylic acid. Like ethanol will be converted into ethanoic acid. Okay, like CH3, CH2OH in presence of acidified K2Cr2O7 or alkaline KMNO4, that results into formation of CH3 COOH. Ethanol converts to ethanoic acid. Propanol converts to propanoic acid. Number of carbons will remain same in reactant and product. Butanol converts to butanoic acid. That happens on oxidation in presence of the oxidizing agent, which is quite specific. Now, talking about third type of chemical property, which is addition reaction. Please make sure you remember these pointers. Addition reaction can only take place in unsaturated hydrocarbon. Please make a point here. It happens only in case of unsaturated hydrocarbon. Secondly, it requires catalyst. What is catalyst? The one which alters the rate of reaction. It could increase the rate of reaction here. Right? Thirdly, it has the ability to convert unsaturated hydrocarbon to saturated hydrocarbon. From this addition reaction, we can actually convert double or triple bond into single bond. That's the powerful things, guys. We are converting one type of hydrocarbon into another type of hydrocarbon by the help of addition reaction. For example, let's see an example here. CH double bond CH. Okay? Now, addition reaction. If hydrogen has been added, it is called as hydrogenation reaction. If hydrogen is added here, it's called as hydrogenation reaction. Hydrogenation itself means addition of hydrogen. Now, can I write H2 as this? Yes, I can write. Now, it will always take place in presence of a catalyst. Nickel will be taken in presence of heat. I will heat this. What will happen? Hydrogen gas bond will be broken. One of the bond will be broken between ethene. One of the hydrogen will be added to one carbon atom. Other hydrogen will be added to other carbon atom. So what compound will it make? It will make CH3 single bond carbon CH3. So ethene has converted to ethane by a process of hydrogenation or addition reaction. Is that clear to all of you? Yeah, sorted. Give me a thumbs up in chat box. Vegetable or animal? See, no, vegetable ghee is not good because it's dalda. Animal ghee is good. Yeah. Okay. All right. All right, guys. So this is a simple way to learn reaction where ethene turns to ethane, propene turns to propane, butene can be turned to butane, and so on. So this can happen only in presence of addition reaction, presence of catalyst, and you have to provide some heat. Now, your fourth chemical property of carbon compound is substitution reaction. Now, there are pointers again that you need to remember. first point, that is only given by saturated hydrocarbon. Saturated hydrocarbon means it is only given by alkanes where carbon and carbon have a single bond. First thing. Second, substitution reaction always takes place in presence of sunlight. It requires a condition of sunlight here. Thirdly, it is a stepwise reaction. It is a chain reaction. It goes on and on and on. You can stop that in between, but it's a stepwise reaction. So let's have a look on one of the example. Let's say CH4 is reacted with chlorine in presence of sunlight. What does substitution means? Guys, you know this better than anyone else. Children know this very well. Like, let's say your chemistry period has been substituted by games period. Lucky, huh? If your chemistry teacher is absent, you will get a games period. So what will happen? A teacher is absent and other teacher has taken up place of that particular primary teacher. So chlorine will be substituting hydrogen from methane, taking its position, and that will going to form CH3Cl plus. This H will go with another Cl and form HCl. Second step, it will go on and on. Now it is CH3Cl reacting with another Cl2 in presence of sunlight. This will break. Other Cl will going to replace another H. That results into formation of CH2Cl2 plus HCl. Third step, one more Cl will going to be replacing another H. So it will go till the time all the hydrogens will be substituted, and that will give you CHCl3 plus HCl. And guys, this is none other than behosh karne ki dawa. That's chloroform. Used for medical purposes, used in movies also. So yeah, it is none other than chloroform. Yes, yes, yes. UV light is also possible. Yeah, yeah, Lakshmana. Yep. UV also will do instead of sunlight. UV can be written. All right. Okay, Bacha Party. So this will go another step till it going to create CCl4. So last will be CCl4, which is called to be as carbon tetrachloride. So that's all about substitution reaction. Now the most favorite topic of you guys is ethanol. I don't know, but you guys take a lot of interest in ethanol. Oh, that's so sweet. Okay. So, what is ethanol? Ethanol is a consumable alcohol. Yes, it is alcohol. Having OH group, it is having OH group. Formula is C2H5OH and its common name is ethyl alcohol. Now, there are different types of alcohol available in market. One is rectified spirit. Now, 1 mark question lands up from these 3 points. So, please make sure that you learn them. Rectified spirit, absolute alcohol, and it is denatured alcohol. The most important one is denatured. It has asked you so many times in your previous year question papers. What is rectified spirit? Ethanol with 5% of water. It is also used for commercial purpose, so for drinking alcohol. Rectified spirit is used. 100% pure ethanol called absolute alcohol, and denatured cannot be consumed. Can never be consumed. So I'll give you one simple story. I'll tell you a story which is a real story actually. You might have read in newspapers, like in villages, mass people have got sick because of consuming alcohol. So many people have died after consuming alcohol. Have you heard such kind of stories in newspaper? That's a reality, guys. I'm telling you a real thing. Yeah? You have heard, है ना? So why is that so? Once they supply alcohol to villages, they try to cut down the money, and to save money or to get more profit, what they do, they mix small amount of methanol in ethanol. Methanol is poisonous. One of you have asked me a question, what does methanol do in our body? So methanol coagulates the organs. Coagulates means they will going to shrink the organs, and because of that our body organs will start failing, and it eventually leads to death, or it also causes permanent blindness as well, guys. So it's very, very harmful and it's not consumable. So methanol is added to ethanol because to avoid misuse of alcohol actually. So government has passed this thing that whatever alcohol is being given to your school or in other institution and colleges, it has to be mixed with some amount of methanol so that people will not consume it. Misuse can be stopped for ethanol. So that's the reason they are starting adding little bit amount of methanol to make it unconsumable. So that is all about types of ethanol. Now, as properties of ethanol comes into picture, you're all aware about it's colorless. It has a pleasant odor. See, pleasant can be for some people. For some people, it is yuck. So ethanol is volatile, means it evaporates. It's flammable, colorless liquid with the pleasant odor. They are produced by the fermentation of sugars by yeast, like fermentation of grapes I told you, which turn into wine, and wine is nothing less than alcohol. Ethanol is commonly used alcohol for alcoholic drinks as one of the ingredient commercially used, and it is also soluble in water in all proportion. It's even soluble in soda, da. It will definitely be soluble in water in any proportion. So yes, ethanol is soluble in water. Now talking about uses, how many of you feel dizzy after having cough syrups? Huh? How many of you feel dizzy after having cough syrup? Most of us, right? Because in cough syrups they put little bit amount of alcohol, and that's the reason it makes us feel little dizzy. Perfumes also have alcohols. In fact, nowadays you are using sanitizers, they also have alcohol. Perfumes have alcohol. Dyes, varnishes, paints, tinctures are also having alcohol in them in some amount. Now, okay. All right, guys. Shall we? Let's move on. Yes, tincture of iodine rush. You got it right. Absolutely. Ready? Ready for chemical properties? Ready for chemical reactions? Because one of you have told me, ma'am, I got confused in chemical reactions. So practice as much as you can. Write and learn. Write and learn. Thinner for paints. Yes, Prem Kumar. Got it. Yes, right. It's a covalent one. Yes, Lakshmana, you got it right. It's not a hydrocarbon. It's not made up of hydrogen and carbon, but it's a derivative of hydrocarbon. It's making a covalent bond. All right, starting up with what are the reactions that ethanol give. Ethanol can react with metal. Yes, it can react with sodium, specifically CH3, CH2OH plus sodium. Now we all know that sodium is more reactive than hydrogen, so it can displace hydrogen, and what? It will form CH3, CH2ON is sodium ethoxide plus hydrogen gas will be evolved. Simple. That can be learned. Sodium displaces hydrogen, takes its position, forms sodium ethoxide. I'll write it for you. Sodium ethoxide and hydrogen gas will be evolved. Yeah. Second, it can also give reaction to give unsaturated hydrocarbons. So alcohol can be converted into a double bond unsaturated hydrocarbon also. How come? Let me tell you. CH3, CH2, OH. Can I write ethanol this way? Can I write the structure of ethanol this way? Is it right? Give me a thumbs up in chat box if you all agree. I can write, right? This is ethanol. Now, in presence of concentrated sulfuric acid H2SO4, heating it at 170 degrees Celsius, this concentrated sulfuric acid is behaving as dehydrating agent. Another question for your exam. What is the purpose of concentrated sulfuric acid here? It is acting as a dehydrating agent, means it will remove water molecules from within alcohol. It will break the bonds, take out water and make a new substance. So HOH, this will be removed. What is removed? HOH, which is water. Plus, what is left here? CH2 is left now. I'll write this as such. CH2 is left. Is this stable? No, it's not stable. It will be stable if I put double bond here. And done. It was ethanol converted to ethene after dehydration. Dehydration means removal of water. And this is what? This is H2 only. Da? Dehydrating agent helps to remove water. Easy to remember, eliminates water. Perfect. Yeah, easy to remember these reactions now. So that was all about ethanol. Now moving on to ethanoic acid. What is ethanoic acid? Do you use ethanoic acid at home? Yes, yes. Lakshmana, yes. So where do we use ethanoic acid at home? Do you like chow mein? Do you like Manchurian fried rice? Or any Chinese food which consists of, or where we use ingredient as vinegar and few drops, which give sour taste, khatta wala taste, right? So vinegar is made from ethanoic acid in a diluted form. If you dilute ethanoic acid a lot, that will turn into vinegar, which we consume in our day-to-day life. Ethanoic acid is commonly called as acetic acid, having a carboxylic group, which is C double bond OH. If I make a structure, it would be CH3 C double bond OH. That's ethanoic acid. Yeah. Ethanoic acid is also called as glacial acetic acid. So they can ask you a question for 1 mark. Define what is glacial acetic acid. So what will you write? When acetic acid is brought to a lower temperature, around 290 Kelvin, it freezes during cold climate and it looks like a glacier. Therefore, we also call pure acetic acid or pure ethanoic acid as glacial acetic acid. It is only for pure form of ethanoic acid, which is also called as glacial acetic acid. But acetic acid or ethanoic acid, if it's mixed with water, 5 to 8% of solution of acetic acid in water. That means if I take 5% of CH3COH and 95% of water, that will going to give me vinegar, guys. Can you imagine? Now, have you ever opened a bottle of vinegar and smelled it? Tell me honestly, have you ever opened a bottle of vinegar and smelled it? How harsh, how strong that smell is. Even you have diluted it to certain extent, 95% of water, 5% of ethanoic acid, it's still very sour. It's very khatta in taste. It is having a very strong smell. Now imagine pure 100% ethanoic acid. Oof. 100% pure ethanoic acid will be hard to smell, hard to taste. It would be highly corrosive to us. So I hope now you understand the acids, though it's a weak acid, but it's not weak for our body. It is weak, but not for human body. Yeah, apple cider vinegar, it's a mix. It is having vinegar, but it is a mixture of other acid also. Kunal. But it's good for health. And that should not be consumed in large amount, Kunal, because that also harms your body after a certain period of time. Okay, guys, moving on to again some of the chemical lotus and properties of ethanoic acid, which is esterification reaction. Guys, if you have done previous year question papers, you already have an idea how esterification reaction important for exam point of view, because every year, literally every year, they are asking questions from esterification. In fact, if you have solved sample paper 1 and sample paper 2 released by CBSE, they have given esterification reaction in both of them. So please be mindful and do not miss anything from this chapter. Esterification means what? See, we have learned about ethanol, we have learned about ethanoic acid, but what if we mix both of them together? So when ethanol is mixed with ethanoic acid, that results into formation of ester formation, which is a fruity smelling product. For example, like I'll show you a complete reaction. This is ethanoic acid, CH2, CH3, है ना? CH3, CH2H, this is ethanol. So I've just changed the position. Rest everything is same. This is ethanol, this is ethanoic acid. Now let's say I remove water from here, है ना? So water will be out, H2O. Now what is left? CH3CO, CH3, C double bond O, है ना? C double bond O, O, CH2, CH3, CH2, CH3. It is called as ethyl ethanoate. All right, plus water, ethyl ethanoate. And this is a fruity smelling product, which is ester, used for bakery items, even used for fruity perfumes, which I don't like. So yeah, they are also used for perfumes. Absolutely viral zone. Yes, just be positive. So this is all about esterification reaction. Now with base, obviously being ethanoic acid, acid can easily react with base. So let's take a look on this reaction. Ethanoic acid CH3, C double bond OH reacts with NaOH. So what will be formed? Come on guys, do let me know the product. Na will be taken on the position of H, that would be CH3, C double bond O, Na plus H2O. Sodium ethanoate. Yeah, sodium ethanoate. Absolutely. Is pure ethanoic acid harmful? Yes, yes, Divya, it is. It is. Pure ethanol, pure ethanoic acid, you cannot consume anything in pure form. Though it's a weak acid or a weak base, you cannot consume. Okay. All right, moving on to third chemical property, third chemical reaction with carbonates and bicarbonates. So tell me one thing. Will ethanoic acid show reaction with carbonates and bicarbonates? If yes, why? Why? Can ethanoic acid CH3, C double bond OH show reaction with any metal carbonates or bicarbonate? Let's say NaHCO3. Yes, it will show. Why it will show? Why? What is the reason? Why not ethanol shows this reaction? Ethanol will not give reaction. Why? Now, see, it's a basic substance. As I told you, basic substance will always love to react with the acid and give salt and water and carbon dioxide in this case. If you remember, you have learned a general reaction. If acid reacts with metal carbonate or bicarbonate, that will give you a formation of salt, carbon dioxide and water. This is a general reaction you've already learned today. So what will happen? Na will take a position of hydrogen, that gives you CH3COONA. Along with that, it will give you water and carbon dioxide as the byproduct. But ethanol cannot give reaction with metal carbonates or bicarbonate, because ethanol itself is neutral in nature. Ethanol is neither acidic nor basic. So it will not going to produce H plus or hydroxide ions. So being neutral in nature, it will not going to react with as a basic substance here. Cool? Clear? Okay. So this is one question that can be made up in your paper. How will you chemically differentiate between ethanoic acid and ethanol? So by this reaction, you can differentiate chemically between ethanol and ethanoic acid. I hope you all are ready to solve some questions, solve some chemical locha. Yes, Chagde Fateh? Are you all ready? Yeah? All right. So it seems you guys are born ready. Let's solve the question. Question number 1 on screen. The formula for organic compounds are given below: C2H4, CH3COH, C2H5OH, C2H6. Which of these compound A, B, C, D is saturated hydrocarbon? Saturated hydrocarbon. I will come to saponification, don't worry. It's a polymer, Lakshmana, that comes in your JEE NEET part. Okay. Which one of them is saturated? Saturated means single bond between carbon and carbon, means we are talking about alkanes. That means the one which follows CnH2n plus 2. So does this follow CnH2n plus 2? No. Is it no, it's having a functional group. It's a derivative of hydrocarbon. No, it is also derivative of hydrocarbon. What is left is C2H6. So D is the one which is saturated hydrocarbon. That one compound which is saturated is D, which is C2H6, following alkane CnH2n plus 2 general formula. Identify the organic acid and give its structural formula. Come on, guys, you can do it. It's a simple one. Identify organic acid. Organic acid is only one here, which is B. That's CH3COOH. Give it structural formula. What is structural formula? Open all the bonds and show. CH3, C double bond OOH. Cool? Yes, B. Perfect. Third, which of the above compound, when heated at 443 Kelvin, in the presence of concentrated H2SO4, forms ethene as the major product? Major means the one which is in larger quantity. What is the role played by concentrated sulfuric acid in this reaction? And write the chemical equation involved. This is a previous year question, guys. I've picked this from a previous year question paper. Can you guess that? Yes, it is ethanol. It is ethanol. Absolutely right. So the above compound, when heated at 443, 170 degrees Celsius, is none other than C2H5OH in presence of concentrated sulfuric acid. That gives ethene, which is CH2 double bond CH2 plus water. This is your major product. What's the major product here? Which is ethene. And 170 degrees Celsius or 443 Kelvin you can write. And what is the use of concentrated sulfuric acid? Come on, just one word and you will get full marks. What is the role played by concentrated sulfuric acid here? Priya, high five, good job. You'll get full marks for that. So yes, it is dehydrating agent. The role played by concentrated sulfuric acid here is dehydrating agent. Cool. I think sorted, boss. Yeah? Okay. Good. Moving on to our next question. Number 2. Name the gas evolves when ethanoic acid is added with sodium carbonate. How would you prove the presence of this gas? Easy peasy lemon squeezy. Read the question carefully. I'm not giving answer this time. You are the ones giving me answer. Come on, come on, come on. Yes, it is carbon dioxide. Good. Gas evolved in ethanoic acid. Name the gas. So you have to name it, okay? Complete name. Carbon dioxide. In bracket, you can definitely write the formula. How will you prove the presence of this gas? Extinguishes fire, turns lime water milky. Kunal, very good. It either turns lime water milky, it extinguishes fire. Thirdly, we identify by its brisk effluences. Brisk effluences will be produced if carbon dioxide gas is evolved. Yeah, lime water test. Done. So for that, you will get 2 marks. How many of you got 2 marks? How many of you got 2 marks here? Full. Fata performance. Huh? Which of the following functional group is present in CH3COH organic acid? Let's start a poll here. Let's start a poll. A, B, C, D. 30 seconds starts now. Question number 3. Which of the following functional group will be there in CH3COOH organic compound? All right, it seems you guys are coming up with the right answer. And yes, it is none other than option D. It's carboxylic acid. 100% of you are perfect. Well done, Parpriya, Rush, Adiba, Vanchaka, Kunal, Forever 7, Vaibhav, Divya, Harshit, Venkatesh. Perfect. Good job. All right, guys. So one of you have asked me a question, ma'am. Please tell us the difference between soaps and detergents. And now here we are on a very last topic of soaps and detergents. So yes, how are you feeling, guys? We are at the end of this session at the last topic of today's marathon. So many of you were sitting with me since afternoon. And I'm really proud of you guys. Again, I would say the same thing. We are very close towards our victory line. We are very close towards our exam. It's not the time we give up. It's time for us to make us proud, us our parents proud. Imagine a day when you see yourself in paper. State topper. So and so. How will that feel? Amazing. That would be the fantastic feeling. You will feel like, oh, I have just conquered the world. Yeah, I'm telling you, that's an amazing feeling. Break, no break. Bas, ab no break. Last, we'll do this. And then I'll give you full break. Go and have your dinner. Enjoy. Be satisfied that you've completed chemistry portion. And you'll be very proud of yourself later. Diluted, yes, it's very diluted, Divya. 95% of water and 5% of vinegar, acetic acid in that, Divya. Yes, yes, Kunal. Chale? Okay. So let's start. Let's begin with soaps and detergents. Now, there are two kind of questions that come in your paper from this particular part. One, micelle formation. Second question that is asked is related to why detergents are better cleansing agent than soap. These are the two most important questions. Third question that can be asked to differentiate between soaps and detergent, right? Starting up with what are actually soaps. Soaps are basically the long chain fatty acids of sodium and potassium salt. So potassium and sodium salt of long chain fatty acids are called as soap. One of the very basic example is sodium stearate, which is C17H35CO minus Na plus. Now this is not in your NCRT. Please do not take so much stress that you have to learn it. You have to write it in your paper. If you remember it correctly, do mention it. If you do not remember, no marks will be cut for you. So please do not stress yourself. Bevajah. Okay. Now after you know what is soap. How soaps are formed. Formation of soap is called as saponification reaction, which is actually the opposite of that of esterification reaction. So let me recall this part for you. In esterification reaction, you have seen that when alcohol and acid will be combined together, when ethanol and ethanoic acid will be combined together, that results into formation of ester. Whereas in saponification reaction, we are going to use ester, react with alkali, aqueous form of ester, or hydrolysis of ester. Hydrolysis means we are adding ester with water. Along with that, we are putting a very strong alkali like NaOH or KOH, and that results into formation of product, which is sodium salt of carboxylic acid and ethanol. This reaction is called saponification reaction. It's important. Same as esterification, they can ask you saponification also. Now, as soaps, as we are talking about soap, there is a proper structure of soap which we call it as micelle formation. This is where you get question from for 2 marks. What is micelle formation? How micelle formation takes place? What is the entire mechanism of micelle formation? So for that, you have to understand about soap molecule. Now, soap molecule, as I told you, let's take an example. C17H35 COO minus Na plus. It's a sodium salt of carboxylic acid. This is one of the example of soap called as sodium stearate. One of the example of soap called as sodium stearate. Now, imagine this as the ionic head. And this hydrocarbon chain C17H35 will be placed as the hydrocarbon chain here. So it looks like a structure of a tadpole, or it looks like a structure of a sperm which has a tail and a head. Head is the ionic part, tail is the hydrocarbon chain. Hydrocarbon chain is actually the tail part. Now, tail is hydrophobic. Phobia. Phobic means one which is scared of water. Hydro means water. So the one which do not like water, which scares from water, is the tail part. Whereas ionic head is water loving, or in other word, it is called as hydrophilic. Now, soap molecules get a cluster. It will create a cluster. Cluster means group of molecules of soap will going to make a micelle, a cluster-like formation, and that is when we call it as a micelle formation. So, how will they come up? They will be having tail in the interior side and heads, or the ionic heads, on the posterior side. Like this, they will going to create a cluster of soap molecules, and this complete cluster is called as micelle formation. Chale, Atmanirbhar Janta. Atmanirbhar Janta, I hope you guys wash your clothes. You might have washed it one time or the other. So, what we do? We put a soap solution in a bucket. We'll put water in it. And we'll put a dirty cloth in water. Let's imagine. As we put a dirty cloth in water, we agitate. We try to clean the dirt part. As we are agitating, what will happen? In between, there is a dirt molecule. In between the soap molecules, there is a dirt attached to it. So, all soap molecules will go towards that dirt, try to pick it out, try to scratch it out, and these heads, which are water loving, they will stay inside water. So what will happen once you agitate? These tails will bring out dirt, and these tails are connected to water loving part. So they will all remain into water along with the dirt, and what you bring out is the clean cloth. So that cloth will be clean after these clusters of soap molecule will take out this dirt from it, will be suspended in a in that particular water. So that water becomes dirty, water becomes cloudy, it becomes a colloidal solution. But the magical part is that cloth will come out to be clean from that dirty water. This is how mechanism of micelles work. I hope it is clear. Yeah, clear? All right. So that's all about micelle formation. So soap in form of micelle able to clean, remove the oily dirt part collected in the center of the micelle. So it's a dirty part which is collected in the center of micelle. Micelle stays in the solution. So once the dirt has been taken out, these all micelle formation will remain in the water, make a colloid. It will make that water dirty. It will be a colloidal solution where light can be scattered. You all know what is colloidal solution. You have learned this in grade 9. So thus dirt suspended in the micelles are easily rinsed away, and soap micelles which are large enough to scatter light and soap solution appears to be cloudy. That solution of soap becomes dirty and clothes comes out to be very, very clean. But problem is there are two types of water. One is hard water and other is soft water. Now in most of the places it's hard water because of water pollution and so much of dirt. We are getting hard water nowadays. Soft water is present in very few places now. So let me give you one example. You might relate with it. Your grandparents must be scolding you for using many products for your hairs. You are using shampoo, you're using conditioner, you're using body shower and all that stuff. And your grandparents might be scolding you, oh, in my time, we are not supposed to use so many products. In our time, we to wash our clothes with washing that kapde dhone wala sabun. I hope you might have heard. In your time, you guys have so much of tantrum. You spend a lot on these kind of products, right? You might have heard some things from your grandparents. So the problem is, in their time, they used to get soft water. Soft water is a good cleansing agent for soaps. Whereas hard water does not go well with soap. Soap cannot clean well with hard water. This is where your another question lies up. Question asks why detergent is a better cleansing agent than soap. So what happened? In hard water, we have calcium and magnesium ions present in them. Whereas in soft water, we do not have any presence of calcium and magnesium ions. So if you put soap into hard water, the ionic head will going to be reacted with these ions. The ionic head of soap molecules will react with these calcium and magnesium ions of hard water and create a precipitate which we call it as scum. Some of you might have observed on black clothes we get white spots even after washing. Have you observed ever? Have you seen? Even after washing, your black clothes have some amount of white spots on it. It does not give that better cleansing property. Even you have washed it from detergent, even you have washed it properly, they have those black spots on it. So it is called as scum. Scum is the precipitate which settles because of the hard water presence. So soaps cannot work effectively in hard water because they produce scum which is insoluble precipitate. And how insoluble precipitate is formed? When the ionic head of soap will react with calcium and magnesium ions of hard water. But the good part here is that detergents work very well with hard water and soft water. Detergents have no problem with calcium and magnesium ions present in hard water. Detergents will not react with calcium and magnesium ions of hard water, so it will not going to prepare any kind of scum or any kind of insoluble precipitate, and that's why it is considered to be as one of the best cleansing agent. So detergent is a better cleansing agent over soap. Now, what are detergents? They are sodium salt of sulfonic acid or ammonium salts. So these ionic head, sulfonic part, ammonium part does not react with calcium and magnesium ions of hard water. So they do not precipitate out. They do not create insoluble stuff or scum. So it's good to go with hard water also, and it shows a good property with soft water also. Now, the problem here is the one biggest problem of our earth, that detergents are not biodegradable. That's ouch. That's hurtful, guys. Detergents are non-biodegradable. Detergents are there in shampoos also. Detergents are there, what you're washing your clothes using detergents. So detergents is everywhere. The problem is it's getting collected on our earth without getting decomposed, without getting degraded. So imagine the amount of pollution we guys are doing knowingly or unknowingly. Whereas soap is biodegradable, but it's not good for cleansing hard water. Clear, boss? I hope that is clear. So anyone who become a scientist, please find out a solution for detergents, alternative solution for detergents, okay? You will be blessed. Yes, check their birthday, football stars. Yeah, we use detergents now. Ajaz, we are using detergents now, not soaps. Okay. Now, what is the basic difference between soaps and detergents? It comes for 2 marks in your paper. Soaps are sodium salt of carboxylic acid, whereas they are sodium sulfonate group. Detergents not suitable for washing in hard water, whereas detergents are suitable in both hard and soft water. Detergent for soaps, they are relatively a weak cleansing agent, whereas detergents are a good and a strong cleansing agent. Detergents are non-biodegradable, whereas soaps are biodegradable. This is a basic difference between soaps and detergents. So, how are you feeling, guys? We have came to the end finally. Congratulations. You have completed the entire chemistry in one go. And I can assure you, after going through this entire marathon, you don't need to go through your NCRTs, because we have done each and every part, each and every concept of your chemistry portion of all 4 chapters. So if you go through this entirely one more time, 2x, 3x speed, just revise it one more time and you are done and dusted. In fact, we have also solved many important questions in between, so you can solve that as well. Last homework question, write the formula and draw the electron dot structure of CCl4, which is carbon tetrachloride. And yeah, as I always told you guys, you are so close to the victory. Don't you dare to give up right now. Do not get tired. It's time for you to focus. Whatever you have done for the entire year, now it's the time for you to show off what you can do, what you can achieve. So do not dare to give up. That was it from my side, guys. It was lovely meeting you all for the first time live. I hope we'll be meeting soon. So, thank you. That was it. This is me, Rajta Sachdeva, signing off. Take care. Stay safe. Stay happy always. And be milenge chalde. Bye, guys. Take care. Thank you. Thank you, Adiba. Thank you so much.